Pasok-sok. Kung dati na sok-sok. Ayun.
Maratang ka lang.
Pakita ba yun?
Wala yung patawag na sa woods. Sa woods.
Pero,
the Institute of Integrated Electrical Engineers of the Philippines Incorporated, IIE, is thrilled to invite every electrical practitioner and innovation enthusiast to the biggest gathering of electrical, energy, and electronics sectors. 3E Expo is the IIE's premier event showcasing the transformative power of innovative products and services from industry-leading companies. 3E Expo expects to gather 200 leading companies to unveil their latest breakthroughs and solutions. This 3E Expo will put a spotlight on cutting-edge technologies by featuring renewable energy solutions and display of electrical vehicles. 3E Expo is poised to be a catalyst for endless possibilities and new ideas. The 3E Expo will certainly be a venue of unparalleled networking possibilities, as IIEE expects more than 15,000 trade visitors. 3E Expo is not just an exhibition. 3E Expo is a journey into the future. Together, let us all witness revolutionary designs and technological solutions that will shape the world as we know it. So what are you waiting for? Mark your calendar and visit the IIE 3E Expo.
Convention Center Manila. Your safety is our top priority. And for us to accomplish this, it is essential that you are familiar with our security and emergency procedures. For your safety and security, everyone entering the facility is subject to body frisking and bag inspection. All vehicles are inspected prior to entering the parking area. The facility is also equipped with CCTV cameras. For emergency situations, kindly take note of this safety procedures. In case of fire or earthquake, do not use the elevators and escalators. Instead, use the safest way, using the fire exit stairway. There are fire extinguishers and fire hose cabinets located within the facility. The medical clinic is located at the south mezzanine level near the administration office. When trapped in an elevator, press the emergency call button for your rescue. SMX Convention Center Manila is equipped with a fire alarm system that automatically activates during emergency situations. When you hear the alarm, please be alert. During an earthquake, perform drop, cover, and hold. When you hear the continuous alarm, please immediately evacuate the floor by using the exit door nearest you. There are emergency exit doors out of the facility. From the basement, you can exit using the car park entrances located at the south and north sides. You can also use the stairway in the middle of the basement area. From the ground level, you can use the exit doors located inside the halls or the roll-up doors. You may also use the hall entrance doors. For the mezzanine level, you can exit using the stairway located at the south and north sides. You can also use the bridgeways leading to Conrad Manila or the mall, located at the north side, or the bridgeway leading to the hotel at the south side mezzanine level. From the second level, you can use the emergency exit doors of the function rooms, located at the back alley leading to 3 stairways. You can also exit using the function room entrance doors leading to 2 more stairways. Our security and evacuation team will direct you to the assembly area, located at Coral Way beside the facility. Please do not try to re-enter the facility until instructed it is safe to do so. At SMX Convention Center Manila, your safety is always our utmost priority. On behalf of the management, we wish you a most successful and safe event.
The Institute of Integrated Electrical Engineers of the Philippines, Incorporated, IIE, is thrilled to invite every electrical practitioner and innovation enthusiast to the biggest gathering of electrical, energy, and electronics sectors. 3E Expo is the IIE's premier event showcasing the transformative power of innovative products and services from industry-leading companies. 3E Expo expects to gather 200 leading companies to unveil their latest breakthroughs and solutions. This year's 3E Expo will put a spotlight on cutting-edge technologies by featuring renewable energy solutions and display of electrical vehicles. 3E Expo is poised to be a catalyst for endless possibilities and new ideas. The 3E Expo will certainly be a venue of unparalleled networking possibilities, as IIEE expects more than 15,000 trade visitors. 3E Expo is not just an exhibition. 3E Expo is a journey into the future. Together, let us all witness revolutionary designs and technological solutions that will shape the world as we know it. So what are you waiting for? Mark your calendar and visit the IIE 3E Expo.
IIEE is celebrating its 5th decade. From the spark of vision of the IIEE's founding fathers to have an organization for the Filipino licensed electrical practitioners. We are now celebrating the 50th Annual National Convention and 3E Expo 2025. Driven by the 4 core pillars that defined us: integrity, innovation, empowerment, and excellence. We would like to invite all IIE members to witness the next wave of innovation for the electrical engineering industry. The 50th Annual National Convention and 3E Expo 2025 will be held at SMX Manila on November.
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you, and have a good day ahead.
This year, the Institute of Integrated Electrical Engineers of the Philippines Incorporated celebrates half a century of its commitment to integrity, innovation, empowerment, and excellence. We come to witness how IIEE evolves. 3E Expo as the IIEE's biggest product exhibition to converge the 3Es, electrical, electronics, and energy sectors in one grand venue showcasing the latest trends, products, and services of the participating companies from local and abroad. As the Vice President for External Affairs, and on behalf of the Exhibit Bureau for the 58 years of IIEE, I take pride in saying that the 3E Expo is a testament of progress to electrical engineering innovation and transformation. For this year, 3E Expo 2025, in line with the IIEE's celebration of its golden year, we recognize the transformative potential of artificial intelligence in shaping the future landscape of the electrical engineering industry. Come and witness the limitless possibilities of the electrical engineering industry with AI and other exciting activities that the participating exhibitors have prepared. Visit the 3E Expo 2025 that will be open to the public on November 26 to 29, 2025 at SMX Manila, Pasay City. See you there.
Welcome to the Institute of Integrated Electrical Engineers of the Philippines. a professional organization of electrical practitioners founded in 1975 with the core values of integrity, innovation, empowerment, and excellence. For 50 years now, IIEE has been a cornerstone in advancing the electrical engineering profession, fostering leadership and growth within the dynamic industry.
This year's annual convention is especially meaningful as we inch closer to the historic milestone, IIEE founding anniversary. We are not just merely commemorating the anniversary of IIEE. We are traversing the pages of history to write the remarkable story of our institute. To my fellow electrical practitioners, join us.
On behalf of the Council of National Presidents, we would like to invite all of you to our 50th Annual Convention and 3D Expo on November 26 to 29, 2025 at SMX Convention Center, Pasay City.
This year, we gather at SMX Manila, a space that perfectly blends innovation and excellence to host our 50th Annual National Convention. An event that will bring together experts, leaders, and practitioners to explore the latest trends and advancements in electrical engineering. Behind the scenes, our dedicated committee members work tirelessly, ensuring that every session and discussion is impactful, providing valuable insights to attendees. Our seamless registration process to efficient kit distribution ensures that all our attendees are ready to experience the full scope of our event, from intuitive technical sessions to exciting networking opportunities. Our technical sessions cover the most innovative topics in our event, where experts present cutting-edge knowledge, experience, and research, empowering our community with the latest trends in electrical engineering. We believe in the importance of balance with a healthy mind and body. So, alongside intellectual stimulation, we offer sports activities to foster teamwork and healthy competition among our members. Our exhibit areas are buzzing with innovation as leading companies showcase groundbreaking technologies and solutions that are shaping the future of electrical engineering industry.
3E Expo as the IIE's biggest product exhibition to converge the 3Es, electrical, electronics, and energy sectors in one grand venue showcasing the latest trends, products, and services of the participating companies from local and abroad.
The Golden Pavilion is a special highlight of our event where we celebrate the outstanding achievements and contributions of our members and partners. We are proud to present our showcase of electric vehicles, an inspiring glimpse into the future of sustainable transportation and energy. Our B2B Dinner and Exhibitors Night is a relaxation event that brings together leaders and industry partners to build valuable relationship for networking and potential collaborations. And of course, what would an event be without a bit of excitement? Our raffle draws bring a thrill to our attendees with fantastic prizes up for grabs.
We are bringing 2 vehicles for our fabulous prizes during raffle draw.
At IIEE, we also celebrate the involvement of our regional chapters, acknowledging their dedication and contribution to the growth of our profession.
Join us as we mark our half-a-century milestone, remarkable innovation, progress, and contributions to the field of electrical engineering. We will celebrate engineers who have shaped the world with their expertise and vision. And we invite you to be a part of this unforgettable event, where we will reflect on the past 50 years of growth in our field, recognize outstanding achievements, and look forward to the future of electrical engineering.
Greetings, all licensed electrical practitioners. We would like to invite you all on our 50th Golden Annual National Convention and 3E Expo on November 26 to 29 at SMX MOA.
As we celebrate 50 years of excellence in electrical engineering, together we continue to innovate, empower, and excel as leaders in the electrical engineering community.
It will be a very exciting Golden Annual National Convention. Mabuhay ang IIE!
For more than 4 decades, IIE has always been committed to its core values of integrity, innovation, empowerment, and excellence. Founded on September 15, 1975, the Institute of Integrated Electrical Engineers of the Philippines, Incorporated, IIE, is registered with the Securities and Exchange Commission, SEC, as a non-stock, non-profit technical professional organization accredited by the Professional Regulation Commission, or PRC. IIE started with 500 members and now has grown to a more than 60,000 membership base, with local and foreign chapters in active service across the whole world. Through the years, IIE continuously commits to upgrade the professional credentials of its members through the Continuing Professional Development or CPD programs, enhance their social standing through the promotion of high ideals of integrity and ethics, facilitate advancement of technology transfer through carefully conceived educational and training programs, and provide opportunity for regular interaction among electrical practitioners. Inspiring future electrical practitioner leaders, IIE organizes activities such as conferences, conventions, and exhibits showcasing the latest technologies, trends, products, and services relevant to the industry, motivating the members to be globally competitive and be able to adequately adapt to the changes, needs, and developments that constantly occur in the electrical profession. IIE activities are planned to be a venue of endless possibilities, new ideas, and valuable market trend insights on energy-efficient products and services. IIE is working together towards one certain goal: to continue to move globally forward so that the Institute will be an esteemed organization with the mission to excel and the vision to lead. For more than 4 decades, IIE has always been committed to its core values of integrity, innovation, empowerment, and excellence. Founded on September 15, 1975, the Institute of Integrated Electrical Engineers of the Philippines, Incorporated, IIEE, is registered with the Securities and Exchange Commission, SEC, as a non-stock, non-profit technical professional organization accredited by the Professional Regulation Commission, or PRC. IIEE started with 500 members and now has grown to a more than 60,000 membership base, with local and foreign chapters in active service across the whole world. Through the years, IIEE continuously commits to upgrade the professional credentials of its members through the Continuing Professional Development or CPD programs, enhance their social standing through the promotion of high ideals of integrity and ethics, facilitate advancement of technology transfer through carefully conceived educational and training programs, and provide opportunity for regular interaction among electrical practitioners. Inspiring future electrical practitioner leaders, IIEE organizes activities such as conferences, conventions, and exhibits showcasing the latest technologies, trends, products and services relevant to the industry, motivating the members to be globally competitive and be able to adequately adapt to the changes, needs and developments that constantly occur in the electrical profession. IIEE activities are planned to be a venue of endless possibilities, new ideas and valuable market trend insights on energy-efficient products and services. IIEE is working together towards one certain goal: to continue to move globally forward so that the Institute will be an esteemed organization with the mission to excel and the vision to lead.
The Institute of Integrated Electrical Engineers of the Philippines, Incorporated, IIEE, is thrilled to invite every electrical practitioner and innovation enthusiast to the biggest gathering of electrical, energy, and electronics sectors. 3E Expo is the IIEE's premier event showcasing the transformative power of innovative products and services from industry-leading companies. 3E Expo expects to gather 200 leading companies to unveil their latest breakthroughs and solutions. This year's 3E Expo will put a spotlight on cutting-edge technologies by featuring renewable energy solutions and display of electrical vehicles. 3E Expo is poised to be a catalyst for endless possibilities and new ideas. The 3E Expo will certainly be a venue of unparalleled networking possibilities, as IIEE expects more than 15,000 trade visitors. 3E Expo is not just an exhibition. 3E Expo is a journey into the future. Together, Let us all witness revolutionary designs and technological solutions that will shape the world as we know it. So what are you waiting for? Mark your calendar and visit the IIE 3E Expo.
IIEE is celebrating its 5th decade. From the spark of vision of the IIE's founding fathers to have an organization for the Filipino licensed electrical practitioners. We are now celebrating the 50th Annual National Convention and 3E Expo 2025. Driven by the 4 core pillars that defined us: integrity, innovation, empowerment, and excellence. We would like to invite all IIE members to witness the next wave of innovation for the electrical engineering industry. The 50th Annual National Convention and 3 Expo
much for your patience. We're making some final adjustments and we'll be starting in a few moments. So thank you very much. Hello, mic test. So once again, ladies and gentlemen, thank you very much for your patience, and to our delegates, guests, and virtual participants joining us online. Welcome to the third day of the annual National Convention with the theme Technology Trends in Electrical Engineering, Present and Future Innovations. To formally start this hybrid session, may I request everyone to please stand for our invocation, to be followed by the Philippine National Anthem and the singing of the IIEE hymn.
Engineers of the Philippines Incorporated, IIEE, in recognition of the constant involvement of technology in uplifting the quality of life, and in accepting a personal obligation and dedication to our profession, its members.
O divine creator, source of all wisdom, love, and compassion, we come together today in gratitude for the gift of life and in reverence for the diverse paths that lead us to you.
عيننا القتل تكرم القدسات في كل إنسان ولتنظر إلى ما وراء اختلافاتنا وتدرك الإنسانية المشتركات التي تربطنا من. نتمنى أن نحتضن اللطف والتفاهم ونبني جسر السلام حيث توجد اليانك. Oportunidad nga magkahiusa karon sa kini nga seminar konferensya. Pagpalihok sa imong Espiritu Santo sa atong mga kasing-kasing o pangisip aron kita makatagbaw sa imong mga katuyuan. Paghatag kanato og kaalam, pagkaayo ug pagkausa sa atong mga paningkamot. Pagampo nga ang atong mga pagingon ug mga buhat magdala og kaayo ug kalipay. Hegyan kesrot, हमारे मन को प्रकाशित करे ताकि हम समान और खुलेपन के साथ जुड़ सके सभी लोगों और हमारी साझा धराती के परस्पर संबंध का सम्मान कर सके हमें अन्याय को चुनौती देने का साहस गहराई से सुनने की बुद्धि और समझाने की सहानुभूति प्रदान करे यह सम्मेलन एक ऐसा स्थान हो जहां विचार पनापे और जहां हम एक अधिक न्यायपूर्ण और दयालु दुनिया के लिए मिलाकर काम कराने के लिए प्रतिबद्ध हों.
Kami ay nagdarasal para sa pagkakaisa, para sa kapayapaan, para sa pagmamahal. Sa iyong maraming pangalan, kami ay humihiling ng iyong gabay at mga biyaya. Amen.
Mga kababayan, ang pambansang awit ng Pilipinas.
licensed in electrical profession, having a dynamic professional association, making innovative contributions to our nation. Rising to any challenge, involving what's comes and goes, BRE and RME, connecting industries by electric circuits. Bind us together, IIB. Synchronize our hearts to reach greater heights and brighter lives. We serve humanity with the power of electricity, making grid transmission great for reliability, ensuring little power loss and high efficiency. But shifting from one place, the use of all energy. Bind us together, IIB. Bind us forever, IIB. With our hearts cannot be broken. Bind us together, IIB. Bind us together, IIB. Bind us forever, IIB. Synchronize our hearts to reach greater heights and brighter lives. There's only one institute, no one else can substitute. There's only one IIB.
You may now take your seats. To begin our morning sponsored presentations, let us welcome our first speaker. Engineer Ariel Didi Guzman is a Project Specifications Manager at Eaton Global Energy Infrastructure Solution, where he leads specification strategy across the Asia-Pacific region. He has more than 12 years of engineering experience in both local and international projects, including mining, power generation, chemical facilities, and LNG terminals. His career began as a field engineer in Palawan and later expanded to roles in Sarangani, Singapore, Thailand, and Taiwan, as well as multidisciplinary collaboration in Japan. Before joining Eaton, Ariel built his expertise in JGC, gaining a strong foundation in systems engineering and project execution. He is an active member of the Institute of Integrated Electrical Engineers of the Philippines, Metro North Chapter, serving in the Teamwork and Professionalism Committee. Ariel focuses on advancing professional growth, promoting high ethical standards, and preparing engineers to compete globally while contributing to the local industry. Let's give him a warm round of applause.
morning everyone. Salamat din po sa very generous na pag-welcome. Once again, I'm Ariel from Global Energy Infrastructure Solutions ng Eton dito sa Philippines. Before I start my presentation, let me ask you a question. Have you ever experienced sudden power outage? Yung tipong everything stops. Lights go out, machines shut down, and everyone scrambles. Now imagine that happening into a data center or in a manufacturing facility or in an hospital. Isang iglap lang pero ang impact could be millions of losses, disrupted operations, or lives at risk. Power is what keeps the world running. Pero our world is also changing and evolving. Yung old ways natin ng pag-manage ng power is no longer that simple. So, imagine this. Every businesses now are in great pressure. Operation costs are rising, energy goals are becoming stricter, and then systems are becoming more and more complex. And yet, they're expecting us to deliver more, deliver faster, and deliver safer. Alam naman natin na hindi madaling ma-achieve ang lahat ng to, pero resourceful as we are, doing the best with what we have, unfortunately, yung old ways talaga ng pag-manage ng power is no longer enough. This is where Bright Layer comes in. It's Eton's way of combining intelligent power and connected device. It's combining our electrical expertise in intelligent softwares and connected devices. Imagine having a real-time visibility to your critical facilities. So you don't only detect the problems, but you're also able to predict and prevent them to happen. So this morning, let me introduce you to Bright Layer, and let's explore what Bright Layer is, why it matters, and how can it help your business to thrive, not just to survive in this ever-changing world. Globally, businesses face 6 major challenges pagdating sa energy management. When we talk to facility, and what's interesting is yung mga challenges na to is no longer isolated. They're actually interconnected. Meaning to say, kapag meron kang challenge sa isa, possible na mag-domino effect siya sa iba. So let me walk you through in a way that connects to real operations. First is yung safety risk. Maraming sites today ang old, remote, and poorly maintained. Hindi updated yung status reports and hindi rin accurate yung monitoring. Kaya nangyari, human error, outages, and safety incident. Alam naman natin na konting mistakes sa electrical system, it could lead to catastrophic consequences. Next is yung skilled labor shortages. Ito very real dito sa Pilipinas. Kulang yung skilled workforce, pero yung system is nagiging more and more complex. Kaya nangyayari manual tracking, spreadsheets, delayed updates, and sometimes hinuhulaan yung values para makapag-comply lang doon sa report. So productivity goes down and data integrity suffers. Yung numbers na dapat nagiging basis natin for decision making is hindi na nagiging reliable. Next is yung unplanned downtime. This is the nightmare of every operations team. And honestly, unplanned downtime is no longer a technical issue. It's already a financial issue. Because globally, there are incidents of unplanned downtime that cost businesses around $1 million per incident. Bakit? Kasi maintenance backlogs keeps on growing and failures happen when you least expect it. Next is yung reducing energy consumption. Every company now is pressured with net zero goals or sustainability targets. Pero paano ba natin imamaneuver kung hindi natin alam kung alin yung may pinakamalaking power consumption or kung anong yung area yung may pinakamalaking impact or kung anong items yung pwede nating i-rectify immediately. So energy management today is no longer about just savings. It's about strategy. Next is yung infrastructure availability. As our operations scale, more machines, more racks, more loads. The question is, are we ready for the future capacity? Some organizations overinvest, while others are underinvesting. Both are risky. What we need today is better visibility, better monitoring, and better planning. Last but not the least is compliance. Regulations change, standards evolve, and the documentation required is mas lalong lumalalim, mas lalong dumadami, at mas lalong tumatagal. What we need is consistent automated reports para ma-avoid yung mga penalties and maintain yung brand trust. So, if you look at all of these challenges, one message is becoming clear. We can no longer rely on the old and manual ways of managing power. What we need is something smarter, something integrated, and something data-driven. So now, dito pumapasok yung importance ng Eaton's evolution on power management. For more than 100 years, Eaton has been known as the global leader in power management. Hindi lang basta sa products, sa breakers, UPS, switchgears, but in the deep fundamental engineering behind them. Pero gaya nga nasabi natin, the world is evolving, assets became connected, systems became digital, and operations became data-heavy. So customers are now looking for not just hardwares, but on data-driven solutions. So Eaton expanded from manufacturing to intelligent data-driven solutions. We're combining connected hardware, intelligent software, and expert lifecycle services into one ecosystem that gives you full visibility and control. So hindi na hiwa-hiwala yung systems, hindi na manual yung tracking, hindi na delayed yung reporting. Instead, you get real-time insights, predictive analytics, and actionable information all working together. And because Eaton serves in more than 170 plus countries, every bright layer solution is built to handle diverse environments, different industries, at iba't ibang stages ng digital maturity. The goal is simple, to help organization navigate complexity and be resilient on what lies ahead. So let's go back to our story. We have a rising challenge. We need smarter tools. And Bright Layer keeps your way, it gives you way to simplify your operations and make the data work for you, not against you. Okay, so Bright Layer is founded in four value propositions. Kasi most of our organizations, they have IT or OT, information technology or operational technology. Minsan magkaiba yung system nila, magkaiba yung language, magkakaiba yung data sets na kailangan. But Bright Layer brings a platform that can integrate all this data together and help you decide or give you data to help you decide. Based on these four foundational value proposition. First is safety and risk. Bright Layer protects people, assets, and even your brand. Kasi kung connected in systems mo, you can detect the problems earlier, automate certain responses, and reduce human error. Number two is efficiency. In a world with skill shortages and limited resources, you need to do more with less. So Bright Layer helps you maximize every watt, every worker, and every workflow. Next is resiliency. Ito yung pinaka-critical ngayon. With unpredictable grids, higher operational demands, uptime is no longer optional. It is required. So BrightLayer supports faster recovery, predictive maintenance, and smarter capacity planning. And sustainability. Every company today is being measured by its environmental impact. So BrightLayer helps you track, compare, and reduce energy consumption para ma-hit natin yung net zero goals natin. So BrightLayer is like a visibility engine. It, again, hindi lang siya nagde-detect ng problem, but it makes you predict or prevent them to happen. So BrightLayer is built for organizations that keep the world running. For data centers, manufacturers, utilities, commercial buildings, and more. So whether you're managing critical energy system, reducing downtime, or hitting sustainability goals, BrightLayer turns power and data into action. So it helps you stay resilient, efficient, future-ready, so you can lead through change with confidence. So ito naman yung kanina medyo high-level story tayo. Ngayon ito yung under the hood view para sa mga engineers and technical teams natin. So BrightLayer is a portfolio of software and services designed to do three things. First is to enhance connected assets. Number two is deliver insights, control, and predictions. And number three, achieve outcome in terms of safety, efficiency, resiliency, and sustainability. So sa connected assets, this includes IT assets, yung mga UPS, PDUs, servers, hypervisors, and yung OT assets naman, ito yung mga switchgears natin, transformers, MCCs, meters, etc. Think of it as bringing all your critical equipment into one unified view. And syempre, kapag connected yung system natin and cloud-enabled, dapat secured siya. BrightLayer follows strict OT cybersecurity standards and integrate privacy by design. Sa digital platform, dito pumapasok yung data integration. BrightLayer connects, enriches, and manages data across different protocols and devices to create a seamless infrastructure. Meron din tong cloud and on-prem software, and you get flexibility to choose. Pag cloud, ang advantage niya yung long-term storage, remote access, and analytics. Sa on-prem naman, high-resolution data, control, and low latency. Sa professional managed services naman, of course, hindi ka iiwan after installation. BrightLayer supports training, monitoring, troubleshooting, upgrades, and OT cybersecurity assessment for your systems. So BrightLayer isn't just a product, it's an ecosystem that designed for your business so that you can stay ahead of what's coming. So ito naman yung diagram ng BrightLayer ecosystem. So BrightLayer power with motor analytics is for industrial environments. It monitors motors, electrical systems, giving predictive insights para maiwasan yung downtime. Think of it as a health check for your equipment para hindi ka ma-surprise sa mga failures. Yung BrightLayer DCIM natin or Data Center Infrastructure Management is for data centers. It helps you manage racks, PDUs, cooling systems, and lahat ng critical sa IT infrastructure. And may real-time monitoring and capacity planning para hindi ka mag-overload. Next is yung BrightLayer EPMS. Ito yung favorite ko. Electrical Power Monitoring System. This is for electrical distribution. It tracks power quality, energy usage, and yung compliance natin sa different regulations. This is perfect for facilities na kailangan ng detailed reporting for audits and sustainability goals. Next is yung distributed IT. This is for remote branches. It gives you full visibility kahit remote yung branch nyo or yung location nyo. And this is ideal for businesses na may multiple sites but limited on-site staff. And of course, yung bright layer monitoring services natin, it is a managed service option ni Eaton, where Eaton experts monitor your assets 24/7. So you don't have to worry about missing your critical alerts. It's like having a dedicated team watching your back. So ito naman, this is how the data moves across bright layer. From the connected assets, it is either all of your equipment is starting to generate data, and then it is either transferred to bright layer edge or bright layer on-prem. So pagpapunta siya sa bright layer edge, it collects and processes data at the edge level, enabling fast insights and control. And then sa bright layer cloud, this is used for long-term storage, lower resolution, but highly scalable. And this is ideal for monitoring and analytics. Kapag sa on-prem naman, high resolution yung data, faster yung control, and this is ideal for hospitals, data centers, and industrial plants. And of course, again, yung professional services natin, we support you through design, integration, commissioning, and optimization. So, bright layer is scalable, expandable, interoperable, and cyber-secured. Ngayon naman, may mga organizations na medyo advanced na. Kumbaga, nag-integrate na sila ng digitalization sa businesses, systems nila. Pero meron din namang mga businesses na mag-i-start pa lang ng digital transition. But Bright Layer and Eaton is here to support you at every stage, from planning, where we do network design, configuration, and OT cybersecurity assessment, up to deployment, where we do installation, startup, commissioning, and customization, up to support, technical support, upgrades, health checks, custom development, and up to operation, where we do training, remote monitoring, device audits, and cybersecurity lifecycle. So Bright Layer offers a full range of services designed to meet organizations wherever they are in their digital journey. Ito, we're just showing you the complete coverage of Bright Layer products. Sa cloud natin, sa cloud software natin, merong Bright Layer Assets, Bright Layer Energy, Bright Layer Lighting, and Bright Layer Machinery. Sa on-prem naman natin, yung Bright Layer Power, Bright Layer EPMS, Distributed IT, and DCIM. And again, yung mga orange na yan is the software add-on where you can include disaster avoidance, motor analytics, BI dashboards, monitored services, and integrations. And additional service sa cloud is yung Bright Layer monitoring service. So it's a modular ecosystem where you can start small, you can grow as needed, and then you can add components at any time. Right now, we're renaming some of our software products into a more simplified naming to drive consistency, clarity, and simplicity. For example, our APM or Asset Performance Management and EPMS is turned into Bright Layer Power and Bright Layer EPMS. And then, for example, sa cloud software products naman natin, yung dating GEMS natin, yung Global Energy Management System, is now renamed as Bright Layer Energy. Okay, as we close, one thing is clear. The world is not slowing down. Systems are becoming more and more complex, and uptime is more critical. And the real question is, do we keep on reacting or do we start leading? That's exactly why Bright Layer exists. It turns your data and power into action to turn downtime into uptime, and then turn all these complexities into clarity. So if something today brings you a big idea, or you have big challenge in mind that you think BrightLayer can help, this is my contact details, where we have office here in Vertis North in Quezon City, and you can send email to this email address, and you can call me also on this mobile phone. And I'd be very happy to understand your setup, and then let's explore BrightLayer, how BrightLayer can bring value to your business. Once again, this has been Ariel de Guzman. Thank you for your time.
Hello. The floor is now open for the question and answer portion. So any question from the crowd po that we have for our speaker, Engineer Ariel? Punta na lang po dito or you may raise your hand. Any question from the crowd? Ayan. So, baka shy sila, sir. So, if ever na meron po tayong nakakatch sa ating attention na question and then nahihiya lang po tayo, pwede po nating labitan si Sir Ariel kung nandito pa siya. And then, meron din pong booth yung Eton sa baba that you can visit for further questions. For now, we would like to close this first presentation and we would like to present our certificate of appreciation. Allow me to read the citation. This certificate of appreciation is presented to Eton Electrical International in grateful acknowledgement and sincere appreciation of its valuable contribution as sponsor during the technical trends in electrical engineering, present and future innovations, in conjunction with the 50th Annual National Convention and 3E Expo 2025 with the theme IIEE, Celebrating 50 Years of Integrity, Innovation, Empowerment, and Excellence. Once again, let us give a big round of applause to our speaker. Next, we have our second speaker is Florian Predel. Mr. Predel commenced with Omicron Austria in 2007 as an application engineer with special focus on advanced instrument transformation diagnostics within the engineering services team. In 2013, Florian joined Omicron Australia as a field application engineer. Before starting at Omicron, he visited the Federal Higher Technical Institute in Ranquil, Austria, where he graduated in 2007. There, he was focusing on high-frequency technology. His final thesis was focused on range extension of RFID systems for business applications by using high-frequency amplifiers. A big round of applause for our next speaker.
works. Yeah, salamat po for the nice introduction. Magandang umaga po. Yeah. Is this starting? Ah, yes, here we go. Perfect. Okay, yep, so good morning, everyone. Magandang umaga po. My presentation will be about case studies on rotating electrical machines in terms of partial discharge measurements, both done offline and online. So first I will do a quick introduction on what partial discharge measurements on rotating machines is all about. Then we talk a bit about the differences between offline and online measurements. Yeah, what are the disadvantages of both methods? And then we round it off with some case studies. So when we talk about doing electrical diagnostic testing on rotating machines, we talk about the stator winding. Yep, you can see in this drawing here, the stator winding is shaded in yellow. So that's basically insulating the copper conductor from the stator core with mica taped insulation layers. And that's what we are assessing in terms of diagnostics. If you have a closer look at the end winding area, yeah, not sure if you can see my laser pointer. Yeah, you have the stator core here, so that's on ground potential. And you have the stator winding, which is the copper here, on high voltage potential. So imagine you have high voltage here going into a section enclosed by ground potential. So we need to have some insulation material around it, which gradually reduces the electrical field stress. So that's this outer equipotential grading layer here, which reduces the electrical fields gradually from high voltage to ground. Yeah? And if that gets, for example, damaged, we can have surface type partial discharge activity as a result. Yeah? If you look at some statistics, yeah, to no surprise, outages on electrical machines, you can see a big portion is caused by insulation damage. Yeah? And out of those insulation damages, we have contributions such as aging, contamination on the end winding area, and also internal partial discharge activity from like delamination, type defects, and so on. Yeah? Also loosening of bars, for example, can lead to partial discharges as a side effect if it's like a sparking type discharge, if the bar is loose. So also those can be detected with a partial discharge measurement. So if you have a look at most common defect types, yeah, you have here the stator core, high voltage. Sorry, that's the stator core, that's the stator winding, yeah. And in between you have the insulation system, which is a mica taped insulation system. We can have delaminations there, like shown here as A, B, and C, which you can also see here as a side cut from a stator bar. You have this here, this bigger delamination sections here that normally happens due to aging, yeah. As you run the machine on different loads, the copper expands and shrinks, and as it does so, it starts to delaminate the layered insulation system from each other. We also have here type C defect, that's an abrasion of the outer corona protection layer. So here the stator winding sits in the slot, and if the slot is not mechanically very stable, it starts to vibrate in the slot area, yeah, and that vibration will start to abrase the outer corona protection layer. Yeah? Other defect types we have here on the end winding area. So here we have not enough clearance between two phases, yeah, leading to a gap-to-gap discharge. Or here defect type D, we have contamination on the end winding area leading to surface type tracking and surface type PD. So when we talk about PD measurements, partial discharge measurements in stator windings, we typically talk about two types of partial discharge activities. We have the so-called normal, need to go back. Yeah, we have the normal type PD. Yeah, so those happen already at very low system voltages, between 20 and 30% already of the nominal voltage, but they are normal. They are basically caused by microvoids, which are those microvoids are part of the normal manufacturing process of machines. Yeah? And then we also have those critical partial discharge defects. Yeah? They're well known, the patterns of those are well known, and we will talk about how they look like and how we can differentiate them from the normal type PD we have on machines. Yeah? So important is that we interpret the results correctly, whether we deal with normal type PD or, let's say, a dangerous type of partial discharge in machines. So if you look at the normal type PD, that's a typical example of microvoids you have here, yeah, in the machine. Now the machine is layered with mica tapes. So the insulation layer is layered with mica tapes, which is very resistant to PD because it's anorganic. Yeah? It doesn't have a carbon molecule bonding compounds together. So which means if you have PD activity, we see here, it's very hard for it to progress to ground from high voltage here. So it has to track around this mica layer here. Yeah? You can see this cloudy shaded part. That's the partial discharge activity. Those microvoids, they cause PD activity. You see them here as colored dots just after the zero crossing of the applied test voltage or the system voltage. Yeah? And they are more or less symmetrical in both half cycles. Yeah? So similar pattern on both half cycles. That's a typical activity for microvoids. And then we have, of course, we talked already, we have in the end winding area surface type PD, E3, or gap-to-gap discharges, E2 and E1, and slot discharges in the slot area. Yeah, we already talked about that. In the slot, again, we also talked about we having discharges due to delamination, yeah, S1, S2, and S3, depending on whether it happens near the copper conductor, stator core, or in between. And we said we have normal type microvoid PDs here in S4. If you want to have a closer look how it would look like, yeah, in terms of PD activity, you see here a summary. Yeah, this is from the ISC 60034 part 27 standard, yeah, talking about rotating electrical machines. And then there's part 1 talking about offline PD measurement, part 2 about online PD measurement. And they have put this nice summary there. You can see here, if you have delamination type PD, often you find it is unsymmetrical between both half cycles. Yeah? And depending on whether you have a higher discharge magnitude on the positive or the negative half cycle, you can tell whether the discharge is closer to the stator core or the conductor. Yeah? You also see here something called high, medium, and low. This is the criticality. Yeah? Low criticality means there is no immediate danger to the machine. Yeah? High criticality means this type of defect is critical for the life expectancy of the machine. Yeah? Okay, let's talk a bit about offline and online measurements of machines. First, some definitions. What is a measurement? Yeah. Measurement is the progress of making a quantitative assessment of a measuring quantity. Yeah. Monitoring is essentially the systematic observation of such measurements. So if you do periodic measurements every couple of years on the machine, that's de facto monitoring, right? That's trending/monitoring. Yeah. So if you look at offline measurements, what are the differences between offline and online measurements? Offline measurements, we have the advantage that we can excite or stress the entire machine winding from start point to end winding. Also, we can variable the frequency and the voltage we apply to stress the insulation, because that can give us some indication of what type of partial discharges we're dealing with. Online has the advantage that we don't need an outage for the measurement, right? And the entire machine is stressed as in service. So there's some type of defects, like the delamination type defects, which might only occur when the machine is online, because the machine needs to run, it needs to spin. So the status bar might vibrate at that point if they're loose, which can lead to gap-to-gap type discharges. Yeah? So basically what I'm trying to say is you get the advantage if you do both offline and online PD measurement for the full picture of the insulation system. So let's talk about offline measurements. Yeah? How is it done? That's just a snapshot from the ISC standard for machines. We have basically on the start point side, we apply our test voltage. And on the end winding side, we connect the coupling capacitor and the partial discharge measurement system to it. And if we can break the start point, we basically short the other two phases we are not measuring to ground. And we would repeat this test for each phase. Yeah. So this is how it would be, how it looked like when we do a measurement. So you see this is a coupling capacitor. That's a blocking impedance to block noise from the voltage source, which is connected via this black cable here. And this little blue box is a partial discharge detection system. Yeah. In terms of test voltage for offline testing, yeah, we have basically three possibilities. So the standard says either go to the nominal line to ground voltage, go to 1.2 times nominal line to ground voltage, or if you're really brave, go to the nominal line to line voltage. You apply it between line and ground. Yeah. Now I would only do that on a brand new machine, an in-service aged machine. I would normally just use the nominal line to ground voltage because you don't want to overstress the line to ground insulation that much for an old machine. Yeah. In terms of the voltages you apply, the standard says you can either apply them as step voltages, so you increase the voltages in 20% steps up to the full test voltage, and then you step down again, so you get your inception extinction voltages for the PD activity, or you can ramp it up to your maximum test voltage, hold it there for a couple of minutes, and then ramp it down again. Yep. In terms of the ramp should be with less than 1 kilovolts per second, so don't ramp up too quick, yeah, because you might miss the inception voltage. So let's look at some case studies, yeah, for offline measurements. So this first measurement was done at a large chemical plant in Europe, which they run like steel mills with over 500 high voltage motors, yeah, 11 kV motors. And if they have an outage on one of those plant sites, it would cost them about 150,000 euros a day. Yeah, so they want to make sure those motors are reliable and that they don't have any unplanned outages. So the operator has asked us to do offline PD measurements on those machines they have ordered. Those are brand new machines they've ordered from the manufacturer, and they've asked us to do offline testing. And on the next slide, you can see 4 measurements. Yeah, these are 4 measurements of 4 machines they have ordered. Yeah, and you can see they're vastly different. The machine on the top left-hand side just has some microvoids, so that's like pretty okay, yeah, for a brand new machine. But you can see all the other machines, they have pretty large discharges, up to about 20, 30 nanocoulombs. And if you remember the slide with the overview of all the PD patterns, this is a delamination type discharge. Yeah? So these brand new machines already had delamination problems, yeah, from the factory. So what happened next is the chemical plant operator, they went back with those results to the machine supplier and basically told them, look, you have supplied us machines which are not great. Yeah? And basically the machine supplier has replaced those machines free of charge, and the machines they got now are pretty good. They all have results like this, just some microvoids. Yeah. So here the question is, should we do a PD measurement on a brand new machine as well? The answer would be yes. If you have cases like this, definitely makes sense. This is another case study. Yep, this was a machine made in 2007. 14 MVA, runs on 1000 RPMs. And the purpose of the measurement was a routine test. Yep. We were asked to do a routine measurement of insulation resistance, tan delta measurement, capacitance measurement, and partial discharge measurement. So if you look at the data for the insulation resistance and polarization index, you can see that between the measurement in 2007 and the one in 2015, we can see a difference in polarization index. However, even in 2015, the polarization index is still fairly okay, right? It's above 4, which normally is kind of a threshold for class E insulation types. So there's still no definite indicate problem of an issue here. Yeah. So if you look at the offline measurement, we had a voltage source here, supplied a coupling capacitor, which runs in parallel to the machine winding. This is a reactor here, which is an inductor to compensate the capacitive load of the machine. So it's a parallel resonance circuit, basically. If you look at the results of tan delta, so you see here voltage and tan delta, yeah, and you can see the tan delta starts to tip up at about 4 kilovolts up to 7 kilovolts. So that's indicating also there is partial discharge activity potentially, because for a healthy insulation, the tan delta should be stable over voltage, should not increase. Yeah. So already tan delta showed us there is a problem. And also when we did the tip-up test, we had heavy PD activity. We could even hear it, yeah, the PD activity. So there was a risk of breakdown, so we limited the voltage, the test voltage we apply. And you can see next the PD measurement. You see the red curve, that's the voltage we applied. Green is the partial discharge activity. You can see once we reach about 7 kilovolts, yeah, we had heavy discharges, up to 500 nanocoulombs at 8 kilovolts, so huge. Yeah. You can see here, this was at low voltage, 0.2, 0.4%, 60%, 70%. So you see the PD activity rising, rising, and rising. And we have a quick look here at the PD activity at 7 kV, was around 100 nano, and at 8 kV, 500 nanocoulomb. That's huge. Yeah. Normally, on machines, we have less than 10 nanocoulombs, yeah, as a benchmark. Yeah. Here's more than 50 times. Yeah. And the pattern also shows some single discharges in the end winding area, like a surface type PD, yeah, because you have basically the PD just after the zero crossings of the voltage waveform. So here again, another snapshot at 7 kV. Again, end potential surface type discharges because the PD is unsymmetrical and just after the zero crossings of both half cycles. Yeah. So once they pulled the machine out of the housing and inspected it, they found this kind of, looks like a sand on the surface. Yeah. Those are like little sulfides. Yeah. So what happens if there's PD on the end winding area? We create ozone, yeah, O3. And ozone is very aggressive. It likes to bond with other chemicals. So if you have ozone and it basically bonds with water vapor, you get like a nitrogen in the air, right? So you have nitrogen in the air, water vapor, and ozone. It forms like a nitric acid. And nitric acids are very aggressive on organic compounds. Yeah? So it's eating basically into the organic compounds. So we have PD activity, which creates ozone, and ozone creates a chemical problem for the machine, right? So we see that here. So the end winding area, you can see that the byproducts, the chemical byproducts of this PD activity. And basically what they did here is completely cleaned the machine, repainted it, and then put it back into service after. Yeah, so you can see another picture here of that. So again, a little conclusion. So we have defects in the outer corona and then potential grading layer, which is this layers here. Create PD, that creates ozone, and ozone, again, bonds with other chemicals like nitrogen, creates nitric acids, and that basically creates these little salts here. So they basically cleaned it all up and repainted it. Then we did another PD measurement afterwards. It came back okay, so the machine went back into service. Let's have a look at some online measurements. So here's just an example how online measurements are normally performed. So we would have coupling capacitors installed on the end winding area, usually one per phase. Here you also see one on the neutral point, which is optional, not required. And then it can either be connected to a permanent monitoring system or to like a terminal box, like here. And then the operator of the power plant or the machine, he or she can go there and hook up PD measurement systems like here to take periodic measurements. Yeah. So it can be done with a permanent installed system or someone can go there and do periodic measurements on the machine. Yeah, so if you look at the permanent installed system, that's how it would look like. We have the couplers here in the end winding area, a physical connection to the data acquisition unit, and from there a fiber cable running to a monitoring server, which is connected to the IT infrastructure. So basically, if there's any alerts or alarms coming up, the monitoring system can send alerts to SCADA, for example, with TCP/IP or ISC 61850. Yeah. But let's have a look at some online case studies. Yeah. Here, a case study from a 180 MVA 16.5 kV turbo generator. Yeah, you can see here the permanently installed capacitors. If we look at what happened here, so this is the trend up here. So you see here red, yellow, and blue phase starting to creep. So you see blue phase starting to creep up in PD on June the 12th. And you can see 2 months later, right, they had an outage because they saw, oh, the PD on the blue phase really doubles. It goes from 25 nano to 50 nano, 75 nano. So it doubles in very short time. Yeah. So they said, oh, we take an outage. So here they took an outage of the machine. And you can see here the PD activity in the bottom. So you can see here, this was here on June the 12th. And then in August, you see this heavy end-winding PD here, yeah, at that point as it starts to increase. So this is the filtered signal, end-winding surface discharge, filtered out from all the background noise we have, right? So there's some algorithm where you can filter background noise from PD. So they took an outage. Here they did some maintenance on the machine. And after maintenance, you can see PD start was a bit high at the beginning. That can be normal if you have some dust particles which need to burn off. And then afterwards, PD activity was back to normal. Yeah. So here a second case study from unit 7 and 8, which were installed in 97 on a very large hydroelectric power plant in Southeast Asia. Yeah. So the monitoring system was installed in 2012 here as well. And if we look at a comparison, so you see here unit 7 and unit 8 in comparison, so all 6 phases. And you see here the purple one, yeah, which is unit 7, phase S, shows like, again, an increase of PD activity just on the one phase from around 10 nanocoulombs up to 50 nanocoulombs within quite a short time, right? December 2012 to September 2013, so a bit less than a year. Yeah. So what we did is we used a technology called 3-part. I can explain that later what that is, to separate the PD pattern to find the root cause. Yeah. So if you have a look, you can see here each little cluster in this star diagram means there's one PD source. So we have like 1, 2, 3 PD sources on this machine. And you can see here that this cluster we have highlighted here is this cluster here on phase S. Yeah. So on phase S we have this PD activity, again end-winding surface type PD. And if we look at basically filtering out that end-winding surface PD from the rest, we can see that the rest of the machine looks fine. Yeah, just some microvoids. So basically we have the one end-winding surface PD problem and the rest of the machine looks fine. So again, they wanted to take an outage to have a closer look of what's happening there. And that's what they found by visual inspection. Yeah, they found in the end-winding area, again, those burn marks. Yeah, from end-winding surface type PD, which caused that trending increase of activity. Again, they basically cut out those, oops, wrong button. They cut out those faulty parts, repainted them, yeah, and then put the machine back into service. Yeah. So this was after doing a tan delta and PD measurement after the refurbishment, and it came back as normal. Yep, all 3 phases look again very similar. Yep. So again, they took an outage because they saw a creeping up of PD activity, repaired it in timely manner, and then re-energized the machine. All right, that's I think it. So that's the end. That's my email in case you have questions. You can also ask questions now. And we are also at the booth downstairs, Tan Delta Corporation. So if you want to come by, for a coffee or something, just let us know.
Yes, so that ends the presentation. And once again, the floor is open for our question and answer session. Palakpakan po natin yung ating speaker. Thank you very much. So any question from the crowd? Ayan po, any question? You may raise your hand. Pwede po namin kayong lapitan kung nahihiya po tayong pumunta dito sa harap.
Maybe everyone's still tired.
Yes. I think everyone is shy, sir. Ayun, there's a question. Ayun. Sige po, kami na po yung lalapit. Baka nahihiya sila, sir.
It's like, no, you ask the question. No, you ask the
question.
No.
So, no question for now. If nahiya po tayo, you may visit their booth and you can have coffee with Sir while asking, yes, any question po related to his presentation and to their products. So, for now, that ends the second topic and we will proceed with the awarding of the Certificate of Appreciation. Allow me to read the citation. This Certificate of Appreciation is presented to Pan Delta Electric Corporation in grateful acknowledgement and sincere appreciation of its valuable contribution as sponsor during the technical trends in electrical engineering, present and future innovations in conjunction with the 50th Annual National Convention and 3E Expo 2025 with the theme IIEE Celebrating 50 Years of Integrity, Innovation, Empowerment, and Excellence. Let's give a big round of applause to our sponsored technical presenter. We will now proceed to our third sponsored technical presentation for today. Our next presenter is from Blue Arc Engineering Enterprise and Services. Engineer Ruben C. Likayan is a professional electrical engineer, and so to discuss silicon insulator coating, let us give a big round of applause to our next speaker.
Good morning sa mga fellow engineers, guests, mga student attendees, and iba pa na umattend sa convention ngayon. I will present more on the transmission aspect, no, ang mas beneficial to sa mga NGCP, Meralco, mga cooperatives, kasi we will be discussing how to address yung problem ng flashover sa mga exposed distribution facilities. Balik. Yung sa PDF. Ay, hindi po. Yung una. PowerPoint pala, PowerPoint. Yung PowerPoint. Hindi ko may open yung sa akin. PowerPoint. Hindi, guide ko lang to eh. Ayun, gumana. Ayun po. So, I expect na may matutunan kayo after nitong presentation para sulit naman yung mga binayad natin. So, to begin with, yung problem na ating tinatry na i-address is yung protection of high voltage insulators. No? We will mainly deal with medium voltage and high voltage. Medium voltage, mga 13.2, sa mga co-op, sa Meralco side is 34.5 kV, and then sa NGCP 69, 115 to 30 kV. So, doon tayo magpo-focus sa discussion. We will focus on yung mas high value na electrical engineering. So, ang insulators naman is almost gamit natin no, sa, mapapansin nyo pagka pupunta kayo ng NLEX, SLEX, ang dami niya yung mga linya na yan no, na galing sa mga transmission depot from Balintawak going to mga GENCOs. So expectedly, since naka-expose sila, maraming ma-encounter ng dust accumulation and so forth. So yun ang i-address natin. So, yes sir. So ano yung cause ng mga problema na to and how to mitigate or resolve the problems? Kasi ang goal natin, ang bottom line is to increase yung system efficiency and likewise, tataas natin yung reliability ng power system. So yun ang bottom line. Why natin kailangan gawin to? Kasi tumataas yung cost of generating power. So we have to do something, ano ang latest technology na we can adapt to bring down yung cost ng electricity. So bottom line here is makasave ng pera. At the end of the day, pag nakasave tayo sa operation natin, that will translate to savings na pwede natin namang gamitin sa ibang endeavor. So next. So these are some of the cost ng mga problema sa mga ceramic, porcelain, and glass insulators. Itong mga insulator na ito yung mga 50 years old na, yung mga sinauna, ceramic. Then from ceramic, naging porcelain kasi ceramics very porous material. And from porcelain, naging glass insulators. Then ang pinaka-latest ngayon is yung silicone insulators. So, ano nakaka-apekto na nakaka-cost ng flashover sa mga insulators na ito? Una-una yung accumulation of dust, dirt, contaminant. Sa mga lugar na, let's say, malapit sa dagat, mostly mga power plants kasi located tabi ng dagat. So, may mga, moisture niyan is maalat. So, darating yung time na naiipon yun doon sa mga surface ng insulators. So, thereby magkakaroon ng tracking, dadaan doon yung current, leakage current, magkakos ng flashover. Then water filming, pagka maulan, malaman natin na basa, so kumakapit sa surface ng mga insulator, yun ang nagiging path para magkaroon ng leakage current, thereby affected yung ating system. Mostly line to ground. Line to ground yung nangyayari. Then, pangatlo is reduction of resistance. Katagalan yung mga insulator, nagde-deteriorate. So, yung effectivity ng insulation nila is bumababa. And pag nangyari yun, pag bumaba yung resistance, nagkaroon ng dirt, ano yung nangyayari? Nagkakaroon po tayo ng dry band arcing, or in one word is flashover. So, dun maapektuhan yung system pag nagkaroon ng flashover. So, flashover, ano yung mga contributory factors? Just like sinabi ko, industrial pollution, no? Merong mga industrial plants na talagang hindi maiwasan for example, power plant, particularly mga coal-fired power plant. So, yung galing sa smokestack, minsan, bumababa yun, napupunta sa mga insulator. So, nag-accumulate in the long time, problema nangyayari. Also, yung salt fog, pagka nearby tayo, malapit tayo sa dagat, so yung simoy ng hangin, may mga asin na kasama yan na sumasama sa breeze. So, doon magre-reside sa mga insulators natin, itong salt na to, kaya tinatawag salt fog. And pangatlo is smog. Ito na yung problema ngayon, yung pollution, no, na galing sa mga engine exhaust, sa dami ng mga vehicles. So, ito yung nagiging challenge. No? Hindi na natin maiwasan yung smog, lalo na sa parting EDSA. So, ano ang mangyayari pagka nagkaroon ng flashover? Number one is revenue loss. No? Ma-interrupt ang power, ang system, and then you have to start over again para ma-restore yung power. Okay lang sana kung transient fault, no? Pero pagka ganyang flashover, mahirap na i-determine siya as transient fault. Sometimes you have to determine yung cause ng fault sa lugar, paano mo ma-correct bago mo maibalik yung power. And number two, repair on cables or insulators. Pagka masyadong mataas yung fault current, nadadamage na minsan yung mga insulators, nababasag, minsan yung kable, nasusunog yung insulation. So we have to replace yung mga ganong scenario. And number three, business disruption. So kung meron kayong mga data center, mga apektuhan, pag nag-brownout, so you have to restart again, no, reboot the system. Also sa mga process ng mga, like for example, mga ALPI, air liquid, mga nagproduce ng industrial gases, minsan 9 hours yung process para makaproduce ng kailangan nilang gas, no? So, pag na-interrupt yung 9 hours na yun, babalik uli yun sa zero. Unang oras ulit. So, ganun nangyayari. So, apektado ang production. And then, damage sa business image. Like, pagka yung lagi kayong may brownout, so, typical example dito, yung sa Surigao, no? Lagi may brownout. So, yung Genco na nag-operate nito is naalis, no, natanggal, pinalitan. And number 5, yung inconvenience brought about ng ganitong mga power interruption due to flashover. Ito yung isang example na real-life case scenario. Hindi ko pwede sabihin yung site kasi non-disclosure agreement ako dito. Ang system is 69 kV, no? 69 kV. Ito is yung bushing insulator. Ibig sabihin, yung current papasok doon sa gitna ng bushing. Ang nangyari to December 8, year 2020. December 8. So, ano ba in-expect? Nangyari to mga, say, 9 ng umaga. Ano ba ang in-expect natin pagka December? Normally, pagka ganitong period, yung hamog, no? Foggy. So, nangyari, dahil sa fog at saka yung mga contaminants, lumundag yung kuryente. No? In the process, binasag niya yung insulator. Ngayon yung insulator, kailangan ibalik mo yung power Nangyari sa 9 ng umaga, kailangan mo ibalik as soon as possible. Problema, walang available na replacement. And so you have to do, kailangan mong remedyohan kung anong available na meron ka at hand, no? So ganun kagrabe yung flashover na kaya niyang basagin yung porcelain na insulator. So, kung ikaw yung engineer sa site na to, yun ang challenge, no? Paano natin re-remedyohan to, paano natin gagawin. Pansinin nyo yung environment, yung ACSR, heavily contaminated na rin ng pollution, no, ng alikabok, which is kumapit na. Pati yung bubungan, hindi mo na maano yung galvanize, bubong kasi puro semento na. No? Next slide. So, niremedyohan namin yan. temporarily. So, ano yung remedyong ginawa namin? Since alam na natin yung principle ng high voltage, no? Kailangan natin dagdagan yung creepage distance. Paano natin dadagdagan? Since nabasag na nga yung, yung petticoat. So you have to maintain, sa 69 kV, you have to maintain yung safe distance sa anything na may metallic part. So, may ginawa kami rin, para mabuo yung portion na nabasag na insulator, dinikit namin ng 3M na scotch-cast. Pamilyar ba sa 3M na scotch-cast? Ano yan A and B na pouch na pag pinagsama mo, isang clear, isang dark, may pot life yan na saglit lang. So, yan ang pandidikit mo para ma-maintain yung creepage distance. However, hindi enough yun, no? Kasi nabawasan na nga eh. Yung iba hindi mo na pwedeng idikit. So, ang tanong, ano yung nasa likod? Nasa likod na cover? Anybody? Ano po yung nasa likod? Yan po ay mylar, no? Yung ginagamit sa rewinding. Kasi wala kami magamit na available material. We have to do what we have. Ano po yung basic reason sa mylar? Para lang maitaas natin yung creepage distance. No? Bilang electrical engineer, alam natin basic principle. So whatever yung material available, kailangan natin siyang i-adapt. So sa site wala eh. So mylar, ang temporary na ginamit para lang malayo siya sa mga metallic na object. Kasi naka-wall mount yan, wall mount. Next slide. So yan po yung focus, no? Yung nalinis na kasi yan eh. Nalinis na na picture. So, kita niyo yung sa bubong eh. Sa next slide, ma'am. Yung sa taas, papansinin niyo, hindi pa rin nalilinis. Yun yung ebidensya ng contamination eh. No? Kaya lang hindi namin pwedeng galawin yung sa taas kasi NGCP property yun eh. NGCP line. Tapos yung mga patak-patak, pabalik. Yung mga patak-patak, yun yung scotch-cast na 3M. Ginagamit mostly yan sa mga rewinding. So itong solution na to, tumagal pa to ng mga 9 months. No? Yung owner, sabi ko sa owner, okay na yan, tatagal yan. Kinakabahan yung owner eh, sabi, palitan mo na, bumili ka ng bushing na pamalit dyan. Sabi ko, hindi, kahit na tumagal pa yan ng 3 taon, makaka-survive yan. So, nangyari yung solution December 8, tumagal pa yan hanggang November. Almost a year bago namin pinalitan. Okay. Next case study. So, ito naman is bagong kaso. Yung planta, tabi ng dagat. Sa Mindanao to, sa Mindanao. So, nagkaroon ng arcing, binutas yung insulator, no? So, meaning to say, affected na yung insulation property ng insulator. Ito naman is purely insulator because ang purpose nito, yung mechanical strength niya para ma-hold yung load break. Load break switch nila, disconnect switch. So, pero ang sa atin is, ano ang means always para ma-avoid yung mga ganito? So, yung old practice, o dating ginagawa, ay gumagamit sila ng pressure water washing para malinis, lalo sa mga substation, sa mga switchyard, para matanggal yung dumi na nag-accumulate. Yung another method is silicone greasing. So, may nabibiling silicone grease, i-apply mo yun doon sa insulator para doon sa grease, alam niyo may grease madikit eh. Doon ngayon mag-deposit, mag-accumulate yung mga alikabok. Ang third method is silicone composite insulator. Ibig sabihin, yung existing mong mga insulators, papalitan mo ng silicone. So, bagay lang yung insulator, silicone insulator, sa mga bagong construct ng mga substation, bagong transmission, bagong distribution, okay yun. Pero kung halimbawa existing na siya, hindi natin pwedeng gawin dahil kailangan mo mag-shutdown, kailangan mo mag-interrupt, which is hindi unlikely na i-approve ng mga GenCos at ng company na nag-ooperate. No? So ang focus natin is silicone elastomeric coating. So, dito sa silicone elastomeric coating, apply lang siya natin ng coating, colorless, para siya tumaas yung hydrophobicity. Ano yung hydrophobicity? From the word hydrophobic, yung fear of water. So, yun yung characteristic niya. Another solution, countermeasure, is increase clippage distance. Babalikan natin itong silicone elastomeric coating. Yung increase clippage distance, ibig sabihin, say 69 kb, instead na 7 yung insulator mo, yung string of insulator mo 7, kasi kada string is 10 kb. So gawin mong 8 or 9. Pero ito naman is magastos, no? Pwede rin to sa may bago installation, pero sa may existing hindi pwede. Kasi mag-i-interrupt ka na naman ng power. Sa water washing na method, ano yung nangyayari? Safety concerns. Pag ginugasan mo ng high pressure washer yung insulator, pwedeng magkaroon ng problema kung yung nag-ooperate ng washer is hindi marunong. Kasi minsan buhay yan buhay na water wash. Then, it can be repetitive, paulit-ulit. Kasi once na madumihan na naman, say after 6 months or 5 months, maglilinis ka uli. So another 5 months, paulit-ulit yung process. So, para ma-maintain mo lang na huwag magkaroon ng flashover. And it requires dedicated equipment and well-trained crews. Hindi pwede yung kung sino-sino lang yung gagamit nun para maglinis ng high voltage insulator. And sometimes, pag nililinis mo, dahil live nga yung linya, nagkakaroon pa rin ng hindi maiwasan na magkaroon ng flashover, which is yung makakos ng aksidente. And overall, since repetitive nga siya, medyo may kamahalan din. Pag dinagdagan mo naman yung clippage distance, nagdagdag ka ng string of insulator, in-extend mo lang yung time ng paglilinis in between washing and cleaning. Kasi nabahan mo Kumbaga lumayo na yung distance from ground to the live part. During period of no rain, let's say summer, siyempre yan, hindi magkakaroon. Pero pagdating ng tag-ulan yan, yung naipon na alikabok sa insulator, yun din ang makakakos ng flashover. And then yung longer surface path, over-insulation limits leakage current. Hahaba nga naman yung magmi-minimize yung leakage current. Pero still, we are finding ways na mas simple at mas mura. Sa silicone greasing naman, it needs replacing when saturated. Nasubukan namin ito, pag puno na ng dust yung insulator, kakayurin mo yun pagka yung greasing, ang hirap kayurin. Plus, yung nakayod mong dumi, so environmental concern yun, saan mo itatapon, saan mo ilalagay. So hindi rin ganun siya gandang i-adapt. Yan nga, waste disposal consideration, yung manatanggal mo, makapit kasi yung grease Pag na-apply doon sa insulator, makapit yan. Pero yung life niyan, siguro after mga 1 year, papalitan mo na, kakayurin mo na. So yung grease, nag-accumulate din ng pollutants kasi yung grease madikit in comparison sa water washing, mas mura naman yung silicone greasing. Pero ito is dati nang gawin. We will try to find ways na mas better sa ganitong mga solution. So ito yung main nating silicone elastomeric coating. So arc resistant siya. Ibig sabihin, hindi magkakaroon ng tracking doon sa insulator. Gawa nga nung madulas yung silicone pag in-apply mo Smooth yan Longer in service lifetime than silicone grease. Mas mahaba ang life ng silicone elastomeric coating na in-spray kaysa yung silicone greasing na dating ginagawa. At ito ay talagang ginawa specifically sa mga high voltage system. So, it retards leakage current formation, it retards film formation and contamination solubility. Ibig sabihin, hindi yung mga industrial dust, mga hindi magpo-form doon. Gawa nga nung hydrophobic siya at saka siya madulas. So, babalikan natin to in depth, no? Yung yung isang file. PDF. So, ina-adapt po natin yung yung trends na team ng IAE, yung present and future innovation. So, mas una pa. So, ito yung power cell na I'm trying to introduce na silicon insulators coating. Take note, no, coating lang siya. Coating lang. So, ano ba ang nature ng silicon elastomers? It's a inert synthetic compounds with variety forms and uses. So, it is a generic name for a class of synthetic polymers with silicon oxygen backbone. It's a three-dimensionally cross-linked polysiloxane polymers. So, elastomeric rubber-like materials with a combination of unique properties. So, ang silicon polymers composition yan is CH ay methyl and then portion of hydrogen. So yun yung pinaka-base niya, base ng chemical. Then it's also composed of pyrogenic silica, quartz, and others. It's also a close linkers of peroxides and high silocanes. It also serves as a catalyst for platinum, tin compounds, and others. So it's a carbon black, pigment conductive special grades, and aluminum trihydride. Yun yung composition ng pinaka-silicon rubber. So ito po, no, hydrophobicity and hydrophobicity transfer. Ganon sinabi ko kanina, hydrophobic yung silicon. Meaning, hindi, yung water kasi is a polar molecule. Nire-repel ni silicon. Silicon kasi is a non-polar. So, hindi kaya mag-form ng film ni water doon sa surface ng silicon. It has also a dielectric properties. UV radiation and weathering resistance. So, importante yung UV radiation characteristic kasi lahat nito naka-expose sa field. So, lahat yan, kilometers ang exposure ng transmission line, gaano kahaba yan, and weathering resistance, mean to say, pagka yung, let's say, mga 10 years na nagka-crack ba siya, so hindi po, hindi siya nagwe-weather. Mechanical properties, silicon rubber is, nabibend, no? Bendable yan eh. Yung mga petticoat ng pwedeng, hindi katulad ng ceramic, rigid talaga siya eh. Anyway, tracking and erosion, basahin ko lang, no? May 5 minutes na lang ako eh. Low temperature flexibility and heat resistance, flame resistance, ibig sabihin hindi siya nasusunog ng apoy. Tracking and erosion, yun ang problema sa mga insulators. May avoid natin yung tracking resistance. 5 minutes. Next slide. So, classification ng silicons, high temperature curing, room temperature curing, tsaka silicon fluids. Dito tayo sa silicon fluids. Itong RTB na to, familiar kayo dito, yung ina-apply sa bintana, yung silicon sealant, yan yun eh. Ina-apply natin, then later on, mag-perform ng seal dun sa glass. Yan yung isang example, no, in practical life. So, yung company, yung Wacker, they have spent 50 years na, no? So gano'n na katagal na ang focus nila is find ways para ma-utilize yung technology ng silicon from 1938 to 2013. So yun yung mga dinevelop nilang product. Meaning to say, gano'n na katagal yung R&D nila, yung mga test na kinonduct, and so on and so forth. So hindi lang overnight na research ko to, ito to. So maraming laboratory case studies. So I think I have to jump now. Ito yung gamit ng silicon sa mga insulator, silicon insulators. I want to focus dun sa insulator coating in number 2 for porcelain glass insulators. So, isa pa. We skip dun. Sige, isa pa. Ito for insulator coating. Yung isa is solvent-based power seal N553. Ang isa naman is 577 plus. Bakit yung isa water-based? Halimbawa, magbabiyahe kayo sa kayo ng aeroplano, hindi kayo papayagan mag-carry ng solvent-based na liquid. So, dinevelop nila yung water-based. Ang naman performance, siyempre yung water-based, say it can perform 10 years. Yung solvent-based, naturally, mas 15 years mas matagal. So, simple lang na ini-spray lang siya dun sa insulator. Kahit na yung insulator nakakabit sa site on field, so pwede mong i-apply. Provided na naka-de-energize. So, where to use, paulit-ulit na, sa industrial, sa desert, coastal region. Yung countermeasures, pagka yung frequent washing, high maintenance, kaulit-ulit. Pero yung silicone, mas matagal kang maglilinis. Next. So, sa dagat, yun, mataas ang pollution gawin. Sodium chloride, magnesium chloride. Yung sa industry, marami yan, mga power plant o chemical industry, cement industry, dyan maraming accumulation ng dust. So, ito, medyo self-explanatory na to. Habol tayo sa oras. Yung video. So, I will present ng video na test kinunda. Itong test na to kinonduct sa Germany. De-explain ko na lang. Wala audio. Explain ko na lang, no, para ma-expedite yung oras. So, sa laboratory, dalawa, no? Yung nasa kaliwa, yun yung na-sprayan. So papansinin nyo, hindi nag-film yung tubig, no, sa surface. So yan po yung nangyayari sa field, no? Pagka na nagkaroon ng pollution, so pwede nating i-simulate yan sa laboratory. So this one, in-applyan niya, no, ng silicone insulation. By spray lang, napakadali. No? And then, i-compare natin, yung sa kaliwa, in-sprayan, yung sa kanan, hindi, as is siya. Ang in-spray may content ng asin, salt. So, para mas mabilis conduction ng electricity. So, nagbi-build up yung current, no, yung leakage current. Ayun. With the same voltage na in-apply, so yun yung nangyayari. Yung isa is, nakalusot yung current, yung isa, hindi. Gawa nung silicone insulation. So, hydrophobicity and hydrophobicity transfer, protection against flashover, no cleaning necessary. So, ayan yung salt deposit na nakikita na nangyayari. So, masyado nang makapal yung accumulation. So, iyan po. Yung tubig nagiging beads, no? Nagpo-form ng beads. So, ganun lang po kasimple, no? Yung experiment nila. So mas okay kung halimbawa silicone din yung gamit mo na insulator, so doble. Hindi na hindi na siya dadaling kuryente. And then at the same time, applyan mo pa, lalong hahaba yung buhay. I think my time's up. Thank you po sa pakikinig sa akin.
Is now open for the question and answer portion. Any question once again from the crowd? Question po. Pwede po kaming lumapit kapag nahiya po kayo. Yes. Okay. So, I think we don't have questions, sir. So, if you have any question, you may directly ask si sir while he is here, or you may ask for his contact number so you can ask more about the presentation that was just presented to us. And for now, I will proceed with our presentation of our Certificate of Appreciation. Allow me to read the citation for our Certificate of Appreciation. This is presented to Blue Arc Engineering Enterprise and Services in grateful acknowledgement and sincere appreciation of its valuable contribution as sponsor during the technical trends in electrical engineering, present and future innovations, in conjunction with the 50th Annual National Convention and TE Expo 2025 with the theme IIEE, celebrating 50 years of integrity, innovation, empowerment, and excellence. Once again, let us give a big round of applause to our speaker. Our next presenter is Peter Hempens from Homecore Marketing and Construction Services Corporation. He is an electromechanical civil engineer with more than 17 years of experience in medium voltage switchgear design and testing. He is the head of research and development at SGC Switchgear Company in Belgium, where he led the development of advanced MB switchgear technologies with a strong focus on safety. To discuss next generation switchgear safety, the ARC Killer, let us all welcome our next speaker. Palakpakan po natin.
Dear ladies and gentlemen, did you ever imagine how digital monitoring can support with optimizing your assets? Due to digital monitoring, you're able to continuously monitor and collect data from your substation and analyze it in real time, and get also notified upon upcoming trends which are not yet visible for the naked eye. This is the true power of digital assets and the condition of your substation. In order to monitor, we have to collect the data. We will discuss it. Also, the role of the sensors. Once you have collected the data, you have to be able to transfer it and have a real-time visualization. In order to do the analysis and to define an algorithm and have an automated response. Afterwards, we're going to show you how we take this theory into practice by our approach, and we give you an overview of the system. So the digital monitoring is continuously collecting data, so not a few spot measurements, but on a real-time basis. Also, this information is transmitted in real time, that you can do your analysis, and that you have an early detection of a deviation. So the aim is from your data collecting from your DOS prompt that you can have a visualization and that you see certain trends. In order to be able to have the necessary information, you have to define some key parameters. So first of all, you have to be informed about your environment. So your temperature, your humidity of your substation, because you will have to correlate your obtained data from your switchgear and reflection with the environment. Also very important is the load operations. So the number of open-close operations and in combination with your load give you an idea of your mechanical and electrical wear. And to be able to give an idea of your aging of your total substations, we measure the PD and also temperature to define certain hotspots. So this collection of all those parameters is the foundation for your monitoring. If we go back to the sensors, first of all we have the thermal sensors to define the hotspots. Those hotspots could arise from poor connections or from temporary overload. For this reason, we identify a few components. Do you see the pointer? No. We define the compartments where you have to place the sensors. So the busbar compartment on top, the cable compartment at the bottom, and your switchgear compartment in the middle. Because those connections are the connections which are being made on site. If you have a poor connection, those are most questioned. And also by well positioning the different sensors, you have a total overview of your cubicle. Also, we measure the environment. This is done in the LV compartment on top on the right-hand side to have a reference value. The PD and the humidity sensors we combine because when you have fluctuations in your humidity, it's normal that your PD have the same fluctuations. The aim for the PD detection is to detect an early installation problem. That can be due to voids in your insulation material, as well due to a poor termination in your cable lug, or to loose connections. Once again, we measure as well the environment to have a view of the substation. So the positions of the sensors are the same as earlier on, the busbar connection, cable compartment, and your switchgear connection. In order to have a view of the load, we also measure the current and the voltage. If you already have a circuit breaker, you can collect the data from your protection relay. If you have a fuse, switch fuse combination, for instance, you can add a Rowhovsky coil and take your voltage sensors from your VDS. And this way we are able to measure the power of your substation, and we can reflect this into behavior of your temperature to see if it's aligned with your power consumption or not. Next to it is the position sensor, so the number of operations of your earthing switch, of your circuit breaker, because it gives an idea of your mechanical wear. Next to it is also the switching under load. So the accumulated amps can be measured by your protection relay, and it gives an idea of the electrical wear of your switchgear. The same happens for the opening and the closing times of your circuit breaker, because if you see a certain tendency, it also gives you an idea about the electrical life. This one is only related to GIS installations, so the measurement of the gas pressure, because you want to detect an early leakage, and that way it's interesting to have a gas sensor with an early threshold value and not only an alarm value. So you have to well select your sensors. And the basic aim is to ensure that your dielectric and integrity is safe. So the most important is not the collecting of the data as a standalone unit, but to combine it, because the combination of the different information gives you a real overview of your switchgear, both electrical, thermal, and mechanical. Once all the data is collected, you need to be able to transmit it and to store it, and to have it in storage to do some analysis. The transmission can be done by Wi-Fi or Bluetooth, but this has a disadvantage that you have to be in the near proximity. And the aim of a digital monitoring is that you can do it as well remotely. That's why 4 and 5G is the most selected option, or if you have the possibility to wire it through Ethernet. For long distance, LoRaWAN can be used, and also industrial protocols like Modbus can be used between sensors as well. For storage, you have different options, or in the clouds, or your own server, or you can also have local storage or a combination of both. Of course, when you transmit the data, the security is of major importance. So we have two well-known protocols, but the security is a topic on its own. I will not go wider in this one. So you collected the data, but to be able to have an interpretation of it, you need to be able to visualize it. It's very important that you're able to visualize it, that it has a low entry barrier, that it can be used both for operator as for engineer, as for managers, that it gives a global overview of your entire substation, but at the meantime that you can dig into it, that you have it for a unit on its own. As well, a logbook of the total substation gives an added value, because you can see the number of operations, you can see under load what it does, and it can create warnings and alarms that you have the total life of your switchgear is involved. And if you are able to do it with a low entry barrier to make your sensors simple to install, it's ideal for a retrofit, because it's mainly those substations which already have some aging that are most interesting to analyze, to monitor, because it's those can fail faster. So the advantage is that you have the real-time insights for your operators, your engineers, and your managers. Could you move to the next slide, because the pointer is okay. Once all the information is transmitted, now comes the key, is that you have to analyze it, that you have to apply certain algorithms to define different topics. So first of all, you have your basic thresholds, but that's a very basic level, so it's really an alarm level that you cross, and you can give a warning. More interesting is that you have a correlation between different values, because for instance, if your temperature in your bus bar is going on, you can see it as an alarm, but as in the meantime, if your load is maximizing, and as well you name a temperature, then there is no reason to be worried. As well, trend analysis. So if you get a gentle increase of the PD, it's not alarming. But if you can correlate it to the other cubicles and to the environment, you can make different alarms. So it's really the algorithm that can enable active maintenance, that you don't have any downtime to do spot measurements. That's the biggest value. So based on those algorithms and these alarms, you can send automatic responses. So first of all, just alarms. You can also apply active cooling. So if you see that your ambient conditions are, or ambient temperature is going up, that you have a cooling system in your installation, you can actively control it. You can as well generate maintenance tickets. So if you see a steeply increase of your PD, but it's not alarming, that you can plan it. And you can also foresee auto closing functionality and others. So that was the theory. How we made it in practice, we cover a complete data collection. So because, like said earlier on, the sensors are mainly interesting in the busbar compartment, switchgear compartment, and cable compartments. We combined all those, so the thermal, the humidity, and the PD, we combined them in one sensor that it's easy to install in all those compartments. Because you're interested for all the different values in the same region. For connectivity internally, we rely on Modbus communication because it's wired into the switchgear. It's an easy connection to be made. And for the data transmission, we have a 4-hour 5G connection and also a local interface. The local interface has the advantage if you're doing the installation and that the operator, after installing all the connections, all the sensors, he can have a quick access, do a verification of all the components, and then connect it to the server. So the real-time visualization, so it's very important that it's user-friendly. So we have a global overview of the entire substation, so not only the cubicles, but also the transformer, and if present, the low voltage compartments, that we monitored everything, that you have a global overview. If there are alarms, you have the status bar, which is in green, which gets a notification. And if you click on it, you can dive deep, that you have all the informations of one cubicle all connected together, that it's clear which measurements contain to which value. So. Next to it is the analysis and the algorithms that are made. Here we have some trend lines. So for instance, on top you have the humidity, at the bottom you have the temperature. In the middle you see a temperature rise. You can take this one as alarming, but if it's combined also with your load, you can see that your load is going up as well. It makes sense because your temperature rises, your humidity decreases due to the load which is raised. And then based on all those algorithms, you can have your responses automatically, just your status information. If you have certain alarms, you will have a pop-up, you will also have a signal, and you can connect it with an email or an SMS service with automatically the alarms you have on the left-hand side. So every alarm is able to combine with a certain position. Next to it, we can add the video stream, which is very interesting to have a clear view, but also you can combine it with a trigger. So whenever someone enters the substation, you get a registration in your logbook, and you can see which actions that they performed. So on the right-hand side, you have the logbook. Each time you have a video recording you can do, a minute up front and a minute afterwards, that you can collect everything that the operator has done. And you also have pictures which are being transmitted that you can see which operations, like at the bottom, so manual operations of your routing switch, and also remote controlled of your low logic switch. So this remote control is if you're not, if you don't have a SCADA, so for a standalone system. But if you have a SCADA, you can use the system also as an add-on. So it's really the combined information which makes the system very interesting and reliable. So if you have your control, you always have to do confirmation like you saw in the previous slides. Here in summary, we can say at the center you have the core module, which contains the RTU and your reference sensor. This one is backed up by a UPS system, that you have your power supply also in case of an outage, that you're able to transmit the information, that you know what happened, that you also, based on this one, you can do a notary closing function. The connection is made by a modem by 4G, or you have your wired connection. And then the two blocks at the bottom represent the unit module, which is incorporated in each cubicle. So you have your IO module that captures your inputs and your outputs. And on this one, you can add your sensors for the different compartments. And in case you can add your motor control or integrate in your SCADA, and also have your caption or your voltage detection. And you can add your protection relay and your switchgear, your short circuit indicator as well. So this module is copied multiple times, as much as the number of switchgears you have. So you're invited to our booth because we have the setup as well over there. And if you have any questions, please.
Ayan. Yes, thank you very much. Any question po from our crowd? Once again, tanongin po natin. Anyone? Anyone from the crowd? Any question? And if none, don't worry. You can always visit the booth of our technical sponsored presenters. So, visit lang po tayo sa booth kung naiiya po tayong magtanong dito. And feel free po. Ayan, si Sir, they will be assisting you naman po once you visit their booth. Ayan. For now, we will proceed with our presentation of our certificate of appreciation. Let me read the citation for our Certificate of Appreciation. This is presented to Homecore Marketing and Construction Services Corporation in grateful acknowledgement and sincere appreciation of its valuable contribution as sponsor during the technology trends in electrical engineering, present and future innovations, in conjunction with the 50th Annual National Convention and 3E Expo 2025 with the theme IIEE, celebrating 50 years of integrity, innovation, empowerment, and excellence. Once again, let us give a big round of applause to our speaker. The next one will be our major technical session. Our speaker is Engineer Rodolfo Peñalosa. He is a distinguished professional electrical engineer, an electronics engineer, an APEC engineer, an ASEAN Chartered Professional Engineer, and of course, our former national president here at the Institute of Integrated Electrical Engineers of the Philippines. He earned a Bachelor of Science in Electrical Engineering from FEATI University and has received numerous accolades, including the Most Outstanding Professional in the Electrical Engineering by PRC in 2010. With extensive leadership roles, including former chairman of the PRC Board of Electrical Engineering, he has authored electrical construction standards and lead communication infrastructure studies. He founded Westco Electrical and Equipment Corporation, offering energy solutions, substation testing, and maintenance, and continues to contribute to the industry through training and consultancy. So once again, let us give a big round of applause to Engineer Peñalosa.
Thank you very much. Good morning. So how's your morning? Overwhelmed? Not yet. Well, anyway, my topic today is now the mandate of the Department of Energy. I know that many of you could have been at CEM or a CAA, but let me just brief you what this is all about. Now, I'm Engineer Roddy Peñalosa. It was already mentioned. And I'm the president of Westco Electrical from 1990, but I started the business in 1976. I had an office in California in 1986 to 1990. I'm the president and training director of PAM of Tech. We provide training for technical programs and non-technical programs. We also conduct training for certification in the thermal imaging in collaboration with the US, and also certified energy management and certified energy auditor. I'm former chairman of the Board of Electrical Engineering and a former chairman of CHED on technical panel. And also I'm past president of the Philippine Institute of Construction Arbitrators, where we have conducted a lot of construction disputes up to now. So just like that, let's go straight to the point. So when we talk about electromechanical systems, we know very well that all systems, like this building has mechanical systems, it has electrical system, it has lighting system, it has so many things. And that affects what we call the efficiency of the building, and at the same time, it affects the consumption of the facility. So what happens is that when RA 11285, promulgated by the Department of Energy in 2018, all of the establishments in the Philippines are required to report annually or every 3 years the consumption or development or program of the facility to improve their efficiency of operations and consumption. What does it affect? It affects, the most important part here is HVAC. You know that very well. Lighting systems. Also about boilers, heaters or steam. Now all these, like combined heat and power, the use of renewable energy is also very essential. As you can see, all of these are all part of what we call energy efficiency program, supposedly. Now let's go to the first. This is how you look into the Department of Energy requirements of all buildings. One, if you have a 50,000 kilowatt hour equivalent of the year consumption, you may not need to report, but you need to monitor. When we have a 500,000, 50,000 on one and up to 500,000 kilowatt hours of consumption annually, then we have to report. And if we go beyond that, 50,001 to 4 million kilowatt hours, then you are on type 2, and go beyond is type 3. That means all of us are required to submit to the Department of Energy. I know that many of you are aware of this, but many, as of now, as I know, are not so familiar yet. Okay? So let's go on HVAC. You know very well that HVAC in a facility probably consumes about 40 to 60% of energy. And there are a lot of companies all over the world that come to Manila to make an offer to reduce the consumption or improve the efficiency of HVAC. And I agree with that. Remember, when an HVAC is operating 24 hours or 24/7, like in hotels, in casinos, probably in establishments like this, probably runs from 6 to about 10 or 11, that's still very big substantial cost of energy. So what are the things that we need to do? We need to know what is the significant energy consumption of the facility. We know it's already 40 to 60% on accounts, and most buildings, most of them were not tested practically before its operation. Some of them are just rushing the installations, and so what happens, it is not tested practically to its true functionality. And now we have also looked at inefficient systems that are old or it has to be upgraded. Now this is some of the technical aspects that I don't want to go technical, but I'd like to just show you what are the things that we need to understand. The coefficient of performance of the machines for mechanical energy. I think you know that very well as well. I don't need to go beyond that, but at least you know exactly that this is what we are supposed to know. How many of you here are CEM? Raise your hand. Only one. How many are CEA? Raise your hand. It's unfortunate. When we conduct training for CEM, CEA to be accredited or recognized by the DOE, mostly I can see are mechanical engineers, some are civil, some are ECE. Why can't the EE become a CEM or a CEA? I think you need to focus on that because I know that every company is required to have a CEM or a CEA. All right, let's go to the next. We know that the coefficient of performance is very important, and we know that every 1.5 kilowatt of electric power consumed has a cooling effect of 3 kilowatt effect to be delivered. When you conduct an audit, you will have to measure those things at least somehow. And then we have to look into the coefficient of performance, which is the most crucial parameter to measure and calculate the piece of heating and cooling. Okay? Okay. Now, this is also a measure of energy efficiency ratios. These are just examples of formulas that normally you could probably use. Let me see if I can try. That's not okay. It's okay. All right, so again, here are the retrofits of your mechanical systems. Some of you may be electrical mechanical engineers, and I know that if you are electrical mechanical engineer registered, then you know these things very well. Okay? But if you are not, electrical engineers also know something about mechanical, especially when loading is required or even some operations of the motors are required. So let's move into the next. How to understand the HVAC operations and maintenance. I think you know this also very well, but what is important is we need to know HVAC system's objective is to add or remove heat and moisture to maintain appropriate environmental conditions. During audit, we are supposed to look into the quality, indoor air quality of the facility, just like this one. If the indoor air quality is poor, that means it has a lot of particulates. That means if 1 or 2 people are sick, then practically everybody would be affected. That is why the DOE during the COVID pandemic, rooms are being required to have some exhaust fans so that if there are particulates that are present inside the room, that is brought out using that small exhaust fan. Now, these are some of the things that normally we look at, the rooftop units for retrofit, and VFDs. I'm sure that all of you are familiar with frequency drives. Frequency drives are now used practically in all types of motors, especially if it is for HVAC, if it is for pump and fan, or water, or hoist. All those applications require what we call drives. And drives can actually save you money. Now, this is what I was telling you earlier. When I talk about ventilation, we know very well that in the air conditioning system, there is always some fresh air coming into the system. So that means it's not all within the room that goes inside the room. It has some fresh air coming in, filtered, and then move out again. Mechanical engineers know this very well as well. So what is important is we comply with national and international standards that is under 62.1, indoor air quality standards on ASHRAE. Okay? Now, on lighting systems, I'm sure that all of you probably are designers, but this time we don't really need to be a designer because what we know is when we place the lights that we want, we can do it. But this is important. When we buy our lights, LED lights, we are running from 3,000 K up to about 5,000 K. What is K? Kelvin. We know that as well. This is probably about 3,500 or 4,000 Kelvin. Because it's almost, we call it sometimes cool white. But most of the time, when we design the lighting system outdoor, we use 5,000 K to about 6,000 K level of illumination. Why? Because it has a very high distance from the field, so it has to have a very high illumination level. Now, when we buy LEDs, we look at what? CRI, or color rendering index. When we buy a level of 0 to 55 CRI, that's very poor. But when we buy 75 to 85 CRI, it's good, a little expensive. But when we buy 90 to 100% CRI, that becomes excellent, and that is quite expensive. I know that many of you are aware of that, but I'm just saying this is something that sometimes when we replace, during audit, say supposing, during audit we found that these are all halogen lamps, assuming, and we would like to change that to LED, that means the level of illumination under lumens per watt, we have to change that. And you will notice that the capacity of that is also changed. So here is what I would say, warm white, cool white, and daylight. Okay, that's how it goes. And then, when you audit, say supposing management says, okay, I want to replace all my lights in the plant to LED. From there on, just the level 1 audit, on walkthrough audit without measurements, we can already measure the savings the company can make. Look at this. If we're looking at 1,100 lumens, and if we use, say, incandescent, that's about 75 watts. If it's HID, 53. If CFL, but look at this. LED is already 10 to 15 watts only, so you have a savings of what? It's a big one. So from there, when we audit, we can immediately compare the expenses and the savings it can create. I think all of you have changed your lights because it's also being required by the DOE. Okay? So that's how it goes. So from here, you will notice immediately what is the savings that you create. And these are, when you replace ballasted lights using troffer type. You know the troffer type is rectangle with reflector. That's troffer type. And you may have there 2 lights, 3 lights, or 4 lights with the ballast. That means when you convert that to LED, you will have to remove all those, compute them, and then when you put that, say supposing we have a 70 watt panel LED, and that 70 watt, when you do that for a standard type, that's probably about 150 watts each. So if you have the ballast plus 150 watt, 150 ballast watt, and so on, so the saving is much, much larger. Okay, so that's how it is. When we audit, this is how we do it. Okay? Now, but listen to this. Having enough light is less subjective than having good quality illumination. That is correct. Less subjective is when you have enough light. When you have enough light, that means we are good. Right now, if I estimate this, the lux level of the room is only about, I would say about 300 or less. Office spaces required by the DOE or under international standard is about 500 lux. But when we visited a lot of buildings and rooms or offices, some of them are 300 lux only. Now some, they don't like to be that 500 lux, but sometimes when you are used to having low lux level, your eyes is adjusted. But when you adjust it to direct level, you would feel like it's too bright. So it depends on how you started using your light inside your office. Okay, there are also some issues about delivering light to the target fixture. If this is my table, the light is over here, that means my light must have to be acceptable to my eye without glare. Without glare. Now these are the suggested standards that we use. When you design, you do this very well. If you go lower than that, that's okay. But if you go higher than that, maybe it's too bright. Basic lighting design, audit procedures. Determine meet the desired light levels, produce light efficiently, and efficacy is equal to lumens per watt. That is the light efficacy. When you use that, that becomes more safe. Deliver and keep light efficiently, measure existing light levels and its operating hours, days, week, and years, compute total wattage of fixtures, including the ballast, single or double lamps, 1, 2 lamp, 3 lamp, 4 lamp, and so on. That's how you do it. So I'm sure some of you are doing it, but when I ask who is a CM or CEA, only one is showing. That means this must have to be understood, or some of you must have to be trained. These are the lighting survey evaluation. I will not discuss this very well, but this is then something that you can probably do on your own. It's your style, your different models. Now let's go to boilers. Right now, we know that there are a lot of old boilers using bunker fuel, some are diesel, and so on. But right now, most of the boilers that I see are electric boilers, which is very small, and the efficiency is about 98%. So these are some of the combustion thermal efficiency. I will not discuss this very well because it's a little bit technical, but I don't want to discuss that. But I just want you to see how it is shown. It's like that. And there is what you call tables on estimating. Now, these are also efficiency by reducing the SCR level. All these are practical use, ensuring that the heat transfer surfaces are clean and so on and so forth. That means when we have these boilers, we have to make sure that those tubes are clean. I know that many of you are familiar with it. If you are not in the plant, you may not be so familiar. But if you are, say, a maintenance guy or facility guy, your maintenance people is under you, so probably you can understand a little bit of this. Now, these are some simple flow. I'm just showing you this for purposes of information so that you know how it flows. And these are the flow. When you are in training, this is what you learn. This is what you learn when you conduct training. These are some of the boilers that we have seen. The large boilers are now reduced to smaller ones and more efficient because of what we call the efficiency of the heaters. And then these are solar thermal systems also that are being used right now. In some large systems, like in other countries, I have not seen one here using the solar or renewable energy solar PV being used for heater or heating or boilers. I have not seen one. Probably I'll see one in a few years. But this is how it's done. Right now, we are being asked by the DOE to actually look into the renewable system. We know that we have a lot of renewable systems here. We have PV solar or solar PV. We have farm on big areas. When I say big farms, these are the wind farm. Okay, we have a lot of wind farm, and there is now what we call a vertical axis wind turbine. We are exploring the use of vertical axis wind turbine in areas where the wind is quite good. And it's not covering a wide area of like the wind farm. It's not. But the capacity is a little low, but you can make them all side by side depending on the wind speed. So the combined heat and power is another issue. Some companies now are using combined heat and power, or CHP they call it. And this is how it goes. So combined heat and power is a powerful way to improve energy, efficiency, reduce emissions, and promote resiliency. Those are just a very simple analogy of combined heat and power. From the generated heat, you create the steam, and that steam, when it's very strong, you connect it to the turbine, and then the turbine will generate connected to a alternator, a generator, and it will actually generate power. So that means sometimes this is an excess heat that is generated by your boiler. So that means CHP saves money because it uses less energy than traditional systems. Also, it saves money by reducing energy losses when you convert energy from one form to another. This is the general principle of combined heat and power. There is no need for me to discuss it in detail because it will take us days. Now, this is a kind of CHP. It's just a simple analogy, how it goes, how it moves, and so on. So you will notice here, power station, and then you have the boiler, you have the heat, you have the electricity, combined heat and power, and the output is there. Your fuel comes here. It needs a design. It's not as simple as we see it. I'm not good in boiler design, I'm not. But we have to ask people who are good in designing combined heat and power using the boilers. For electrical power output, that we can do. But for the mechanical side, we have to ask those guys who are good. Let's go to building envelope. This is one of the things that being asked by most clients. Remember, when we audit, it's not only because the air conditioning system is working. We have to look into what is happening to the confined walls of the facility. If the facility uses only very light materials that during summer, the heat is radiated from the outside inside. So what happens? The air conditioning system must have to work more than it should not. So that means that it's also being tested and measured when we conduct audit. So that is why when we have, say, furnace, when we have a furnace in the plant, we have to know whether the heat is leaking, the heat is leaking. And if it is a storage, of cold storage, we have to know also whether that coldness inside is also leaking. And that is a loss. So those are even measured the same way. But for building purposes, like if this is a building, this is the face of the building, and this we have a window pane, glass pane. That means the kind of glass that we will use must have to reject UV and heat transfer as much as possible. You will notice that a lot of high-rise buildings now, they don't have much of this drywall or concrete wall. No, most of them are glass. Why? Because they want to minimize the use of electricity through the lighting. However, what happens is if the heat transfer from the building, from the sun outside, going inside, the more we will use the aircon. So what they did was to make sure that the glass pane or window pane are capable of not transferring the UV and so much heat. Probably the heat transfer is only about 20-30%, but that is very expensive. So you will notice the design now of envelope. It's becoming more sophisticated. Okay? Now, why do we need building envelope considerations? One, impact on equipment, HVAC, perception of well-being occupants. Kasi pag mainit na sa loob, sa sobrang init, kahit na may aircon at mainit pa rin, ang mga tao sa loob ng opisina, maapektuhan. Now, the reverse, pag naman sobra ang lamig sa loob, at naka-jacket ang mga tao doon sa opisina, ang ibig sabihin nun, the temperature is too low. Kaya ang sinasabi ng DOE, as much as possible, it should be within the range of 24 degrees C. But that is not also true. Like here, we are compute that. And then the heat transfer from here plus the aircon, that means the aircon cooling must have to be lower. Or if there is sun coming in, that means we have to bring down the temperature as well inside. So that is how it's done. Again, the problem with retrofitting exists when there is technically the design system is good. Upgrading the changes, of course, are costly. Now, these are some common terms that we use. For building envelope, they call it building enclosure. That is correct. I was in construction for almost 40 years. And when I had my construction also in the US, for small buildings, they use only very few concretes, except for high-rise buildings. In the houses, most of them are drywall and wood. So when there is fire, everything is down. Not like in the Philippines, practically even a small house or whatever are all CHB or concrete. So, ang natatanggal lang doon pag malakas ang hangin is bubong, yung roofing lang. Pero sa US, most of the construction there, even for small malls, are drywall. And of course, sa labas is a different kind of concrete. It's just like plaster. Okay? So dito iba. Now, the building envelope, often referred to as the facade and roof, consists of the thermal, weather, and air barriers separating the building. And that is correct. Ang design ngayon ng mga bagong tinatawag na green building designers are following that. Thermal, weather, and air barriers. In Quezon City, where our office is, when you go beyond 2,000 square meters of space, they would say you have to go green building. So it means you will have to use LED, you have to use STP, you will have to use so many things and drives. The more, pag tumang ka sa Makati, all of the buildings are LEED building, LEED, and green building. Yung nasa taas na yan, makikita nyo halos lahat glass. Those are very efficient buildings, but even if they are so efficient, they still require some sort of audit regularly to make sure that their operation is compliant to LEED compliant. So yun ang palaging sinasabi dyan. Thermal envelope is very important. Thermally envelope is also very important. I will not discuss that because I want to make sure that I can show you that and I don't have to be very detailed on it. But these are part of thermal envelope. And thermally envelope heavy is that they use materials, iba ang ginagamit pag thermally designed ang building. Iba. Iba siya. Mas mahal. Ikaw ba naman magpapagawa ka ng building, lahat susundin mo yan? Siyempre, hindi. Because you have your budget. But look into Saudi. I gave examinations to Saudi in 2001, 2 and 3. Ang building doon, lahat thermally designed. Why? Because the heat is so high. I mean, the temperature is about, in degrees, siguro maabot sila ng mga 100 degrees. Kaya pagka doon tanghali, halos walang lumalabas. Lalabas lang sila when probably mga 6 p.m. na. Because during the day, sa umaga lang, tapos tanghali, walang lalabas yan. And I said, why? Ang sagot sa akin, sir, kasi mainit. So what happens to those buildings? Oh, those buildings are designed properly. Sabi ko, wow, okay. We don't have that. So here is the heat gain and heat loss. This is just a simplification of where the losses are. The losses is 25%. Sa ceiling is 25 to 30%, walls 15 to 25%, floor, and so on. Makikita niya, no? Yan. Lahat yan. We do not compute them. We only analyze them. If you want to compute them, go one by one. But we will not do that because it takes time. So mangyayari dyan, ganyan. Okay? Makikita nyo heat loss, infiltration, ventilation, conduction, heat gain, infiltration, ventilation, conduction, solar gain, and internal loads. Lahat yun magkakasama. Okay? Now here, air infiltration and leaks. Alam nyo ba, I recently met some guys from SM chief engineers and I asked them about infiltration of leaks. They said, ang kanilang designer has actually provided parang leak prevention sa mga pinto. Hindi siya, yung lamig hindi lalabas at yung init sa labas hindi papasok, yung ganun ang mga distance nila. Now, you cannot prevent leak from the inside and from the outside and from the inside to the outside. You cannot prevent that. It's very hard. That's very, very hard. Now, these are the heat transfer. I think you know this very well. Convection, conduction, sources, and radiation. These are the basis for conducting building envelope. This is how we do it. Comparison ng window. Totoo din yan. Sa atin, ang windows are just very simple. But makikita niyo yung mga good windows, when you close it, you don't even hear something outside. Why? Because it's double pane. Merong vacuum sa gitna. Mahal yun. You will notice that when you close a window, you don't hear anything from the outside. Why? Because it's just like a sound barrier. There is a sound barrier. We design sound systems, by the way. So, if this is one side of the glass, there is small space there, which is very, very small, and then another glass. So there's a vacuum in between. So there will be no sound penetrating on the other side. You know that? That's how sounds are transferred from one side to the other. Dito naman, lalo sa Europe o sa US na merong malamig talaga, meron din silang ganyan. Pinag-iingatan yung papasok na lamig, yung draft. Yung draft galing sa labas, papasok sa loob, yun ang pinag-iingatan nila. Okay, sa roof, ito na, wala nang issue dyan. Ginagawa nating kalimitan dyan. Ito, motors and drives. Lapit na tayo. Motors and drives. I think all of you are familiar with this. And this really provided, motors and drives started in the Philippines, I think, in 1970s, when ABB started it, and then afterwards, many companies already started to sell frequency drives. And all of them have also practically the same functions, except for the quality. When we replace motors, especially if we're replacing standard motors, supposing our plant has been there for about so many years and my motor is already 25 years old, and the efficiency is very, very different, you cannot connect, for an old motor, you cannot connect frequency drive. You cannot. I tested it. When you run the frequency, when you run the motor at say 30% only on frequency, umiinit siya. Why? Because the motor is not designed for that. When the motor, like high efficiency motors or the new motors designed now, when you run it at even 10% of its speed, it will not heat up. But technically, the minimum speed that we normally use is about 20 to 30% minimum. And we can run it at about 40% only because we used to carry vacuum drive from Finland for the last 10 years. All drives are practically the same. It depends on how it is constructed and so on and so forth. That's why I don't have any problem. See here, the high efficiency motors are now the one that is being introduced in the market. So when you replace your motor, some people say, oh, sir, masyadong mahal yan. Lalo na if you have about 250 kilowatt of motor, you will have to do it. Sir, pa-rewind na lang natin yan. True, it's good, okay. But remember, when you rewind a motor, it will not be the same as the original. You know why? Because you have to compute the magnetic flux inside. And what we do here, bibilangin lang yung number of turns, anong size ng wire, anong klase ng insulation, barat, banat. But what happens is that, kung halimbawa 1,000 watt, kunyari 1,000 kilowatt yan, magiging 800 watt na lang siya. So the efficiency is lost. But some rewinding companies in other countries are almost the same. That's how I found it because I stayed in the US for almost 5 years and nakita ko yung diferensyang yun. Sabi ko, galing pala dito, ganyan pala. Dito sa atin may magagaling na rin. I cannot say that it's not comparable, but they have now very good also technology being used. So these are the motor rewinds, I told you. Ang pinag-uusapan, 60% lower lang. Kung if it is a big motor, yes. If it is a small motor, say about 5.5 kilowatt, 15 kilowatt, kung ang motor mo kailangan ng critical load, bumili ka na lang. O gamitin mo dun sa non-critical load, pa-repair mo, gamitin mo sa non-critical load. Pwede yun. Pero gagamitin mo sa critical load, then you need the speed properly, you will lose. Voltage imbalance, I think you know this already. We cannot go beyond voltage imbalance of 3%. We can have to go at least 2% to 1.5%. You're safe. These are the single phasing in case we have a problem we have a detector or sensor for single phasing. I hope you can visit our booth below, Westco down below. We have those monitoring systems that you can detect whether they're single phasing without having to have a failure very, very large. And you can do it online. Now, this is the motor part. Larger motors are more efficient, and for 1.5 horsepower, efficiency is relatively constant at 50 to 100% load. Tama naman siya. That's correct. And then, what are the benefits of VFDs? I don't want to discuss this with you because I know all of you know this. But as part of this presentation, I think these are the benefits of having your VFDs. Those who have not connected or installed VFDs, try to think. It may be a little bit expensive. Your first cost is expensive, but later on you will save. Okay? But you will have to have good guys. Of course, the disadvantage, you know what? You will create a lot of harmonics. That is the issue. That is the main issue. When you have a lot, say, supposing this is the plant, and I have motors only of about 10, I can connect the VFDs there, that's okay. But when we have 20, 30, 100 units of that, even the small ones, my harmonics level at this source will be very high, and we will have some problems with our electrical system. That is why you will have some heating, you have some nuisance stripping of your breakers. When you have your neutral wire will heat up. Your PLC software will sometimes be corrupt. Those are true instances of what happens. There are positive and disadvantages of having VFDs, but the disadvantages can be remedied. It can be corrected. Later on, I will show you how it can be corrected. And that is what we do. Look at this. Initial cost is high. VFDs and associated components, complexity in installation and maintenance. Hindi mahirap ngayon mag-install ng drives. Kasi from the motor, ito ang drive, yan lang, tapos source. Tapos itong motor mo, nakabit na dito sa load. Yun yun. Now, if you are designing a different way of doing VFD controls, say supposing water district or different water pumps, then you will have to do some sort of alternating operation of VFDs. Say supposing I have 10 VFDs and running different motors, we can program that if you want to. Something like that. Okay? But that is how the VFDs are run. After doing all those things, if you audit, you are asked to do this. What are these? You have to learn the economic analysis. Remember, when you are to audit, you will be asked by management, okay, how much will it cost? Yun ang tatanong. Do we have the budget? I said, babala pa tayong budget. Kukumpitin mo ngayon yan, papakita mo ngayon kung ano yung mga papalitan, anong bibilin, anong i-construct, ito-total mo yon. At sinabi nyo kaya, sir, 100 million para makorek natin ang buong system. Ha? Do you have the budget? No. Sir, unti-unti, pwede yon. This is how an audit is done. But you have to learn all these analysis. And you have to look at the time value of money, present value of money, life cycle cost. Ang life cycle cost, and when we buy a motor, we should estimate how long will it cost, how long will it last, and what time is the cost, what are the maintenance, that will be the life cycle of the motor before you replace it. Okay? And making judgment in a rational and complete manner about the cost effectiveness of a project, which of the following projects is the most cost effective. Kaya, if you are replacing something because of the audit, you have to do this. Now, of course, we are not accountants. We are not. But we can ask our accounting or finance guy to help us. But we will provide them all the technical aspects and the costs required to replace and construct. And then they will help us provide what is the payback period of our investment. Something like that. And when we say, supposing we have a problem or we have already estimated the cost, if the internal rate of return is good, is high, the project is good. But if the internal rate of return is low, it will not push through. That is how the finance people will look at our project. That's how. Okay? And this is how we do it. I will not discuss that, but that is the way we do it. Of course, we are not, again, accountants, but we can ask those guys, our accounting guys, to help us. All these are just, I'm just showing you to show you how these things are done, not necessarily us. Energy reports, we have to do the reports. The reports must have to be completed by us. Now remember, since we are not accountant and we are not, say, we are a CEM or CEN and we are not mechanical engineers, so if I'm the CEM, I will have in my team mechanical engineer, I'm electrical engineer supposedly, so I have a mechanical engineer, I have a finance manager, I have an accounting manager, I have the maintenance manager, I have the engineering manager, I have the audit, finance audit. Those are the people below you. So you build up the team. So if I'm the head of the energy team, I will be the one reporting to management. Okay? Now, energy reports, if you are doing your audit, you will know this. I will not discuss this lengthily, but these are the things that you need to understand a bit. Let's go to electrical power systems audit. All right. How many of you are familiar with, I'm sure that all of you are good at putting up your capacitor bank. Raise your hand. All of you, okay? In most cases that I know when we were doing audit, the capacitor bank with some reactors or without reactors is from the point of common coupling. Most of them. This is your transformer, this is your bus bar, this is where your capacitor bank is, and these are the loads. When you put that there in front of the point of common coupling, you are averaging the load here. It's not. It should be close to the load. If this is your bus, this is your capacitor bank, this capacitor bank, and these are the load. If my load here is critical, I have to measure my power factor and harmonics level here. Say, assuming we have that and the power factor is about 79. When we improve all the capacity power factors here, the harmonics level here, you will notice that your power factor will go high. 100% yan. But most of the buildings that we have seen, they're used to having a point of common coupling. That's normal. But this is the way it should be. If you have your reactors, this is the way. And you can be sure that your output will be much, I would say, stable. Pindutin mo nga. Okay. Diyan ka muna. Okay. Hindi. Hold on. Yan, pindutin mo. Okay, pindutin mo lang ulit. Okay. What is more important is another issue. It's grounding. I know that many of you are aware that grounding creates fire. It creates fire. It also affects the people working within the facility. So that is why you will notice that all plants, practically all plants, every year they are being asked to have that grounding be tested continually. Now, you may not probably aware of that all new buildings now are using 400-volt line. They are not using the 480, 460 line anymore. We are using the 400 line, so the line to line is 380 volts, and line to neutral with ground is about 230 volts. Why? Because that is the real standard under IEC. And when you go outside of Manila, like co-op, electric co-op, you will notice that they're using line to neutral and ground. Kaya mas tama sila. Because we were following actually the US standard, which has been here for quite a time. That's okay. But because of the necessity of improving safety, line to neutral is good. Because once there is a fault, it will trip. While doon sa 460, 480, 220, 240, it will not yet, unless it's a solid fault. Okay? So harmonics, these are the effects of harmonics. These are all because of VFDs and so on and so forth. These are all what we have found. Okay? So I will not discuss that every item, but I think you are also familiar with that. Harmonics analysis, look at this. The following symptoms are examples of equipment failure and misoperation. This is overheating of motors, cable, transformers, neutrals, motor vibrations, audible signals on transformers. When we were testing power transformers, some clients would say, oh, sir, our transformer is, it has a sound very high. Sabi namin, why? We don't know. And the load is only I think the load is only 40%. And we will have to test from the entire thing, from DGA, for the oil, when you have the insulation power factor with the transformer, exciting current, and so on and so forth. And we could not find anything. Everything is good. So the only thing that we are looking at is harmonics. When harmonics is very high, the vibration of the transformer is also affected because of the frequency. So, if you are not familiar with that kind of symptoms, you will not know exactly what to do. But that's just okay. If you have some people who know how to test it, they will know. So these are some solutions that normally we conduct. We have a system here, and we have the UPS and so on. All these are connected, and then the output would be just almost on your right. If you have, without the active filter, you will have a problem with all these multiple frequencies. When you go out, it's outside going to the load, it's almost perfect. But there is no perfect sinusoidal wave, okay? There's no perfect. It still has some sort of ripples, very small ripples, but you can see this is almost perfect. This is now the trend that we use. We use this trend because it reduces the problem of flicker, and then yung unstable voltage. Okay, what is important, if you have your filters corrected and computed properly, it should stabilize the voltage and the current. And your power factor is also within 99.9. Now, you don't go beyond 99. Whenever we suggest power factor correction, I only suggest up to 98%, because if you are using your standard type of power factor passive type of power factor. Once you have some problems at site, it may go 100% or more, and you will have some problems. So that's why, if it is using an IGBT type of switch, then your 99.9% may be stable, because it's an automatic thing that happens. Okay? So those are the things that we normally do. So what are the solutions? These are the solutions normally that you do. Harmonic current compensation, reactive power compensation, and load current balancing. When you corrected one, it should correct all your load balancing as well. It may look so technical, but it's not so technical. It's not technical. Very easy. So these are the harmonics determination. I will not discuss that. I'm sure you know that. And we know that the present day condition has a lot of single-phase non-linear loads, high currents in neutral, power supply generator harmonics, installation are grown up, and so on and so forth. These are the components that we see in the new. Sometimes maliit lang ang opisina pero puno ng AC-DC converters. Actually, LEDs has AC-DC converters, but because it's very small, ang effect niya sa harmonics is not so much. But when you have larger system, then the LED can also be part of your harmonics. So present day conditions, I will not talk to you about that, but when you have when I say bad, not properly designed capacitor banks, it will only last for 2 years. I have seen a lot, good brands, but because the design is not properly made, after 2 years, it's already leaking. Nag-overheat, nagli-leak, sumasabog. And that shows that the design is not proper. If the design is good, the life of the power factor with harmonics compensation or harmonics mitigation is about 15 to 20 years. If properly corrected and measured. By the way, before you even do that, you have to measure it properly so that we can analyze and make the computation good. Because if it is not, kasi mura, ayun, 2 years lang. I've seen a lot of that. And we have seen a lot of that. So this is what happens when we have some problems with that. And so of course, we will not do this. And we follow these standards. Whenever we design capacitor bank, we follow 519 and even the IEC standards. That's we follow. So this is where when you have your power factor correction, look at that, the example, without compensation, you have that problem, and with compensation, of course, the total is 100%. But this is just an illustration. Normally, when we suggest, we only suggest about 98, 98, 99%. I can suggest 99% when we're using an active filter or active capacitor bank. Because if it's not active, and there is a system breakdown in the plant, and it's not your step, remote controller does not work, you will have an over 100% power factor, and you will have some breakdowns in the system. All right, these are basic unbalanced voltage. I don't have to discuss that, no need. Active filter solutions, yes. You start from there, you go to the next phase shift, and load current, and so on. So this is a simple analogy of a simple work. This is the active filter, this is your harmonic load, and this is what you get out of that. You have to measure all this, you have to bring it down to almost 5%. According to IEEE 519, a series of 2014, it should be at least within 5%. Below 69 kV. Okay? That's how it should be. Now, you can bring it down to 6% or 7%. That's okay, because it becomes more expensive if you bring it down to 5%. 7%, 8% is not bad. So this is how it's done as well. When you have a system like that, this is the point of coupling I was telling you about. This is the point of coupling where you have your capacitor bank there, and this is your bus. Okay? So that's how it looks. Very easy. And how it is connected. This is an open loop. It goes directly to the load, and it may go directly to the overall load. But my suggestion always is use it independently on critical loads. If you apply it on a critical loads, you go directly to that. If you do not have any critical loads in the entire bus, just let it that way. It's very easy. It's cheaper. Okay? So how it goes the same way, but this time you can also connect it with the renewable energy. Now, renewable energy generates a lot of harmonics. Why? Because you are using the inverters. And one inverter is about 100 watt, 100 kilowatt. If you have a 1 or 2 megawatt or 50 megawatt, then you have a lot of inverters, and harmonics would be very high. That's why I learned that NGCP is requiring all solar PV developers to make sure that the harmonics being brought up to the grid is within limit. It's within limit. Now, if you have your own harmonics PV system in your facility, that you have to look into as well. So this is how it looks. But the solution is static VAR compensation. There are two types of VAR compensation, of voltage of VAR compensation. One is VAR compensation, static VAR compensation, and the other one is StatCom. Okay, so that is it done. This is simple layout. And then typical installation. And then static VAR compensation, this is what happens. You will notice that static VAR compensation, when there is already your output, there will be the same frequency that is opposing the first frequency so that it becomes more stable. So there is an opposing frequency there that you see. So typically, it's like that. And then the SCATOM is synchronous compensator. These fall renewables as well. Almost the same as that, but but the different compensation is more reactive for a harmonics and unbalanced load as well. So these are the control circuits. Well, this is containerized, by the way. This is containerized. Now you will notice here, you apply it because you have a flicker, yung mga ganun-ganon. If your system is very sensitive to flicker, even for milliseconds or microseconds, and there is a fluid running and there's a change in voltage or operation, it will affect your output. So that's why, in order not to affect the output, you have to make sure that the flicker is controlled. Look at this, providing reactive power for voltage control requirements, wind, solar, PV, and other generating loads. If you have your own solar PV, probably think of it if it is a large one, to make sure because remember, when you have a solar PV, the output of that is connected to your main panel to add to your load. And sometimes you will have your battery storage system. So these are how it's applied. I will not discuss that. Now, these are the different types of StatCom use. Look at this IGBT and this is Tyrostor. Both of them has very high speed. That's why When you put it online, it's almost online, but there's also some delays, but very small. This is used for large systems as well. That's it for to me. Thank you very much for listening. I hope you learned something out of it.
Thank you very much, Engineer Peñalosa. So, for our crowd, do you have any question po? This is your opportunity to ask directly po kay sir. Ayan, any question po from the crowd? Ayan. This is your chance. So if none, then we will proceed with our awarding of our plaque of appreciation. This plaque of appreciation is presented to Engineer Rodolfo R. Peñalosa for imparting valuable insights as technical research speaker on the topic Electromechanical Systems Energy Efficiency Effects, Power Quality, and Consumption during the technology trends in electrical engineering, present and future innovations in conjunction with the 50th Annual National Convention and 3E Expo 2025 with the theme IIEE, celebrating 50 years of integrity, innovation, empowerment, and excellence. Once again, let us give a big round of applause to our technical presenter. So for those po na magla-lunch, you may proceed. However, yung sa magsa-stay, we will proceed with our first sponsored technical presentation for the afternoon. So I know nandyan pa din naman po yung online. Thank you for staying. I will be now introducing our first speaker for our afternoon session. Okay, so I hope for those po na magla-lunch, I hope you can still return at 1 p.m. hopefully. So we will proceed with our next speaker at exactly 1 p.m. Thank you very much and enjoy po your lunch.
The Institute of Integrated Electrical Engineers of the Philippines, Incorporated, IIEE, is thrilled to invite every electrical practitioner and innovation enthusiast to the biggest gathering of electrical, energy, and electronics sectors. 3E Expo is the IIEE's premier event showcasing the transformative power of innovative products and services from industry-leading companies. 3E Expo expects to gather 200 leading companies to unveil their latest breakthroughs and solutions. This year's 3E Expo will put a spotlight on cutting-edge technologies by featuring renewable energy solutions and display of electrical vehicles. 3E Expo is poised to be a catalyst for endless possibilities and new ideas. The 3E Expo will certainly be a venue of unparalleled networking possibilities, as IIEE expects more than 15,000 trade visitors. 3E Expo is not just an exhibition. 3E Expo is a journey into the future. Together, let us all witness revolutionary designs and technological solutions that will shape the world as we know it. So what are you waiting for? Mark your calendar and visit the IIE 3E Expo.
IIEE is celebrating its 5th decade. From the spark of vision of the IIEE's founding fathers to have an organization for the Filipino licensed electrical practitioners. We are now celebrating the 50th Annual National Convention and 3E Expo 2025. Driven by the 4 core pillars that define us: integrity, innovation, empowerment, and excellence. We would like to invite all IIE members to witness the next wave of innovation for the electrical engineering industry. The 50th Annual National Convention and 3 Expo 2025 will be held at SMX Manila on November 26 to 29, 2025. See you all there.
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you, and have a good day ahead.
This year, the Institute of Integrated Electrical Engineers of the Philippines Incorporated celebrates half a century of its commitment to integrity, innovation, empowerment, and excellence. We come to witness how IIEE evolves. 3E Expo as the IIEE's biggest product exhibition to converge the 3 E's, electrical, electronics, and energy sectors in one grand venue showcasing the latest trends, products, and services of the participating companies from local and abroad. As the Vice President for External Affairs, and on behalf of the Exhibit Bureau for the 58 years of IIEE, I take pride in saying that the 3E Expo is a testament of progress to electrical engineering innovation and transformation. For this year, 3E Expo 2025, in line with the IIEE's celebration of its golden year, we recognize the transformative potential of artificial intelligence in shaping the future landscape of the electrical engineering industry. Come and witness the limitless possibilities of the electrical engineering industry with AI and other exciting activities that the participating exhibitors have prepared. Visit the 3E Expo 2025 that will be open to the public on November 26 to 29, 2025 at SMX Manila, Pasay City. See you there.
Welcome to the Institute of Integrated Electrical Engineers of the Philippines, a professional organization of electrical practitioners founded in 1975 with the core values of integrity, innovation, empowerment, and excellence. For 50 years now, IIEE has been a cornerstone in advancing the electrical engineering profession, fostering leadership and growth within the dynamic industry.
This year's annual convention is especially meaningful as we inch closer to the historic milestone, IIEE founding anniversary. We are not just merely commemorating the anniversary of IIEE. We are traversing the pages of history to write the remarkable story of our institute. To my fellow electrical practitioners, join us.
On behalf of the Council of National Presidents, we would like to invite all of you to our 50th Annual Convention and 3E Expo on November 26 to 29, 2025 at SMX Convention Center, Pasay City.
This year, we gather at SMX Manila, a space that perfectly blends innovation and excellence to host our 50th Annual National Convention. An event that will bring together experts, leaders, and practitioners to explore the latest trends and advancements in electrical engineering. Behind the scenes, our dedicated committee members work tirelessly, ensuring that every session and discussion is impactful, providing valuable insights to attendees. Our seamless registration process to efficient kit distribution ensures that all our attendees are ready to experience the full scope of our event, from intuitive technical sessions to exciting networking opportunities. Our technical sessions cover the most innovative topics in our event, where experts present cutting-edge knowledge, experience, and research, empowering our community with the latest trends in electrical engineering. We believe in the importance of balance with a healthy mind and body. So, alongside intellectual stimulation, we offer sports activities to foster teamwork and healthy competition among our members. Our exhibit areas are buzzing with innovation as leading companies showcase groundbreaking technologies and solutions that are shaping the future of electrical engineering industry.
3E Expo as the IIE's biggest product exhibition to converge the 3Es, electrical, electronics, and energy sectors in one grand venue showcasing the latest trends, products, and services of the participating companies from local and abroad.
The Golden Pavilion is a special highlight of our event where we celebrate the outstanding achievements and contributions of our members and partners. We are proud to present our showcase of electric vehicles, an inspiring glimpse into the future of sustainable transportation and energy. Our B2B Dinner and Exhibitors Night is a relaxation event that brings together leaders and industry partners to build valuable relationship for networking and potential collaborations. And of course, what would an event be without a bit of excitement? Our raffle draws bring a thrill to our attendees with fantastic prizes up for grabs.
We are bringing 2E vehicles for our fabulous prizes during raffle draw.
At IIEE, we also celebrate the involvement of our regional chapters, acknowledging their dedication and contribution to the growth of our profession. Join us as we mark our half-a-century milestone with remarkable innovation, progress, and contributions to the field of electrical engineering. We will celebrate engineers who have shaped the world with their expertise and vision. And we invite you to be a part of this unforgettable event, where we will reflect on the past 50 years of growth in our field, recognize outstanding achievements, and look forward to the future of electrical engineering.
Greetings, all licensed electrical practitioners. We would like to invite you all on our 50th Golden Annual National Convention and 3E Expo on November 26 to 29 at SMX MOA.
As we celebrate 50 years of excellence in electrical engineering, together we continue to innovate, empower, and excel as leaders in the electrical engineering community.
It will be a very exciting Golden Annual National Convention. Mabuhay ang IIE!
than 4 decades, IIEE has always been committed to its core values of integrity, innovation, empowerment, and excellence. Founded on September 15, 1975, the Institute of Integrated Electrical Engineers of the Philippines, Incorporated, IIEE, is registered with the Securities and Exchange Commission, SEC, as a non-stock, non-profit technical professional organization accredited by the Professional Regulation Commission, or PRC. IIEE started with 500 members and now has grown to a more than 60,000 membership base, with local and foreign chapters in active service across the whole world. Through the years, IIEE continuously commits to upgrade the professional credentials of its members through the Continuing Professional Development or CPD programs, enhance their social standing through the promotion of high ideals of integrity and ethics, facilitate advancement of technology transfer through carefully conceived educational and training programs, and provide opportunity for regular interaction among electrical practitioners. Inspiring future electrical practitioner leaders, IIEE organizes activities such as conferences, conventions, and exhibits showcasing the latest technologies, trends, products, and services relevant to the industry, motivating the members to be globally competitive and be able to adequately adapt to the changes, needs, and developments that constantly occur in the electrical profession. IIEE activities are planned to be a venue of endless possibilities, new ideas, and valuable market trend insights on energy-efficient products and services.
So our delegates po outside function room 3, you may proceed inside so we can start with our afternoon session. And yung mga nasa likod po, you may occupy the seats here in front para makapagsimula na po tayo. Thank you very much. So once again, our delegates na nasa labas po ng function room 3, you may now proceed inside so we can start with our afternoon session. Sige. So ladies and gentlemen, welcome to the afternoon session of our third day of our technical sessions. So, let us begin our afternoon session. Our speaker is Tumay Caraver from Alps Mountaineering Services Incorporated. He is an accomplished and highly experienced executive with over 2 decades of expertise in predictive maintenance, conditioning monitoring, and industrial technology. As Vice President of Artesis Technology Systems, Tumay Caraver has been instrumental in driving the company's global growth, leading international sales, business development, and strategic initiatives. He possesses deep technical knowledge of rotating machinery and a proven track record of building and managing global partner networks. So once again, let us all welcome our first speaker for this afternoon to discuss electrical signature analysis, intelligent conditioning monitoring without sensors, Mr. Tumay Caraver.
So welcome everybody. Yeah, as you can see, we are going to talk about sensorless condition monitoring. So you may ask yourself, what does that mean? Since this is, the audience here mostly consists of electrical engineers. Essentially, this approach is turning electrical signals into condition monitoring technology without using sensors. Essentially, voltage and current are the foundations of this approach. So here is our agenda. Let's take a look at it quickly. So we will look into what is condition monitoring for those who is not familiar too much with this subject, and then where does the electrical signature analysis comes into picture, and how does it help, and how it is different than from other techniques that are used in the industry. And then we'll look into some case studies and some additional features that this technology brings into table, namely pump performance monitoring, as well as the use of latest technological developments, which is generative AI. And we will close our session with that. And because of the time limitation I have, I'll try to be quick and concise. So let's start with condition monitoring. So again, condition monitoring is sometimes used with other terms such as predictive maintenance, preventive maintenance, and also condition-based maintenance. Essentially, they all mean the same thing, meaning that condition monitoring is measuring different parameters of rotating assets to keep track of what is going on so that you have knowledge and data, and that will tell you, what is the condition of the asset, whether these are electrical or mechanical or sometimes process-related issues. So, what does the condition monitoring try to achieve, right? So, first of all, you need to establish the condition of the asset in order to have sort of a baseline. And of course, that will help you to keep track of trend changes, whether they are for worse or for better. And of course, essentially, you are aiming to do maintenance actions based on this information, which will help you to reduce your downtimes, unplanned downtimes, and increase the asset availability on your plants. And additionally, of course, you can have maintenance plan accordingly by looking into the severity of the problems, so you can schedule your priorities accordingly and decrease your maintenance cost. And one additional thing, of course, is something that I'm going to talk about too. Starting from the basic one, basically this has been around for, ever since the machines have been started to use in the industry, visual inspection. So you look at it, you can see the problems or you can hear them, but by the time you can see and hear the problems, it will be too late. So hence you're actually using some other techniques to predict and prevent the failures before they cause unplanned downtimes. So the most common technology that are used in the industry is vibration, and this is usually for mechanical engineering, but also, of course, it's part of the same maintenance topic. So, we'll have to look into that. And ultrasound analysis. So these two are again using sort of similar approaches. Ultrasound being a high frequency analysis. Vibration is again looking into the mechanical problems. Thermography analysis is good for electrical faults, as you can see, using different thermal cameras, the hot spots on the rotating asset, and therefore, of course, prevent or correct the electrical issues. Another technique that is used in the condition monitoring is oil and particle analysis. This is also mechanical related, usually It's an expensive approach for gearbox and fluid bearing analysis. Now, this takes us to the electrical signature analysis. So electrical signature analysis has also been around quite a while. It started in late 70s, early 80s as only motor current signature analysis. And this came from the initial nuclear applications where access into asset was difficult. So they came out with this motor current signature analysis to be able to detect predominantly rotor bar problems. And then, of course, this also over the years have evolved from motor current signature analysis to electrical signature analysis, which is using both three-phase voltage and current. So let's look into what electrical signature analysis is. So electrical signature analysis, sorry, one more slide. Yeah, we talked about the MCSA, which is again motor current signature analysis. Now, electrical signature analysis is a technique where you would combine both voltage and current and try to see the incoming problems as well as the problems that are coming from the current side. And so here, of course, what we are going to focus on is the model-based electrical signature analysis. What does this mean? This means that this is the pinnacle of electrical signature analysis, where you not only use voltage and current, but you actually deploy a machine learning algorithm and turn the motor itself into a sensor so that you can detect all the electrical and mechanical problems altogether from one single connection point, which will be your motor control centers or switch gears, and you don't have to deploy any other sensors on the assets. So let's look into what is this model-based electrical signature analysis look like. So essentially, we start with waveform. By the way, this technique is listed in the International Predictive Maintenance ISO standards. You can see the dedicated chapter over here. And if you guys are interested, that can be sent to you later on for a deep dive. So let's see again how this electrical signature analysis is deployed. So you start off with your voltage. So any industrial motor, you supply a three-phase, whether it's low voltage or high voltage. What happens is that you induce actually an electromagnetic field between the air gap of the rotor and stator. And normally that is a uniformed electromagnetic field, meaning that it is equally distributed. And then your rotor starts to turn, and that causes current withdrawal, right? So if you have a clean sinusoidal voltage waveform and motor is in a good condition, the air gap is uniform, you would expect to see a clean signal like this, the sinusoidal or close to perfect sinusoidal current waveform. So essentially your voltage is here is the cause of actually the current. So now let's analyze this current signal, because I mentioned that MCSA or motor current signature analysis was initially how this started. So now for the sake of easiness and simplicity, I'm just going to look into a single phase, but keep in mind that this has been done for all three phases. So this is a perfectly sinusoidal current waveform shape. So now when we compare a single phase input, which is the blue one, the voltage, and you're seeing this distorted current red waveform shape. So where did this come from? Why the waveform is distorted? It is distorted because the mechanical anomalies in the motor actually distorted the uniformity of that electromagnetic field we were talking about, and essentially causing motor and rotor to try to make up for that friction in the system. And of course, you will see now why that's the case. So again, now you can see the distorted signal overlaid or overlapped onto the sinusoidal waveform. So we don't really understand, what's going on here because it looks messy, right? So what we'll have to do is we need to identify the individual components or those distortion. This is essentially done with FFT analysis. And for those of you who's not familiar with FFT, it's fast Fourier transformation, basically signal processing and identifying and diverging each individual fault frequencies into its own frequency components. And with that, so here you can see the time waveform. That's the original signal that we're seeing over here. And these are the components. So when we turn this signal to sideways, now we can look into the frequency components. So the 50 hertz or 60 hertz is your line frequency, but you are seeing additional frequency components on the same spectrum, which means that these are the additional distortions. And now these distortions can be electrical harmonics as well as mechanical issues, which we will see now. So when we apply a distorted voltage into the motor, you would see the current waveform naturally will be distorted. So this tells us there's two ways that the current signal can be distorted, either from the poor power quality, which was the topic of the previous discussion here, or alternatively, again, mechanical anomalies in the system, meaning that the motor, you have bearing issues, misalignment, cavitation from your pump, and all these will actually distort current waveform. So now we said this is also a model-based approach, which is a machine learning technique. So, and let's take a look at how does that work. So we use here the voltage as an input to the system, and the current is the output. And the motor itself is essentially acting as a transducer or a sensor. So you supply a clean supply voltage, you look at your current waveform, you would expect to see a clean signal. But if that's not the case, then you see those peaks that you see at 150 and 250 hertz. They're not present on the supply voltage. They must be mechanical in nature. So, and this model-based approach is essentially creating a digital twin of the asset, which gives you your baselines over a 7 to 10 day period by looking at the the motor's different load profiles, frequency profiles, basically operational profile. You are trying to cover as much as possible and create a model of the rotating asset. This model also covers both motor as well as whatever is driving and the transmission in between. So here you can see now the digital twin is created through this machine learning technique, and you have the same supply voltage both going into the motor and the algorithm that creates a digital twin. So you estimate what the motor generates in terms of the distortions at the current output. You constantly now subtract, what is actually coming to the motor, and basically it subtract that from the digital twin, which is initially created within that 7 to 10 day period. So the difference gives you your mechanical issues. In this case, of course, it's 0 right now, but assume that this baseline digital twin is created and you started to develop some mechanical faults. Now what's going to happen, you will have additional current waveform distortions on your actual signal, which is constantly subtracted from the learned model, and you will end up with the residual waveform distortions, which are these blue ones over here. So those blue ones, based on or depending on the fault frequencies as well as the amplitudes, you would now have the tools to identify what sort of mechanical issues you're looking at, whether these are unbalance or misalignment or rotor problem or stator problem. All these will have a certain frequency signature. By looking into that, you can see what the problem is, and you can actually automate the diagnostic part to a certain extent. So now let's go to the next slide here, where initially we looked at if you have a dirty power coming into your motor, then that will actually be seen naturally on the currents and at the output of the system. But in this case, this is not mechanical issue, but it's electrical. So you would have high current voltage imbalance, total harmonic distortion could be high. The VFD output can generate a lot of non-sinusoidal waveform. Your crest factor would be high. And all these will affect the performance of your motor. And they will also have cause mechanical anomalies. For instance, any increase in the voltage imbalance will actually start to heat the stator, and you will start seeing insulation degradations over time. Same thing from VFDs. You would have a high level of distortions coming from VFD, essentially, which will create a shaft current and damage your bearings through fluting. So all this will be identified by this approach as electrical in nature. So first order of business would be to look into the incoming power and try to correct this, whether you would use active filters or you would change your VFD or properly tune it. So then this will give you all the information for you to take action so that you can actually separate electrical issues from mechanical ones and know what is the root cause here and essentially rectify the situation. So this, additionally, this approach will also give you an input-output relation. So based on the anomalies seen here, you will be able to detect process-related changes such as pump cavitation or plugged filters on a fan, or pump blockage, so that your pump will not actually withdraw as much current. So all will be detected as process anomalies, so you can see it. Now, one question comes to mind here is that how does electrical signals can see mechanical issues? So when you look into here, I actually touched about this briefly, but a visual representation might help better. So if you look at here, let's say you have a misalignment. So what's going to happen, that misalignment actually through the shaft will distort the rotor, and that will create dynamic or static eccentricity, and your uniform electromagnetic field between rotor and stator will be distorted at the exact same frequency you would see from vibration analysis. So this is how your motor current will actually carry all the signals. So now here is the clustering algorithm for digital twin within that 10-day period. So you're essentially creating a lot of different clusters for different operational profiles to come out with the digital twin. So what does this approach offer? It's actually offering a lot more comprehensive fault coverage, so where you can not only use for your electrical issues and detect incoming power qualities, but also again mechanical issues as well as process. And it also provides automated fault diagnosis based on that digital twin approach, so you know where your starting point is and what's going on now. So those trend changes will be powerful tools for you to see what's going on. And additionally, of course, the system will do energy efficiency analysis, power quality monitoring. You will see all your electrical values. You will see symmetrical components, crest factors, the raw waveform. And also the system will make efficiency calculations based on the mechanical issues present on the system, based on the load profile of the asset, and what would happen if you upgrade your motor efficiency from a lower one to a higher rate. And also it will do pump performance monitoring by estimating the flow and pressure from the power values alone. Now you can see how powerful this voltage and current data alone is and what can be done with it. So the pump performance monitoring is the latest basically iteration that we have come up with. And from the power consumption, the system can accurately estimate flow and pressure. then it will give you your pump curve, then you can see what's going on with your pump with regards to its performance. Couple of cases here, very limited time left here, but you can see the system automatically triggered, the trend increased for loose windings, and here is one of the faces looking hotter because it got corroded. So once that problem is fixed, the trend values went back down to normal levels. Another case here quickly, if you look at it. So the test generated only again with electrical signals, voltage and current. You can see these bar graphs over there showing a lot of mechanical issues. And this is the asset picture. These are the spectrum analysis to help identify. And here you can see the loose belt and all the other mechanical issues on this system. This test actually was performed by Leonardo here on a VFD-driven chiller. And he was able to detect the fluting on the system by using this tool, by looking into the waveform electrical values, as well as the auto analysis of the system, which tells you that you have issues on your system. Another quick case, a stator winding. You can see the damage on the stator, and the problem was identified by electrical trending moving upwards. And of course, you can do additional spectrum analysis at 2x line frequency, which suggests there is a stator problem, and that was confirmed. Another quick one here, the spectrum shows turn-to-turn issues on your spectrum analysis, and offline testing with search tests. You can see actually the polarization index and insulation resistance was this motor passed, but it failed on the search test, which was actually a confirmation of the finding from the electrical signature analysis done online. So there's a difference between offline and online, but if you guys are interested, we can send that to you later on. So I'm not going to spend so much time on the pump performance monitoring, but here in this case, basically, the system was able to identify a potential saving of $30,000 on a 110 kilowatt pump because it was being run so inefficiently and the pump was oversized. And last but not least, here is now we're using generative AI to take the electrical signature analysis to a next level where all the findings, both electrical, mechanical, power quality, is being interpreted by the generative AI, and this works as an agent so that you can get a clear report with action points and immediate recommendations by the system. And that's pretty much it. So if you have questions, I can try to answer them.
Thank you very much to our speaker. Once again, the floor is open if you have any question for the question and answer session. Anyone from the crowd? One question from sir.
Hi, good afternoon.
Good afternoon.
You mentioned 10 days learning period.
Yes.
Is it that not short, a time period for 10
Yeah,
days?
very good question. If I had actually a long time, I would have explained this in a bit more depth. A lot of AI companies that you hear are using data for 6 months to a year time, but our approach can basically essentially is trying to cover how a standard operational profile motor looks like. So depending on the application, this time duration could be maybe 30 days, maybe 5 days, but 10 days is something that we have come up from our works, and that's pretty much covering everything. Now, if a condition is not learned during that time, let's say you have an operation that's different in winter than summer, when that operation changes, what's going to happen, the system will actually notify you that I have not learned this condition, there might be an issue on your process. Now you can go and update it, that new condition will be learned by the system. Sure.
Thank you very much, sir. So one more question from the crowd. So sir, if you have question po, you may visit their booth sa exhibit. So if no question, then we will proceed with our awarding of our certificate of appreciation. And let me read the citation for our certificate of appreciation. This is presented to Alps Mountaineering Services Incorporated in grateful acknowledgement and sincere appreciation of its valuable contribution as sponsor during the technical trends in electrical engineering, present and future innovations in conjunction with the 50th Annual National Convention and 3E Expo 2025 with the theme IIEE Celebrating 50 Years of Integrity, Innovation, Empowerment, and Excellence. Palakpakan po natin.
Hello. Yeah, again, thank you for taking time on listening to our presentation. We have a booth at F19. We also provide on-site product demonstration, actual to your assets. It's free of charge. So that's the best freebies that we can give to our visitors. Thank you.
We will now proceed with our next speaker. Our next speaker is James Tan. He is a technical manager with Panduit Industrial Electrical Infrastructure Business Unit based in Singapore. Over 25 years with the company, started a sales role for Singapore territory and later into ASEAN countries. Industry experiences cover OEM, electronics manufacturing, oil and gas, rails, infrastructure, construction, and data center space. Current role as technical manager with the IEI business unit for ASEAN, Korea, India, supporting both technical and business aspects. To discuss cable clits and IEC 61914 standard, once again, let us welcome James Tan.
Hi, good afternoon. Okay, I'm James. I'm with Panduit Electrical Business Unit. Okay. Okay. Here I'm going to talk about cable clits. Okay. Before I do that, right, I want to share with you. Okay, I want to share with you a little bit of Panduit. Okay. We are a US-based company, manufacturer for network connectivity and electrical cable management products. Okay. We are a billion-dollar company, privately owned, and we have presence in more than 100 countries. Okay. We have two business. Sorry, I'm just trying to get to this. Okay. We have two business units: network infrastructure and electrical infrastructure business unit. The network infrastructure deals with this enterprise data center, basically providing copper solution and fiber solution connectivity for data centers and enterprise. Electrical business unit will deal with cable management, okay? From cable bundling, cable terminating, routing, as well as identifying. So you can see here we have some of the products like cable ties, power lugs, wire ducts, and wiring accessories. But the focus here today, right, is actually more on cable cleats. Okay. Okay, cable cleats. Okay. The topic here at cable cleats, right, but also the IEC standard 61914 standard. Okay, this is not an all-inclusive list of things, but something to share and something that we all can look at. Okay, as you know, cable cleats is important because it protects against instantaneous impact from a short circuit fault, whereas the circuit breakers or protection devices will kick in much later. So you need to have cable cleats to provide that immediate protection. Okay, from IEC's definition, okay, cable cleat is a device designed to secure cables safely along the length of cable runs. It's a mechanical protection device, especially in high short circuit events, to ensure safety and reliability, especially for high risk, mission critical, for harsh environments. Because in the three-phase system, okay, high current short circuit can cause cables to forcefully repel each other, and this excessive cable movement can cause damage and can cause injury. Okay, cable cleats are designed to secure cables from such excessive movements. Okay, the need for cable cleats are often overlooked, okay, and undermined, even though they are important. Okay, so it's crucial that we have this standard, the IEC standard, for safety and reliability. Okay, while IEC requires cable cleat manufacturers to classify material type, it does not exclude or dictate the use of materials and physical attributes. Therefore, you can see over there, we got traditional cable cleats made of different material. Some can be wood, can be steel, can be plastic, on different style. What IEC standard aims to do, right, is to ensure cable cleats can withstand and protect during a short circuit fault. And the standard IEC 6194 is used to govern this requirement. Okay. Cable cleats for electrical installation, IEC standard 61914, specifies the requirement and test criteria to ensure safety and reliability. It specifies requirements for material, its construction, the performance, especially validated with short circuit testing, test reports, validation, and markings and documentations. Okay, I mentioned already, the standard rights harmonize the testing procedures and parameters. It covers temperature rating, flame propagation. It also includes lateral load testing and axial load testing. Impact resistant, and being a cable management product, it also needs, if let's say it are deployed outdoor, it must be able to withstand corrosion or UV resistant. And last one, resistant to electrical and mechanical force. This is the short circuit test. And I can't stress enough. The IEC standard ensures that cable cleats can withstand and protect during a real short circuit fault. Okay, penduit cable cleats, okay, just introduce what we have. We have products, cable cleat products that are made of stainless steel. We have products in aluminum, and also cable cleats that is of polymer material. And all of them complies to the IEC 61914 standard. Okay, some difference between cable cleats and mechanical clamps, okay? Cable cleat and mechanical clamp both are for cable management, okay? However, let's say if your IEC certified cable cleat, right, is for mechanical protection from short circuit fault, whilst a cable clamp is more for cable management only, for positioning, for bundling. It does not offer short circuit fault protection. Well, IEC standard cleats, right, are validated through short circuit tests, and whilst the non-compliance or standard cable clamps usually will use loop tensile tests for, to validate its performance. And the standard right compliance criteria involve what I shared earlier on, temperature rating, flame propagation, axial lateral testing, and so on. whereas the normal mechanical clamp do not have these design requirements and do not have these parameters. Okay, short circuit test, the last one, resistant to electrical magnetic force. Focus on the cable restraint from destructive electromagnetic force at peak level. Okay, whereas the normal mechanical clamp do not have this short circuit testing, or rather, I should say, do not have the correct short circuit testing. Okay, in some instance, you can see here, users could mix up this 1 second or 3 second short circuit current duration test. Okay? This is actually quoted from a cable specification that is concerned with the cable degradation due to temperature rise. Okay? It does not concern with the cable retention from electromagnetic force. So do not confuse between short circuit test for a cable clip and a short circuit test for cables. These are two different things altogether. Okay, the IEC standard test parameters, I mentioned again, temperature, rating, resistance, lateral axle load testing, and so on. Just the resistant electrical magnetic force, which is a short circuit test, right? It itself, alone, it covers all these requirements already. I will show into more detail later in the next slides to you. Okay, this is the typical setup for testing cable clips. Okay, this is the three-phase AC setup in trifoil formation. What the IEC standard requires is that for testing purpose, the cable used must be single core, low voltage, class 2 stranded conductor. You cannot use an armored cable. And the cable diameter needs to be in the range of 30 to 40 mm. Okay, this range. You cannot use a too big one. Later I'll share with you why this is so. Okay, a minimum to have 5 clips in nominal centers, like what you see over there. Okay. Setup usually will be in trifoil formation or in flat formation, and subject to a 3-phase short circuit current for duration of 0.1 second. And whether it's going to be a 1 short circuit hit event or 2 short circuit event, it also needs to be classified. Okay. So this is a typical short circuit summary of a cable clip. Okay, this is, so you can see here the details, like is test for 1 short circuit event or 2 short circuit event, what's the cable diameter used, and what's the short circuit current that's being injected there. All this need to be specified into the this summary. Okay, like what I said, 1 short circuit event and 2 short circuit event are 2 different things. Okay. This is a short circuit testing summary, a video. Sorry. Sorry, the thing got hanging here a bit. Sorry for the technical difficulty over there. Okay. Next slide, don't mind. Okay, this is the video of the short circuit test. Okay, this is a 1 short circuit event. Let's say in the 2 short circuit, if let's say you're going for 2 short circuit event, don't mind. Okay, to qualify for meeting 2 short circuit events, right, you need to pass a voltage withstand test to verify the integrity of the test. Let's say if the short circuit test, after the short circuit test, the cable fails, right? Fails this voltage withstand test, the test is also considered a fail. Okay, about the short circuit test. Okay, IEC committee was set up, okay, for this short circuit, for this cable clit testing. Okay, the first it was set up in 2009. This is the original version. Okay, this is the IEC 619 2009 original version. Then in 2015, IEC reviewed the test parameters and come with the second revision. In this version, right, 2015 version, it made changes to the short circuit testing parameters. And the most latest version is 2021, IEC 6194 2021. Okay, this is mostly the same with 2015 revision, except that it made changes to the actual load testing requirement, and also editorial definitions and some rewordings of the standard. But in terms of short circuit testing, 2015 and 2021, they are the same. There's no difference. So this is the short circuit IEC standard for this short circuit force formula. Force equals to 0.17 multiplied by peak current squared divided by S. S is the center to sensor distance between neighboring conductors. So this formula is applicable for flat, trifoil, and quad. Okay. And and for touching, for touching trifoil formation, right? S is also the same as a cable outside diameter. This point you all need to take note. This is a very important point where short circuit testing is requirement, especially for 2015 revision. Okay, why IEC make the revision in 2015 on the test parameters? Why this is important? Okay, because I mentioned already, before 2009, right, manufacturers can use any diameter of cable. Okay, it doesn't specify the cable type. When in 2015, it specifies that cable to be used need to be 30 to 40 mm in diameter, and it also must be non-armored class 2 stranded conductor. Okay, if you look at the formula, right, you see that using a smaller diameter cable, the force is actually higher. So this is an example. With a fault current of 100 kA and a cable OD of 50 mm versus using a cable of 20 mm, you can see the short circuit force is actually much bigger than the one with the bigger diameter. 28 mm is actually bigger than 50 mm. Okay, prior to 2015, right, let's say a clit manufacturer use a bigger size cable for testing, they can pass their short circuit test easily and declare that their clits are able to be rated to the KA level, even though the actual force is actually much lower. Okay. Users may base on manufacturer's declaration or vendor's declaration without checking the actual short circuit force involved, which could be very dangerous. And the revision in 2015, right, removed this flaw for declaring the short circuit current ratings and the force withstand capabilities. Okay. So complying to the 2015 revision is actually or later is actually very critical. You provide a more accurate representation of the clit's performance, capability, and as a cable type and cable diameters has been standardized and has been declared. So let's say if any manufacturer would declare their cable clit capability, always need to verify it through their actual test report, their test parameters, and also the data authenticity. Okay, I'm not going into detail for this one, but this is something you all need to take note of. The cable clit spacing intervals. Okay, proper clit spacing is actually critical for reliable installations. Okay, you can look at formula, right? Force FT is a short circuit force, is measured in Newton per meter. So to calculate the force that each cable clit needs to restrain, it must be multiplied by the spacing distance, typically matching the cable run. In this part of the world, most of the time, it's either 225 mm or 300 mm. Okay? Match the clit's force withstanding capability to the required spacing for reliable installation. And I cannot stress enough, understanding the force spacing intervals is the key to a reliable solution and a reliable engineering. Okay, pendule cable clits. Okay, like to share with you, actually, in terms of this pendant, right, we are actually a member of the IEC 61914 standard. Okay, this role, right, enable us to, we help in the committee, right, to set parameters, review parameters, and test standards, and also include products that is designed to the latest requirement. So with this, right, we actually have developed this new type of new type of cable kit we call strapping cable clips innovation. And a lot of customers have actually benefited from our new strapping cable clips design. Okay, this is an example of, we've got two types of strap cable clips, locking strap clip and buckle strap clip. And all of them are fully compliant to the IEC 61914 standard, and all of them actually went through the necessary IEC testing. Okay? So what these two product features are, is lightweight, okay? It's not bulky, okay? And it's so easy to, and easier to manage because it requires lesser accessories. Okay? It has a wide range taking capacity. Each part number, right, has a wide range taking, and where situation allows, right, it also provides low profile for tight space and constrained situations, quick installation, and competitive costing. Some of the market applications that we have. So what I'm showing you, where are the cable clips that we have already installed in the market? Both traditional cable clips and strapping cable clips. Okay, this is an example in the oil and gas offshore environment. You can see over there on the right-hand side, top right-hand side, we got this locking strap clips over there. Okay? This is installed near ceiling, low profile, with limited headroom. A traditional cable clip will be difficult to be installed there, but with strap clip, there's no issue. Okay? This is a FPSO, and over here on the left-hand side is a traditional trifoil clip. Okay? Same again, this is a buckle strap cable clip installed in the offshore installation as well. You can see it's for trifoil arrangement. And being low profile is not bulky. It can, within the cable run width, right, it can fit more cable runs within the width of the cable ladder. Okay. Mining process file in Malaysia, and also this is a fit type site fit test for project. You can see over here. Let's say we're using a traditional cable clip. It may have problem to install in the tight space location, where the strap plate can be installed easily. It's not restrained by the ladders, both top and bottom. Okay. We have the offshore oil and gas, petrochemical plant in this Korea. Why they use our product, why they use our buckle strap plates, because of fast installation, low SKU, one size fits most, and so low profile to fit into tight space locations. Okay. Other applications involve petrochemical plants, olefin plants, commercial World Trade Centers, as well as mining coal export terminals. Okay. Our clips are also used in substations or power plants before. So in this example is a utility and substation using our aluminum two-hole clips. Okay. So real infrastructure. Okay. In Hanoi, Vietnam, okay, MRT Line 3, both our clips, traditional clips and strapping clips are used above ground and underground. Melbourne underground stations, and of course in Singapore, our LRT line upgrades, where we have installed for 11 stations as well as for depots. The data center where our cable clips are used both in the gray space and white space location. Okay, multi-core cable applications. Okay. Strap cable clips as well as single clips, one hole or two hole, are popular for multi-core cables. Okay, there's this industry belief that multi-core cables can contain forces during a short circuit. They do not need cable clips. Okay? And currently there are no standards governing these cable clips. short circuit testing for multi-core cables. But nevertheless, right, it's important that they be restrained, because in the high current short circuit event, multi-core cables will also move, okay? Because if you look at the design, right, the design over top, the written design, is similar, the tripod formation is similar to the one for single core cables. So unless a cable manufacturer can declare that their cable clips can perform to anticipated fault rate levels, it's still important to use a fault rated product. Okay, this is an example of the short circuit test on a multi-core cable, unarmored. And if you look at the left-hand side, the armored multi-core cables, right? Even when the short circuit fault happen, the conductors cannot really be contained carefully. Because if you look at armored cable, armored is to prevent external forces cutting all this, whereas the short circuit force is generated from internal. So armoring doesn't really do a lot of difference in this manner. Okay, so in summary, okay, IEC standard ensures cable clips can withstand and protect during a short circuit event, and complying to the latest IEC 61914 revision ensures safety and reliability. And for reliable engineering solutions, always validate proposals they receive with actual test data, check what's the test parameters used, and also need to check the data authenticity. And it's also important to consider short circuit impacts with multi-core cables. It's highly recommended to use a short circuit tested product for multi-core power cables. Okay, so anyway, we are at the booth, okay, at level 2, booth number F73 and F74. You can see our cable clip products and also solutions from our distribution partners over there for more information. So with that, I thank you.
Thank you very much, Mr. Tan. The floor is now open for question and answer portion. So anyone from the crowd? Any question po? If none, you may visit their booth as displayed kanina on screen. Feel free to visit. Ayun po. So now we will proceed with our awarding of certificate. Allow me to read the citation for our Certificate of Appreciation. This is presented to PT Cerna Corporation in grateful acknowledgement and sincere appreciation of its valuable contribution as sponsor during the technical trends in electrical engineering, present and future innovations in conjunction with the 50th Annual National Convention and 3E Expo 2025 with the theme IIEE, celebrating 50 years of integrity, innovation, empowerment, and excellence. Let's give a round of applause to our speaker. We will now proceed with our next sponsored technical presentation. Our next speaker is Mr. Andrew Lee from Crosslink Construction Corporation. With 10 years of experience in diesel uninterruptible power supply system and Rolls-Royce Solutions Asia and 20 years in the power generation sector with Cummins Power Generation, GE, and other OEMs, he brings deep expertise in reliable power solutions. He holds a Bachelor of Business in Economics and Finance and a Diploma in Mechanical Engineering. So once again, let us welcome Mr. Andrew Lee to discuss benefits of MTU, kinetic power, dynamics, UPS.
Very good afternoon, everyone. My name is Andrew. Today, I'd like to share with you on benefits of MTU Kinetic Power Pack. Can I ask one question that you guys in the floor would know static UPS? Just show of hand. Okay, so this is dynamic UPS that I'm talking about. Dynamic UPS, we don't use batteries. Basically, it is an inline system, combinations of UPS and a diesel generator sets. As shown in the picture, it looks like a generator. So, what are the benefits that today I want to present to you on MTU product? By the way, just 1 minute of introductions of who we are. Rolls-Royce Solutions is actually MTU. MTU in the past is an engine manufacturer, but now we are part of Rolls-Royce family. So the Kinetic Power Pack is the product of the name of the dynamic UPS. Next, please. Well, today basically is that the benefits that I want to bring to you guys are maximum reliability of dynamic UPS. You can have a footprint that is small in size, while comparing, in this case, with a diesel gensets together with a static UPS. I will explain further. The next benefits we can look into is a low TCO, total cost of operations, and of course, in the way that you look at the system, we have great flexibility. We have low voltage and medium voltage system. We can customize in the indoor system or in a containerized system. While the next features is also very important nowadays, optimal sustainability. We can go next slide, please. Now, the next one, I will play you a short movie. Before I go into there, and maybe you pause first. The right on the pictures, I just wanted to go through the parts of the machines. From the extreme left on the picture there, well, it looks like a generator that I start off with, where it's a radiator, a diesel engines, followed by an electromagnetic clutch that coupled with the machines on the right side, which is the kinetic energy accumulator, which is commonly we know it as, like to call them, a rotating flywheel. But in this case, it's not really a rotating flywheel. In there are two rotors, inner rotors and outer rotor. Which is a inner rotor is a shaft, and outer rotors is basically a piece of drum that is rotating in the speed of 3000 RPM. Then back on the tail end, on the right side is actually a synchronous machines. ARCA, I like to say is that is an alternator or a generator. Back behind the machine itself, you can see there's a panel, and the panel starting from the left, there's the brain of the control panel, and the control panel itself is a HMI, where it's a touch screen, where we control, we have all the parameters of the machines. Then back in the center itself, inside, of course, you can't see, there are 3 breakers, the incoming breakers, outgoing breakers, and also a bypass breakers. With the last box there, we also couple it with a choke coil, to introduce the whole machine as a single unit here, shown there. So I'm going to start with the movie, and the movie is basically to explain how it works, yeah? So let's pause there. So basically, as you can see, the system is connected, installed, connected to a server. From the left itself, coming from the utility, power grid, let's say, the input voltage shows, and there's all the voltage there that is fluctuating, and you can see that voltage are not a clean voltage, I would say. QD1, as I mentioned, there are 3 breakers, the color in red, which is incoming breaker. In between QD2, there is the choke coil, and up there's a QD3, which is a bypass breaker. And that is connected to the alternator. So in a way that the mains is healthy, and this mode, now we call it a conditioning mode. The alternator is spinning at 1008 RPM, 60 Hertz. Let's play the movie. So at this point of time itself, we are in conditioning mode. The alternator and the storage device, accumulator, that is spinning at the highest, let's say a higher speed of 3000 RPM. What is the machine on the diesel engine is doing is stand still at this point of time. Stand still, I call it a hot standby. The engine is also pre-loop, it's also preheated, it's in a hot standby. Between the diesel engine, before we couple it, we have an electromagnetic clutch, which I introduced early on. That clutch itself is disengaged. There's a small gap, it's disengaged at this moment of time, while the mains is continue to supply voltage, also supplying power to the machine, which in this case, the accumulator or the kinetic module is running at 3000 RPM. Now, between the choke coil, it's also a very high impedance. In this case, electrically it cut off all the disturbance coming from the mains. It gives you on the downstream, which means it gives you a very clean condition power to your server, or rather in the case, any kind of critical power, be it in the manufacturing, also can. Let's proceed. So as I mentioned, the clutch is open, diesel engine is not running. Let's continue to play. Now in this mode itself, conditioning mode has become the utility failure, which continue to run the movie, which later on you see from the picture that, let's say, a lightning strike. Play the movie, please. So the cable was cut off, power is, let's say, cut off permanently. In this case, QD1 will open. We are doing a transfer mode. A guarantee starts. In this case, I'll explain what is a guarantee starts for our machine. The clutch is actually closed and the diesel engine will start. Play the movie, please. So from there itself, the power is continuously, seamlessly, it will supply the power to the server. And a couple of sequences, let's say simultaneously, is giving the signals to run the diesel engine, clutch close. This will continue to run into an independent mode. In this case, now it becomes a diesel generator, which means we call it an independent mode. Or some people like to call it in a diesel mode. So as long as diesel engine has the power, diesel fuel that is in the storage tank, you will be able to run as a diesel genset until, let's say, the utility has repaired the cable, voltage continue to supply from the input, and this is where we can sense the voltage coming from the input side. Let's play the movie. So the utility returns, power outage resolve. In this case is that before that your system will go back to the conditioning mode. The system actually will check the system on the storage device whether it was fully charged, and we can actually synchronize with the incoming mains. We close the breaker and the visual cycle will start all over again. Let's start the movie. Yep, so the incoming itself, there's a voltage. The system will sense, we will transfer back to the utility, synchronize across the QD1 incoming breaker. We will close the incoming breaker and the visual cycles will similar back to the initial phase. Play the movie, please. So the engine will get the signal again. We'll go for 5 minutes cooling run. Clutch open, the engine will stop. So the visual cycle is continue to become a conditioning mode. So for this case is that main supply with any within the tolerance on the downstreams. You can see that the sign of the sine wave itself is actually a very clean conditioning sine wave. Okay, let's move to the next slide then. Next slide. So here, maximum reliability. What makes dynamic UPS more reliability in this case? Well, we are very simple in design. As you can see, everything on the system, we don't need any batteries. Of course, only on the diesel engines, we still be a small battery, I would say. Just to start, just like our car, we need a 12-volt batteries to start the diesel engines. But in this case is that we don't need a big batteries. So for example, you are talking for a unit of 2000 kVA or 1006 kilowatts per unit. Basically, we don't need so much, let's say, batteries in the static to put into the room And in the room itself, you need to have air cons, you maintain the optimal temperature of the batteries. For this case, is replaced by our accumulator, which is the storage device to, let's say, provide the UPS system. And for the reliability, we said that we can guarantee start the diesel engine. How does it work? Well, this is let's say the inventor has think this through very cleverly in the, let's say, 30 years or more ago to solve this problem, which means I give you an analogy in the case whereby in the morning you can't start your car. And what do? Basically, you get down off your car and you ask your partner to take over the driver's seats. You engage the gear and you start pushing, which means you do a bump start of your diesel engine. For us, the machines is that the energy from the storage device, we have excess energy. We close the clutch, immediately itself is just like a bump starts. You can actually kickstart the cylinder of the diesel engines, and quickly itself we can give you starts, which will give you a redundant starts in this case, which means at the end of the day we don't need a diesel or rather electrical means of starting through the batteries, which means we are a mechanical means of starting the diesel engine. And this is where now the redundant start is so, let's say, give you the end user a guaranteed starts, whereby diesel gensets, battery can be sudden death, and you can change the battery in, let's say, a couple of minutes, which means static UPS itself are able to take care of that through the waiting of a couple of minutes, because static UPS can be also sized for, let's say, more than 5 minutes or 20 minutes kind of batteries power, so that you are able still to get the diesel gensets to start in time before your battery is being drained off. But for us is that we already sense the RPM of the diesel engine that it couldn't start, and we can start in 1.5 seconds. So basically itself, the guaranteed start is really a sure starts for our diesel gensets. Next is that another reliability case is that the alternator itself is always been for dynamic UPS are oversized. Let's say for a 2 MVA, we oversize it to a 2.5 MVA. And for this case, the sine wave is actually a true sine wave. It gives you a very high thermal inertia comparing to, let's say, the static UPS. They are actually a lower kind of thermal inertia, which means they can't give you a very, let's say, good thermal inertia in this case. So our dynamic UPS is actually a very robust machine. Last component. Well, as I mentioned itself, comparing to static versions, static UPS itself, you need big rooms. Of course, you also require some other systems like ATS. You also need capacitor bank. These are the things that, let's say, to compare with us as a dynamic UPS, we are in one system already in, let's say, the generators itself, we need another 2 meters more to put in the storage device. We don't need a big space. So this is where a simple system like this, lesser failure, right? Continue to, let's say, look at other importance of the features that, well, UPS would have. Dynamic UPS also, let's say, filter off all the harmonics, cut off all the disturbance coming from the incoming mains. That give you a very nice power quality to the downstream loads. Well, in this case is that if you install our equipment itself, you don't need a capacitor bank, which means if you measure from the input side itself, well, you get a very, let's say, close to unity power factor of 0.99, very close to 1. So that is also a benefit to install a dynamic UPS. Well, like I say, is that the alternator is always oversized. We also have a very low impedance on the alternator. So that will give you a very nice sine wave that we can control in terms of the, let's say, tight tolerance of the voltage. The other feature, very importantly for, in this case, I like to refer it to manufacturing, which is also overload capacity and give you a very high short circuit current contributions to, in case of, let's say, short circuit. So for that manner is that, let's say on the manufacturing perspective, a few productions line. One of the productions line is having a short circuit. We can clear the fault very fast through the alternator that is contributing all the short circuit current to clear the fault. Yeah. Next slide, please. Well, just a simple way of looking at the batteries wise comparing to ours. Batteries, well, this is just most of the time is either a bad batteries or even that battery end discharge. So these are the culprits that cause the batteries of not being reliable. Just want to show some data. Huh? Well, early on is that small footprint. I wanted to explain in a way that small footprint, how does it mean by here? If you look at this installation of a static UPS, as I mentioned many times on what I present earlier, there are many other comparisons of components. So if you look at the top pictures of the layout of a system from coming on a static installation, you need a battery rooms. You need to have aircon system. You need to have a firefighting system. Probably also that sometimes you raise up the floor, right? So all this itself are space and money, and also in terms of operations costs as well. The rest, I would say, there is still a gensets, space. There is also distribution panels. There are ITS. So if you look at the space comparing to us down at the slides there on the small pictures, I would say is that the gray space that we can save for an installation is about 30% differences. So for this is that we don't need let's say, big battery rooms, so that already take away some of the space that is transferred to space back to the user. It can be a data centers. Importantly, a data centers is that space is very, let's say, important for the business of data center owner. You can use this space to sell it back to the IT space, right? So which means it's also a cash cow of generating more revenues in the perspective of the data centers. So yeah, this is why we say we have a very small footprint. So in terms of the dynamic UPS layout plan, we only need the extra length from the diesel gensets. I just now use an example of the 2000 kVA. So in the middle itself, we only need that 2 meters more to keep, let's say, the UPS power of a, let's say, 2000 kVA, 2000 kVA of the power. Next slide, please. Yeah, and again, it's just repeating from the same slides. So, continue, please. So this layout space saving simulate from a data center perspective of a 20 megawatts tier 3 design. From the first view itself is a static UPS design with a diesel gensets layout. Let's continue to see the movie while we put in the system of a dynamic UPS, what will happen then. So we organize all the positions necessary for, let's say, the panels, the layouts, and how much space that has been saved from there. So with that itself, we put in the same number of power needed for dynamic UPS. So that will come back to be less space saving of a 56,000 square foot, 9 millions of saving in construction costs and so forth. So for that is a quick comparison between the two technologies. This is just a, let's say, a summary of single units of comparisons of TCO between, let's say, a 2.2 MVA system using a static UPS versus a dynamic UPS. And the results of that is that the capex itself is shown as it's 8% lower, and the OPEX over the 10 years is 17% savings. So all in all, what we are trying to say is that there are quite a low commercial total cost of operations. And of course, country to country, you can do your own cost calculations, difference, to make see whether that is really a good comparison for yourself. Next slide, please. The next greatest flexibility we have for dynamic UPS is this. I was told that static UPS can't do medium voltage. Whether true or not, I think, people in the industry will know it better. But for us, is that our system would be able to do low voltage, let's say from a single system, versus a medium voltage. For medium voltage, of course, we can given to the power, let's say we can synchronize up to as many as 32 units, depending on the voltage. So our range from there is that, can go up to as big as high as 36 kV. So for the case of the system design, a single unit, of course, is low voltage. For a parallel system, for, let's say, a higher megawatts, then we need to use a medium voltage. The other flexibility we have is that combining let's say, essential loads and a critical loads together into a one system. And how does this system works then? Let's say for your critical power, we call it no break, which means is that your critical power cannot afford to have any breaks from the mains. And some of the essential loads, let's say during the building itself, blackouts itself, you still can allow for some kind of 10 seconds break. So we can actually combine the system together. We call it a single and dual output system, which means at the end of the day, you don't need to put in a standby emergency gensets. I give you an analogy, which that, let's say for IT loads in the data centers, in the event of the utility fail, then you basically the dynamic UPS will, as I shown just now early on, seamlessly it will take over without any break, and let the diesel engine take over to run. And at the same time, you actually, some essential loads that is already outage, which means you can put in that power under essential load by means of an ATS, which means when the diesel already running from our system, the ATS can just change over and take over, let's say, partial of your essential loads. And this is why, in terms of design-wise, we can combine both no break and, let's say, a short break kind of downstream load system. So for the dirt flexibility, I would say is that, yeah, our system is very robust. We don't need to put in, let's say, big battery rooms. We can actually put into an outdoor canopy unit or containerized. So looking at the 2 MVA units, if you look at the diesel gensets, it's always can be designed in the outdoor containerized. So do we can actually containerize. Let's say you have a 10 megawatts kind of system. So each unit is 2 megawatts, and you have 5 times 2 megawatts of power modules that can be designed outdoor. Which means I come from Singapore, so Singapore is a small country, space is very scarce, and this containerized is very, let's say, useful in our country, and we kind of can stack them up in the cases on vertically, stack them up in the structure form, and we slot every unit in, I would call it a pigeonhole. So for that itself, it kind of saves space as well. Of course, a country in the Philippines, space is no issues. Then you can build, let's say, a powerhouse to house all these units within a big powerhouse. Yeah. The next last benefit I would say here is more on the sustainability. How do you see that as a sustainability for direct UPS then? We say that, well, maybe nowadays it's more electrified. Electrified means is that it's going into batteries. But for us, is that we are not going into batteries. And how do we see as a sustainability? Now, in terms of our case is that the lifespan of these units can be more than 20 years, or let's say 25 years. So in these 25 years, we do our major overhaul. In this case, I'm referring to the storage device, which means the machine that is rotating. Then this is more on the bearings case of replacement and overhaul of the machines, which means we varnish them on the coil, on the windings, and this is done after 10 years, which means in these lifespans, you only do twice. And the changing of bearings wise is still, every 10 years you do that. So you don't actually throw away a lot of, let's say, batteries, which is, looking at that, batteries is termed as green, but it's not really that green after all. So there's a lot of disposal to be done comparing to us, So to the impact of environments itself, we are very sustainable. Not only that, probably this slide has not been, let's say, put up. On the diesel engine nowadays itself, we are able to use HVO, a hydro-treated vegetable oil, which is pretty much a very low carbon, up to 90%. So for that matter is that, which is also a kind of green and really sustainable. So the carbon footprint for direct UPS is really low. I would say eliminates all the batteries, avoiding tons of waste material, pollution during the production or disposal of the batteries. So it's very subjective sometimes with these topics to argue. Well, next slide, please. I think this come to the end of my presentations.
Hello. Okay. So thank you so much, sir, for that very comprehensive presentation. So, any question from the crowd? May question po ba? Yeah, sir.
What's the time delay between the engaging of the generator and the after a power failure?
I understand your questions. Thank you for the questions. Well, if you look at the movie itself, just now I was narrating and trying to play it at the same time. It's really, let's say, I answer you this way. Static batteries is, let's say, sized for a certain minutes to start the diesel gensets, correct? That you agree. So usually the genset we take 15 seconds or less. Yeah? So let's say 10 to 15 seconds, depending on the ratings. Now for us is that once the mains fail, we have 6 seconds of energy on our storage device, which is, let's say, in the point of utility fail, it is already supplying to your downstream loads. The diesel engine starts. Yeah. So during this time, we say the diesel engine starts is only 1.5 seconds. When the clutch will close, diesel engine starts. And why we start so fast is because that storage device already spinning so high speeds, right? There's no loads to start the alternator. All right, there's a difference between a standby gensets. And standby gensets, you are starting from a cold start, remember? So for this case, we can start very fast, which means within seconds, 1.5 or so, we already able to couple as an integrated system. And yeah, probably that's my answer to you. So, well, you can't see any much of, there will be, but then it's still within the tolerance, I would say. Yeah, within the tolerance. Thank you very much.
Okay, so mayroon ba? Any questions? Mahaba pa yung oras natin, hanggang 3 o'clock pa po yung for this session, for this topic pala. So, I guess there's no question. Online, how about sa online? Okay, if there's no question, so let's proceed with the awarding of a certificate of appreciation. So I'll give the mic to Ma'am Yasmin for the reading of citation.
Thank you very much, Mr. Andrew Lee. Allow me to read the citation for our Certificate of Appreciation. This is presented to Crosslink Construction Corporation in grateful acknowledgement and sincere appreciation of its valuable contribution as sponsor during the technical trends in electrical engineering, present and future innovations in conjunction with the 50th Annual National Convention and 3E Expo 2025 with the theme IIEE, celebrating 50 years of integrity, innovation, empowerment, and excellence. Once again, let us give a big round of applause to our presenter. For our next sponsored technical presentation, our speaker is Harvey Chester M. Manansala from HomeCore Marketing and Construction Services Corporation. Okay, so our speaker for this afternoon from HomeCore Marketing and Construction Services is Mr. Peter Hempens. He is an electromechanical civil engineer with more than 70 years of experience in medium voltage switchgear design and testing. He is the head of research and development at SGC Switchgear Company in Belgium, where he led the development of advanced MV switchgear technologies with a strong focus on safety. Now, to discuss real-time intelligence, smart MV switchgear for safer, smarter grids, once again, let us welcome Mr. Peter.
It's not working. This is the hormonal effect of an internal arc, ladies and gentlemen. This can be avoided. You can avoid it by installing an arc killer. No life-threatening effects for your operator, no damage to a switchgear, and no long-lasting interruptions. All it takes is an arc killer. It's a powerful product which is able to kill an arc in less than a blink of an eye, and less than 50 milliseconds. So we are discussing the internal arc faults, what it just is, when it arises, also what the result is and how we can prevent it. The arc is a patent solution. We will explain the working principle and we will explain why it's so good and the type tests that have been performed. It's important to highlight that an internal arc is not the same as a short circuit. A short circuit current follows a direct path, where an internal arc is a path which is unintended, which is due to the ionization of gas, of your air. An internal arc fault is one of the most dangerous and disruptive events that you can occur in your substation. During the internal arc, you will have a plasma, and the temperature will rise up until 20,000 degrees. So you will have metal vapor, copper vapor, and also this quick rise in temperature will have a pressure rise as a result. So a big pressure blast that will appear in your switchgear and also in the substation. As a result of those high temperatures and the copper and the metal damp and also of the burning of your insulation material, you will have a flux of toxic gas. The 80% of the faults occur when an operator is live. Further on we will discuss how this has come, but it's important to highlight that the risk for the operator is very large when a fault occurs. You have two type of reasons why an internal arc fault occurs. One is made to the degradation of your switchgear, so aging. You will have deterioration of your insulation material. One is due to the design of the switchgear, otherwise due to the selection of the insulation material and to a lack of maintenance. Those, you can see the results tracking on the epoxy pole or on your cable termination. Those are faults that can be detected due to monitoring or due to maintenance. On the other hand, you could also have contamination in your switchgear due to a high humidity and also due to your environment, to the dust and metal particles that can lay a film, a conductive film on your insulation material and result in breakdown. On the other hand, you have a type of failures which are hard to predict. Mechanical failures, because they only arise during operations. So for instance, your mechanism that breaks down or your VI, which is in service, has a loss of vacuum, you will internal arc during operation, during opening. You can also have animal intrusion that create an arc just due to the reduction of the insulation properties. Those are failures which you cannot predict. On the other hand, almost 70% of the failures are due to the human error. It's mostly related to maintenance work or the installation work, that tools are forgotten in a cubicle, or they had to place a short circuit wire for bounce testing and timing, and things like that got forgotten. They closed the cubicle again, they placed it in service, and that's also why mainly the main 80% of the faults happen when an operator is present. The results of an internal arc fault are very severe, also for your substation, but definitely for your operator. It's very important to highlight that a type-tested cubicle on its own doesn't give a safe situation. So for instance, on the left-hand side, those cubicles are type-tested. You can also see after the arc, they look very well, but due to the high pressure rise, you need a synergy between the switchgear, the substation, and your outlet section. And there it's clearly the case that the substation was not able to cope with the high pressure rise. The same on top. And you can also have the hot gases that create an extensive fire and with severe results for the substation and the operator. This all can be prevented by installing an arc killer. An arc killer is an independent device which is able to, due to the detection of a pressure rise, to feed the fault current towards Earth. So on the left-hand side, you have the design for a GIS solution. There you see a membrane in the center, because in a GIS you have a closed volume. You're able to detect your pressure rise. The membrane will move downwards and will trigger the mechanical stored energy. On the right-hand side, the design for the AES, the same principle, also stored, but the trigger is made by the pressure relief flaps because you don't have a closed volume. So a bit more in detail. The detection is on the rear side, the pressure relief flaps. When those open, like in the picture on the right-hand side, you have a displacement. The cable which is attached will have a displacement and will liberate the stored energy in the mechanism. Then on the picture on the left-hand side, you can see it's an independent switch. Your main earth switch is on the right-hand side. Because it's independent, it's simple, reliable, and also fast. That's also the reason why it makes, here you can see, oh, could you go back? Can you go back one? And push for the film. Okay. There was a video how to show how it works. But continue with the PowerPoint and we'll just explain it. The videos are for later on. Yeah. So if you could go one slide back. So you have your cubicle. You can already see the detection as both in the cable compartment, the second flap, which is tilted inwards. So if you have an arc in the cable compartment, you will have detection and you will liberate the energy. Same independently you will have in the busbar compartment, the yellow flap on top. If you have an arc in the busbar compartment, this will the flap will go to the rear and will also trigger the mechanism. So it's independently of which compartment the fault is. It will always close the independent earth switch and by this feed the fault to ground. And now to tell the installation of the arc killer really makes an enormous difference because just it's so fast. It's like we say less than 50 milliseconds for the total arc extension. So at first you have your fault. You will always have ionization of the air and you need a little pressure buildup. But already at 80 milliseconds you have a trigger of the device. Then starts a mechanical trigger of the arc killer. And in a total of 48 milliseconds, the total arc is extinguished. This is so important, this timing, because it's depending on your fault current, of course, but from 100 milliseconds onwards, you will have surface damage and a bit further burn through. So even with 20 kiloamps, we are far below 48 milliseconds, and by that we can prevent any damage into the substation. So once again for timing, we are at the first zone, the green zone, and we are able to avoid all this phenomena that arises during a normal internal arc fault. So that's a demo test that we did to simulate an operator in front of a cubicle. You can see already at 100 milliseconds what an intensive heat that arises over there. And because the timing of the arc is so fast, you're able to avoid all of this. Because you can see on the right-hand side the influence for your operator, which is already wearing a protective mask and also Nomex coatings, which should protect him from burning, but it's apparently insufficient. And those are the videos you will play separately. So this is the difference between, so first of the DR6, please. So that's in Ringman units, a standard without any arc killer. You can see a fault current of 20 kA, and it's to see the pressure wave if you compare it to one with an arc killer. So on the right-hand side, you see the timing from 0, that's the one with an arc killer. Could you first do the other one, please? Otherwise, I will just explain first the one with an arc killer. You can see that the current also flows for 1 second. You can only see the cable switching, but you have no external gases that come out. Even the burn disk remains in the gas vessel. So there is absolutely 100% safety for the operator, even in case of an arc fault of 20 k's. And if you can now play the other movie, then we can see the difference between both of them. It should be the other video, because this is the same as previously. So you will see now the same switchgear, but without any arc killers, the same fault current as before, and you can see the huge explosion, the pressure wave, also the toxic gas that is being released. So this is in a test setup, but if you have this in a small substation, you will can imagine what you must have as an operator standing in front of this. So if we can move back to the presentation for the final words. So we can clearly see from the videos that you have a huge difference with this product. So it's not a tool that's if you want really operator safety for your staff and also for your substation, for your utilization. It's really an asset that you should install. So we compare at the same time frame. With an arc killer, you have totally not, and without an arc killer, you have a huge pressure wave that arises. So, are there any questions?
Tapos na ba ang speaker niya? Okay, that ends the presentation of our speaker, Mr. Peter. Any question po from the crowd? Ayan. Any question po? Yes, sir. What's your name, sir?
My name is Z. I'm from Holcim, Philippines. So, good afternoon, sir. I would like to ask about the how is that triggering of the tripping? So connected to main breaker?
Yeah, the triggering is
or
based,
independent device.
Yeah, it's an independent device, and the triggering is based on the pressure rise. So that's in the first 80 milliseconds you have pressure rise in your cubicle, both in GAS or IA solution, and this will trigger the stored energy into the mechanism of the arc killer.
For example, we have a switch gear.
Yeah.
So type tested. So we will just how you will install it. So
it's a feature that's added into the cubicles of SGC. It's not something that you can add it as well, but it has to be by design, not for installations which are already in the field.
Okay, so that's a new design because okay, thank you.
Thank you very much. Any question pa po? Question sa likod? May nagtaas kanina si sir. Question po. Okay, wala na pong question. Ayun, visit na lang po tayo sa booth for any other inquiries. And for now, we will once again proceed with another awarding of our Certificate of Appreciation. Ayun, we have one question online, sir. I'm gonna read it for you. This one is from Noel Bunag. What is the ROI and cost benefits of converting from static UPS to this dynamic UPS?
Could you repeat it, please? So the ROI?
Return of investment, ROI.
Yeah.
Okay.
I think it was for the previous presentation.
Yeah, it's from the previous. Apologies for that. Any other question po? Okay, if no question, then we will proceed with the awarding of Certificate of Appreciation. Allow me to read the citation. This Certificate of Appreciation is presented to Homecore Marketing and Construction Services Corporation in grateful acknowledgement and sincere appreciation of its valuable contribution as sponsor during the technical trends in electrical engineering, present and future innovations, in conjunction with the 50th Annual National Convention and 3E Expo 2025 with the theme IIEE, celebrating 50 years of integrity, innovation, empowerment, and excellence. Once again, thank you very much, and let's give them a big round of applause. And our next speaker is for the last technical presentation for today. Our speaker is Engineer Michael M. Evangelista. He is the East Asia Technical Support Group Manager of MEGR. Started with MEGR in 2016 as Applications Engineer. He has broad experience in different electrical applications and is appointed as the product champion for transformer testing. He is a registered electrical engineer, an active member of IIEE, and a member of IEEE. He is a co-author of technical papers entitled Optimizing of Power Transformer Installation Dry-Out Process Using Dielectric Frequency, published by IEEE in November 2022. Let us welcome our speaker to discuss transformer insulation testing, time and frequency domains methods. Once again, Engineer Michael M. Evangelista.
Thank you, ma'am, for the introduction. And good afternoon, everyone. Yun. Pilipino naman lahat no? Bala ko sa Tagalog na lang. Well, anyway, as introduced, I'm Michael Evangelista, and I'm the East Asia Technical Support Group Manager of MEGR. So today, I will be presenting the transformer insulation, sir. So, hindi ko na siguro napakilala naman na. So, what motivates me to present here, actually, this was our paper presented to IEEE last year in ICPAD-M. So what motivates me
Siyempre, mga kababayan, sa ibang bansa nga nakakapag-present tayo, so dito pa kaya, gusto kong ma-share yung aking knowledge about yung mga insulation testing, especially doon sa transformer. Siyempre, may mga tanong tayo, we have questions in our mind, ano ba, safe ba yung transformer ko ngayon? Na-test naman yun? O kadideliver lang? Ano kayang nangyayari ngayon? Diba? So we have a lot of questions in mind and sometimes we cannot sleep dahil nga worried na worried tayo, baka may mangyari sa transformer natin. So yun yung nagbigay sa amin ng motivation. So una, what is happening inside the transformer? So kapag mababa yung temperature and supposedly meron na tayong moisture doon sa loob ng transformer, the tendency of that moisture, papasok yan doon sa papel o sa cellulose natin. So kapag mababa yung temperature. Pero habang tumataas yung temperature, mapapansin natin, yung moisture na yon, lalabas yun sa papel in a form of bubbles. So ano ang unang mangyayari doon? Ang unang mangyayari doon, napipilas-pilas yung mga papel. The cellulose will be easily deteriorated dahil marami kang moisture sa loob. And at the same time, dahil nga bubbles yun, meron tayong air gap sa loob, maaaring kung meron ka ng mga gases or unwanted gases doon sa loob ng transformer, magkukos pa yun ng mga partial discharge. Not to mention, meron pang mga dahilan yan, kagaya ng kung meron ng mga sugat yung winding mo, di ba? Kagaya niyan. So syempre, yung ating transformer, especially sa electrical industry, hindi natin nakikita yung electricity, pero mararamdaman natin siguro pag hinawakan natin. No? So, ayaw naman natin mangyari yung ganito, no? Yung catastrophic effect. So, pag-usapan natin yung heart ng substation, which is yung transformer. Maraming test ang ginagawa sa transformer. Di ba? Pag-usapan natin, sir, yung basic muna, bago tayo pumunta doon sa insulation. So, normally, if you have transformers, you are doing, or you need to do the following tests. We have the power factor tangent delta, or yun yung ating IPF. Meron tayong turns ratio testing, winding resistance, excitation current, the electric frequency response, yan yung part nung present ko mamaya. Oil dielectric strength, syempre yung langis. Oil tangent delta, meron din siyang pang tangent delta ng langis. Syempre yung top changer, kung meron tayong OLTC, on-load top changer. Meron ding sweep frequency response. Meron ding magnetic balance, frequency response of stray losses, at kung ano-ano pang test, kagaya ng short circuit impedance. Ngayon, doon sa atin sa electrical engineering, sir, parang din tayong doktor, di ba? Hindi po pwedeng stethoscope lang, ito may COVID-2, ito may AIDS-2. Dapat ginagawa din natin yung mga iba't ibang test para ma-diagnose talaga natin kung ano yung sakit ng transformer natin. Kaya meron tayong mga ganitong testing na ginagawa. Alam ko yung iba, okay na yan, TTR, okay na yan. Iba't ibang parte ng transformer, sir, iba't ibang test ang dapat mong gawin. Kumbaga sa doktor, meron tayong x-ray, meron tayong ultrasounds, di ba? Marami tayong test na ginagawa. Depende yon sa parte ng transformer. So meron tayong dalawang standard dahil maganda dito sa Pilipinas, parehong standard ina-apply natin. Meron tayong SIGRI Technical Brochure 962 ngayon. Ang isang standard or yung IEC standard, bago magiging IEC standard yon, dumadaan muna yon sa pagiging technical brochure. So itong technical brochure, ito yung ating field test. Iba din kasi sir yung test na nasa laboratory ka, iba din yung test na nasa manufacturing ka, at iba din yung test na nasa field ka. No? So merong SIGRE para dun sa IEC at meron din siyempre yung IEEE. Okay? So depende na lang sa atin. Bago yun, no, review natin ng konti yung akin. Let's review a little bit yung principle ng transformer. Sa transformer, sa Faraday's law, pag nag-induce ako ng voltage dun sa primary, may tatakbong kuryente, yung excitation current natin. And then dahil meron akong excitation current, makakapag-produce ako ng magnetic field. Okay? Nung nakapag-produce ako ng magnetic field, magpuproduce din ako ng magnetic flux para punta doon sa secondary. Sasaluhin ngayon yun ng Lenz law. Sabi ni Lenz law, Faraday, pag nakat ko yung flux mo, magkakaroon din ako ng current dito sa kabila ko. Lenz law. Pero kung napansin nyo, sir, isang flux lang yung nakat dito sa drawing ko, no? Di pala, LED pala to. So isang flux lang. Yung natirang flux doon, wasted na kasi hindi nakat eh. Di ba? So yun yung purpose na meron tayong transformer core. Kaya tayo may core para mabigyang daan yung magnetic flux na may transfer ng buo doon sa secondary side. So sa madaling salita, sir, bibigyan ko kayo ng isang halimbawa. Pag ako, nawala siya? Sorry. Pag ako pala ay nag-turns ratio testing, halimbawa lang, nag-turns ratio testing, ano ang tinitingnan kong parte ng transformer doon? Yung iba kasi talagang, hindi, TTR, okay na yan. In-energize mo yan. Pag. Hindi natin alam, meron tayong mga na-miss na component ng transformer. Pag ako nag-TTR, di ba mag-inject ako ng voltage? Kung halimbawa step-down method yung gagawin mo, mag-inject ako sa primary, susukatin ko yung secondary kung sakto. Ano ba ang dinaanan nun? Dumaan siya ng winding, dumaan siya ng core. Ibig sabihin, pag bumagsak yung aking TTR, pwedeng may problema ako sa core, pwedeng may problema ako sa aking winding. Okay? So ang problema ngayon, paano sir kung nag-fail yung TTR ko? O di, dun ka nagagawa ng iba pang testing, kagaya ng winding resistance, para ma-eliminate mo. Di ba? Kung sumakto yung winding mo, yung winding resistance mo ay tama, so malamang sa malamang, yung merong problema, yung core mo. Di ba? Pero syempre, TTR lang yan, ang tinitingnan, winding at saka core, meron tayong na-miss, at yun yung aking ipipresent, yung ating insulation na isa sa pinakamahalaga din na parte ng ating transformer. Okay? So, punta na tayo doon. Ito yung mga tester. Kung gusto niyo ng copy ng presentation, so ibibigay ko naman, meron akong QR code doon sa dulo ng presentation na kunin nyo lang para mapadalhan kayo ng copy ng presentation. Pero yung TTR kasi, sir, hindi basta-bastang test lang yun, ano? Maraming factors yun. And siguro doon sa ibang mga webinar ko, o baka makikita nyo, sir, sa YouTube, may mga webinar, series of webinars si Megar, makikita nyo doon, sir. May mga factors na nakaka-apekto sa TTR, hindi tayo basta-basta nagti-TTR lang. No? Marami tayong tinitingnan o kinukonsider na factors. Sa winding resistance, syempre, ang benefits niyan para malaman natin kung may shorted turns, may open winding, may problema ba yung OLTC, yan yung mga basic testing, sir. No? Pero hindi ko na-elaborate. Excitation current, ginagawa din natin yan. Para sa akin, pang-confirma ko yun sa TTR ko. Pag bumagsak yung TTR, titingnan ko ulit yung excitation current. Kung nagkaroon siya ng field value dun sa excitation current, tama yung aking TTR result. Kasi minsan, sir, baka mali lang ang connection ko, baka hindi ako marunong magbasa ng vector group. Di ba? Yun. So sa excitation current, malalaman natin. No? So may mga pattern yan. Short circuit impedance, ginagawa naman yan, sir, para malaman mo if you have deformation dun sa transformer mo. Kasi yung percent impedance na nakikita nyo doon sa transformer, yan yung impedance niya nung lumabas siya sa factory. Okay? Siyempre, considering na may langis na yon, no? Ibig sabihin, dapat, ganun pa rin yung impedance niya. Otherwise, nagkaroon ako ng deformation kung nag-fail yung result natin sa short circuit impedance. Okay? So, yun, yung iba, ito na yung insulation power factor. No? Pero yung insulation power factor na tinutukoy dito sa slide na to is yung AC or yung frequency domain. So, punta na tayo, sir, dun sa main topic natin na insulation testing ng transformer. Okay? Sa insulation ng transformer, we have two methods. The DC or the time domain method and the AC or frequency domain method. So, let's start with the DC or yung time domain. Bakit nga ba siya tinawag na time domain? Because we have to wait. Meron tayong iniintay na time bago tayo kumuha ng value. Sino ba dito yung naka-experience na mag-IR? Bakit 60 seconds yun? Bakit hindi pwedeng 3 seconds lang, pang, kuha ng value? Bakit hindi? Bakit 60 seconds? Kasi ganito yung nangyayari, sir. No? Siyempre, yung ating, bago tayo dumako doon, yung DC, siyempre doon din yun sa Ohm's Law nakabase. Di ba? Kailangan ma-measure mo yung resistance, V over I. Kailangan ko yung pinakamataas na voltahe para makuha ko yung pinakamataas na resistance. Kasi directly proportional siya eh. Di ba? Kapag contact resistance naman, gusto ko makakuha ng pinakamababang resistance, kaya ang tinataas ko naman ay current. Kasi inversely proportional siya. Di ba? Kung babalikan natin yung college natin. May mga standards for IR. Ito yung generic, ito yung NETA Standards 2019. Nakalagay na dyan. Yung normal rating ko, kung ganito, ito dapat yung minimum test voltage ko. Yan yung test voltage ko dapat. At ito naman, yung recommended minimum insulation resistance value, nandyan sa pinakadulo. Pero syempre, ang rule of thumb dyan, sir, twice lang nung rating nung test object mo. Huwag naman sobra-sobra. Halimbawa, for 80 volts lang, tinirahan mo ng 5 kV, alam nyo nang mangyayari, in-stress mo ng gusto yon. So, normally yung ating rule of thumb ay twice lang nun. Okay? So, nandyan naman yan sa table o nasa guide nung NETA 2019. Paano naman yung interpretation ng result? Alam ko, karamihan sa inyo sasabihin, 1 kV is equals to 1 mega ohm plus 1, sir. Matagal na yun, talagang well-known yun. Okay pa naman yun, applicable pa naman yun. Pero para sa amin, the best way to analyze yung result ng insulation resistance mo is through trending. So halimbawa, meron akong 10 kV na transformer. 10 kV, for example lang. So ilan dapat? Dapat 11 mega ohm no? So kung ang naging resulta ko, 100 mega ohm, pasado kasi 1 kV is equals to 1 mega ohm plus 1. Tuwang-tuwa ka na, naka 100 mega ohm ka ngayong taon. Paano pala kung last year, 10 giga ohm yun? And in a short period of time, nagkaroon ng malaking pagbabago doon sa insulation status mo. So mahalaga or importante na meron tayong previous test result. Okay? Para ma-analyze natin kung ano yung naging takbo ng ating insulation. So ngayon, ito na yung sagot. Bakit 60 seconds ang ginagawa natin pag nag-IR tayo? First, titingnan natin sa yung insulation, electrical insulation, meron tayong conductor, and the electric in between. Diba? And normally, we model yung ating insulation as capacitor. No? And doon sa dielectric natin, meron yung mga tinatawag na dipoles. Yun yung combination ng positive and negative. And meron din yan siyang mga negative charge o mga electrons. Kung AC yung gagawin natin, kung AC method yung gagawin natin, ano ang nangyayari dyan sa mga charges na yan na nandyan sa loob ng insulation? Malaya silang sumasayaw. Ganyan, sir. Kasi AC, oscillating. Ganyan kapag AC. Pag DC naman, ano mangyayari? Siyempre, yung negative charge, ma-attract yun dun sa positive o sa opposite charge, nag-move yung charge na yun. At ang sabi ni Mrs. Santos, yung ating teacher noon, na kapag nag-move ang charge, current yan. Pero yan na ba yung hinahanap natin na current? Pag nag-test tayo ng insulation, hindi pa. Kasi that current is what we call the capacitive charging current. Hindi pa yun. Ang hahanapin natin, yung leakage current, yung magli-leak doon sa conductor. At the same time, ang nangyayari, umiikot itong mga dipoles na ito. Nag-a-align towards the opposite charge. Nag-move na naman yung charge. Tawag natin doon, absorption current or polarization current. Yung dalawang yun, sir, happens in the first few seconds na nag-inject ka ng DC. Kaya hindi ka pwedeng mag-measure o i-take note agad yung result mo ng DC kasi antayin mo silang matapos. Kasi hindi yan yung leakage current na hinahanap mo. That is the absorption current and the capacitive charging current. Okay? So ganun yun, sir. So after 60 seconds, approximately, doon na tayo mag-measure ng resistance kasi ang makikita natin doon is purely leakage current. Yun yung hinahanap nating current. Okay? So, ganun yun, sir. So, dito pa lang tayo sa basics ng insulation. So, ito yung nangyayari, capacitive charging current, polarization current or absorption, and yung conduction current. Minsan, kung halimbawa madumi yung bushing or yung transformer nyo, nagkakaroon kayo ng surface leakage. So instead na isang resistor lang ang tinitingnan mo, nagkakaroon kayo ng nakaparallel na resistor kasi madumi, basa, o kaya may alikabok na basa. So nagkaroon kayo ng nakaparallel na resistance, yun yung tinatawag nating surface leakage. Yung gamit ng guard sa kahit anong brand ng insulation resistance, kahit hindi naman Mega, may guard yun. At yun ang mag-i-eliminate nung surface leakage na yun or yung contamination na yun. Kasi kailangan mawala yun, sir. Temporary yung dumi na yun eh. Paano kung nalinis mo yung bushing, wala na yun. So dapat pag nag-record ako ng insulation resistance is purely yung resistance na tinitingnan ko. Huwag mong isama yung resistance na caused by surface leakage. Mamaya, sir, meron akong diagram dito na makikita nyo. Okay? So, yun. Ito yung kanyang summary or yung graph na makikita nyo doon sa standards. So, ito, sir, yung surface leakage na sinasabi ko kanina. So, halimbawa, ang gusto ko lang ma-measure na resistance ay from bushing o yung terminal na yon to tank. Dahil may dumaan na current doon, nagkaroon ako ng parallel na resistance. Ang gagawin nung guard, parang i-absorb niya yung current na yun. Sa layman's term pa, hihigupin niya yung current na yun para mawala doon sa total computation ng resistance. Madadivert yung current na yun papunta doon sa guard. Kaya mahalaga, sir, yung guard. And again, sinasabi ko, yung interpretation ng result mo is true trending. Dapat, kung ano yung ginawa niyang connection last year, at i-compare mo ngayon, dapat pareho kayo ng connection. Baka mamaya, ikaw gumamit ka ng guard, but mas maganda yung result mo kaysa doon sa dati. Nag-improve ba yung insulation mo pagka ganun? Parang magtataka ka pa, tumanda na yung insulator ko, pero mas maganda na ngayon. Dati, mababa lang. Diba? So, ganun ang malilito ka ngayon. Diba? And normally, sir, doon sa mga insulation resistance tester natin, I do recommend na dapat tingnan natin, sir, yung trend ng current. Tama bang pababayan? Sa umpisa, mataas yung current dahil meron ngang absorption current, meron kang capacitive charging current. And habang tumatagal, pagdating ng 60 seconds, flat na at mababa na yung current. Tataas na yung resistance mo. Kasi wala na nga yung dalawang current na sumasabay sa simula. Diba? So dapat, ang graph naman ng resistor mo o resistance mo, dapat pataas naman. Diba? Kasi kung ang nangyari, ganito ang naging graph mo, flat pa rin. Ano bang magkukos ng high current, sir? Ano bang magkukos na hindi magbabago yung current? Di syempre, kung may contaminant ako doon sa insulation ko, kung may tubig yun, mataas pa rin yung current ko kasi yung conductivity ko nga, mataas eh. Di ba? May moisture ako eh. So, ganyan ang mangyayari at yan ang hindi dapat mangyari pag nag-test tayo ng DC insulation, lalo na sa transformer natin. Okay? So, ayan yan, sir. Meron namang pagkakataon, sir, na bakit nag-fail, halimbawa sa cable, bakit kaya nag-fail yung aking IR dito sa cable? Meron kasing pagkakataon, sir. Siyempre, yung aking insulation resistance tester, meron lang akong maximum current na kayang i-output. Ngayon, kung ang iyong test object ay highly capacitive, hindi inaabot yung charging current, baka mamaya kulang yung output mo. Kulang yung halimbawa 3 milliamp mo, kulang para ma-charge mo yung test object. Highly capacitive yung aking kable. Halimbawa, mga 1 kilometrong kable na yan. Tapos IR lang ginamit mo. Mag-fail tayo doon dahil highly capacitive yun eh. Hindi kayang i-charge nung output nung IR. Kaya doon na-invento yung mga BLF, yung mga cable tester, dahil sa limitation ng IR, sir. No? Baka kasi may sir, yung IR nyo, sira. Hindi makapag-test ng kable. Ano ba yung principle, sir? Diba? Capacitive charging current yon. So kung hindi ko kayang i-charge, hindi ko matitest yan. Ganun lang naman yun, sir. At ganyan ang mangyayari kasi charge, discharge hanggang sa hindi mo nga ma-charge. at wala kang mababasang reading. Sir, di ba? So yung capacitive current is equals to 2 pi F times voltage area over distance. Kung mataas yung capacitance mo, kasi yung capacitance mo dyan, sir, ay area over distance times permittivity. Di ba? Kung mataas yung capacitance mo, ay limitado lang yung IC max mo limitado lang yung capacitive current mo. Diba? 3 milliamp lang. Pero yung capacitance mo mataas. Hindi niya kakayanin i-charge. No? Nasa formula naman ng capacitance, sir. So sa dielectric field o sa DC electric field, habang tumataas yung voltage, bababa yung current. No? So gano'n naman yan. Linear naman dapat yan kung walang contaminant. No? At kagaya ng sinabi ko, kapag mas mataas yung capacitance o highly capacitive yung test object, mahirapan tayong mag-test. Kasi ang limit normally ng mga IR, hindi lang naman Megar, sir, hanggang 3 milliamp. Pero si Megar, meron na siyang 6 milliamp. No? Hindi pala ako sales ngayon. Teka. So ito, sir, IC is equals to B max 2 pi FC. At mababasa nyo yan, sir, sa mga kumakalat na mga libro ng insulation testing. Okay? So normally, kagaya nung sinabi ko, sir, eto na. Sa transformer focus tayo. Tinitreat natin as capacitor, di ba? Yung insulation, lalo na ng transformer. So, pagka DC, sir, apektado yung result. Results are being affected by the material, electric field, and temperature. So normally, kinokorek natin yung value sa tamang temperature. Bakit? Kasi yung nakita nyong limit kay NETA standards kanina, base yun sa 20 degrees Celsius. Kapag nag-test kayo ng IR, 100 mega-ohm, tama na ba kaagad yun? Kailangan mong i-correct yun, o bago mo i-compare doon sa limit ng standard, kailangan mong i-correct sa 20 degrees Celsius. Kasi yun yung limit na nakalagay sa standards. At 20 degrees Celsius. Kasi ang ating insulation resistance, laging may relasyon kay temperature, di ba? So yun. So kailangan natin i-correct. Kaya apektado yan. No? So normally, kapag nag-IR tayo ng transformer, 60 seconds. At kapag nag-IR tayo ng transformer, dapat, sir, marunong tayo. We should know how to do dielectric modeling. Anong dielectric modeling? Kasi marami pa rin nagtatanong sa amin, sir, saan ko i-connect yung pula? Saan ko i-connect yung itim? Sa totoo lang, sir, bahala ka kung saan mo i-connect. Basta alam mo yung magiging flow ng current. At kung alam mo yung model ng dielectric na tinitest mo. So for example, I have transformer here. Meron akong high voltage side, which is yun yung unang live parts na ko or yung conductor ko, sinort ko yun. Low voltage side, isang conductor din. At syempre yung tank, conductor din yun. So meaning to say, I will try to test yung tatlong resistances na yan. High voltage to low, high voltage to ground, and low voltage to ground. Now, ang problema, paano ko gagawin? Kasi may guard ka pa, sir. So, as an example, ano ba ang nangyayari kapag nag-guarding ka? Nagkaroon ka ng guarding. Nilagay mo yung guarding sa transformer. In this example, if you want to test yung high voltage to ground, yung resistance na to, ang gusto ko lang makita, sir, gaano ba kaganda yung insulation ko from high voltage to ground. Tandaan nyo, sir, na yung positive and negative, meron ako, for example, 5 kV, may 5 kV doon. At doon sa guard, meron din akong 5 kV na voltahe doon. Baka kasi may humawak, sir, ng guard, kakabit ko dito, bang! Doon mo masasabing mararamdaman mo electricity. 5 kV, sir, meron ka ring voltahe doon from positive to guard. Yung current na mapupunta from high voltage to low voltage will be ignored kasi guarded siya. Kagaya nung guard natin dyan, sir, hindi ka papapasukin sa tawad kapag hindi ka allowed. Ganon din ang gagawin ng guard, kaya tinawag na guard yan. Hindi niya i-allow papasukin sa total computation yung hindi dapat. Kasi ang ina-assess mo lang dyan, yung high voltage to ground. Kaya mahalaga, sir, yung guarding. No? Pangalawa, kung walang guard, ganito ang nangyayari, sir. No? E di dalawang resistance ngayon ang nami-measure mo. Okay lang yan kung pumasa. Paano kung bumagsak? Hanapin mo ngayon, sino kaya ang may tama na insulation ko? Yung high voltage to low o yung high voltage to ground? No? Pero pwede. No? Pwede nyong gawin. Yun nga lang, pag bumagsak, confusing. Di ba? Alin sa dalawa, yung may problema. Kaya mahalaga, sir, na meron kang guard. No? Eto naman, kapag ang ginard mo ay ground, siyempre, ang tinitingnan natin na insulation dyan, yung pinakamahalaga, yung high voltage to low. So dahil dyan, ganyan, sir, ang tamang pag-test ng transformer using nung DC insulation resistance. So, lumabas dun sa experiment ng Meger na kapag ginagamit natin yung guard is more accurate at more conclusive yung result natin. No? Pag meron tayong guard. So, mahalaga at importante yung guard. So, yun. Yun yung DC insulation resistance testing natin, sir. Now, punta tayo dito sa medyo komplikado, yung AC or frequency domain. Yung DC, madali, very popular. Pero kasi nakalagay din kasi sa standard, sir, like yung SIGRI na binanggit ko, 962, sinasabi nila, huwag ka nang mag-PI, tatagalugin ko na lang, sir, huwag ka nang mag-PI kung bago or highly polarized yung iyong transformer. Kasi magkakaroon ka ng confusion. Okay? Kakaroon ka ng confusion, sabi. Imaginein mo kung napakaganda ng insulation ng transformer mo. Ang tinitingnan mo ay 10-minute value over 1-minute value. Gaano ba kalaking changes? Ang tinitingnan na lang natin doon, microamp. Microamp. So, konting changes, malaki yung pagbabago ng ratio. Medyo confusing. So, may mga nagre-recommend, hindi ko sinabi, sir, nire-recommend ko, ha? May mga nagre-recommend, kung mga malalaking transformer na talaga, nire-recommend namin yung AC, o nire-recommend nila yung AC method or yung frequency domain method. Bakit? Unang-una, tumatakbo yung transformer mo sa AC. So, maganda na ma-assess mo siya through AC method din. Diba? So dito, meron kaming tinatawag na 3 steps. Pero bago ulit yun, paalala ko lang, yung ating insulation ay modeled as capacitor. So normally, ang tinitingnan natin dyan na current is yung capacitive current or yung IC. Sa AC method or frequency method, kapag yung iyong capacitive current ay talagang naka 90 degrees doon sa voltage, yan yung tinatawag natin na perfect insulation, ideal insulation. Pero saan ba natin nakikita yan? Dito lang, sir, sa slide na yan, o baka sa libro makikita niyan. Kasi sa totoong buhay, walang perfecto na ganyan na angle na perpendicular. Ano? Bihira. Wala talaga. Wala. So laging meron tayong angle na mapuproduce doon sa total current natin. So meron tayong resistive current and may capacitive current. May capacitive current ako kasi nga modeled as capacitor. Yung resistive current kasi nga, syempre yung transformer ko meron din namang mga losses yun. May winding resistance din yun. Di ba? May excitation current yun. Kaya may IR din ako. At saka yung losses syempre na napuproduce doon sa insulation. So yan may angle yan. Di ba? May angle yan yung cosine theta at saka yung tangent delta. Okay? So, tinitingnan natin as insulation power factor. Normally, dito sa Pilipinas, we call it insulation power factor kasi yung ginagamit natin ito. Cosine theta. Resistive current divided by total current. Doon naman sa Europe, sa probinsya namin, na Juby, dito ba si Juby? Tangent delta yung ginagamit namin doon. IR over IC. Pareho lang yan siya, sir, ha? Pareho lang yan ng purpose. Pareho lang yan ng value na tinitingnan natin. Pero baka kasi may mag-compute sa inyo, teka, cosine 45, hindi naman equal sa tangent 45 ba? Siyempre, sir, may sariling limit. Hanggang 20% lang sila magkapareho. Okay? Kung titingnan natin sa graph, sana nandito sa presentation ko, yan ang graph na hanggang saan sila magkapareho. Hanggang saan sila magkapareho. Ang matindi niyan kasi magkaiba ng standard si American at saka si European, di ba? So sa Europe, normal yung ginagamit nila yung tangent delta, and then sa US naman ang ginagamit normally is yung cosine theta para sa power factor. Okay? So pareho lang yan sila hanggang 20% or hanggang dito pala sa aking presentation hanggang 16%. Okay? Normally, pagka nag-IPF tayo, insulation power factor, ang unang tinitingnan natin dyan, sir, is yung value ng capacitance. Bakit kaya tinitingnan natin yung value ng capacitance? Una, ang capacitance, sir, very important kasi yan ang magsasabi sa atin kung tama ang connection mo. Kasi kung halimbawa, malaking transformer ka, tapos high to low yung kinukuha mo, and then nakakuha ka ng around nanofarad, ang galing, di ba? Hindi pwede. Mali ang connection mo na yon dahil masyadong mababa yung iyong, masyadong mataas pa ang iyong capacitance. Dapat around picofarad. Okay? So dito, ginagamit din yung capacitance, sir, kaya mahalaga siya, ginagamit din yan para ma-determine mo kung meron kang geometrical deformation. Kung merong deformation yung iyong transformer, no? Kaya ginagamit din yan. Ngayon, kung nakikita nyo, sir, doon sa ating IPF, may mga UST, GST mode, di ba? GST guard. Ginawa yun, sir, para sa ating convenience. Para hindi ka na maglipat-lipat ng kable. Naman, sa kabila naman. Ganun, sir, no? Hindi. Ginawa yun para sa convenience natin. Dati kasi, yung unang na-invento yan, talagang dalawang kable lang. Isang high voltage, saka isang measurement cable. Papatagusin lang nila yung current doon. Ngayon, meron ka ng red, meron ka ng blue, halimbawa. So, para mabilis, halimbawa, kung ang titest mong transformer ay 3-winding, mas madali na. Okay? So, ito, sir, yung 3 steps ng AC domain o yung frequency domain method. Ang una, o yung ginagawa natin na traditional method, yung line frequency. I-injikan ko yung transformer ko ng 10 kV at 60 Hz lang. Okay? Ito, sir, yung model ng insulation ng transformer sa inyong harapan. Yan ang model ng perfect insulation ng transformer. Kung ginagawa natin yung traditional method na yung 60 Hz, 10 kV, ang tinitingnan natin dyan sa model, itong kakapiranggot na portion na ito, yung line frequency na yan. Wala naman akong sinasabing hindi pwede o bawal yun, sir, ha? Pwede pa rin yun. Walang problema. Pero kung gusto mo ng total picture ng iyong insulation, pwede mong gawin itong full DFR method. So first step, yan yung line frequency, yan yung 60 Hz na tinitira natin ng 10 kV. Pangalawang step, kung kakayanin nyo, meron tayong narrowband DFR na tinatawag, which is from 1 Hz to 500 Hz. So anong ibig sabihin yan? Magkakaroon ako ng information na mahaba na gano'n, no? From 1 Hz to 500 Hz. So later on, sir, ipapakita ko yung mga case study. At meron ding tinatawag na full DFR. Yan na yung 1 mHz to 1 kHz. Kinukuha mo na yung buong spectrum ng transformer insulation. Siyempre, meron pa rin dyan doon pa rin ako sa 10 kV. Wala namang problema, sir. Gawin niyo yun. Walang problema ako doon. Lalo na't nasa Pilipinas tayo. Wala namang yelo dito. Hindi naman tayo nag-i-snow. Okay na okay pa rin ang line frequency. Okay? Pero, etong model curve kasi na to, sir, 60 years in the making. Nagsimula yan noong 1960s. Ang ginawa ng mga scientists, kumuha sila ng mga iba't ibang insulation type ng transformer, ininjikan nila ng low voltage at vinary nila yung frequency. At tiningnan, ito pala ang signature ng magandang papel. Ito pala ang signature ng magandang langis. So hanggang sa nakadevelop sila ng tinatawag nating model curve or master curve. 60 years in the making bago naging available sa market yan. So pag-usapan natin yung line frequency, again, ito yung 10 kV. Normally, ginagawa natin yan, mag-i-inject ako for 1 minute, minsan nga, nagto 12 kV pa, no? Tapos kinukompare ko yung result doon sa standards. At ang sinasabi ng standards, Kung ang iyong transformer ay less than 230 kV, dapat makakuha ka ng 0.5 at 20 degrees. So kailangan i-correct mo yan sa 20 degrees kasi ang limit niya 0.5. So dito sa Pilipinas, kung nakakuha ka ng value ng IPF mo sa 35 degrees, convert mo muna yan sa 20 degrees bago mo sabihin kung pasado or bagsak based doon sa limit ng standard. Kung ikaw naman ay more than 230 kV, dapat 0.4 at 20 degrees Celsius. Kung yan naman ay medyo luma ng transformer, ang tinitingnan natin dyan ay 1% at 20 degrees Celsius. Yan yung line frequency. Okay? Yan yung 10 kV na ini-inject. At yan yung ating ginagawa o conventional method. Ang nagiging problema lang dito sa conventional method, doon sa mga bansang sa 20 degrees, kasi minsan, halimbawa, negative 15 degrees Celsius sa kanila, ganun. No? Hindi na nagiging accurate yung correction factor na nakalagay doon sa standards. And nakalagay din mismo doon sa IEEE C57 na hindi applicable yung table na ginawa nila sa lahat ng cases or scenario. Kasi may mga scenario nga na masyadong mababa yung temperature, hindi nagiging accurate yung correction factor ng table. Yung halimbawa, yung correction factor, yung sa ganitong value nakuha ko sa 35 times 1.5, ito yung 20 niya. Yung ganun, yung correction factor na times 1.5 na yun, hindi applicable yun sa lahat ng kaso, sir. According sa standard. So dahil doon, ginawa nila itong ITC or Individual Temperature Correction. Ito ay ginawa ng scientist na si Arrhenius, no? Nobel Prize awardee. Binigyan niya ng relasyon yung frequency sa temperature. Paragang matindi yun, Nobel Prize. Kasi, paano mo naman i-relate yung temperature kay frequency? Mahirap. Siya lang. At ginawa niya itong Arrhenius equation. Na ang sabi niya, kapag ikaw, di ba may model curve ka, tapos meron kang resultant curve. Kung gusto mong i-correct, magsishift yun sa kaliwa or sa kanan. Sa kaliwa, kung papalamig. Kung sa kanan, magsishift sa kanan kung papainit. Kung halimbawa, nakuha mo at 15 degrees, kukorek mo sa 20, magsishift yung graph mo sa kanan. Kung halimbawa, nakakuha ka ng graph na 35 degrees, gusto mo i-correct sa 20, magsishift yun sa kaliwa. So, ganyan yung equation na yan. No? Yung sinasabi ng equation na yan. Yan yung Arrhenius equation na tinatawag. So, tandaan nyo, sir, kasi may quiz nga tayo mamaya. Ngayon, yung pagtitester ng AC o yung frequency domain, pareho din naman yan ng AC. Kailangan mong i-short yung primary winding at saka yung secondary winding, naka-short din. Di ba? Para hindi ma-stress yung ating winding. Kapag ka-open yan, siyempre mataas yung current na tatakbo doon sa ating winding. May stress. Tsaka bibirahan mo siya ng mataas na voltahe. So may stress. So dapat naka-short. So dito, ito naman yung dielectric frequency response, yung binanggit ko na kanina, di ba? Yung DFR method natin. So normally, ang ini-inject natin dyan, sir, ay 140 volts or 1,400 volts RMS. And then binavary ko yung frequency from 1 megahertz to 1 kilohertz. Ang kagandahan dito sa graph na to, sir, ito, baka kaya pa kung maano dito. May mga bilog-bilog to, may mga region ito eh. Yan, may mga region na yan. At yung mga region na yan, sir, may kaukulang specific na parte ng transformer. So halimbawa, itong region na to ang tinitingnan mo, maaaring ikaw, yung transformer mo, halimbawa, yung resultant curve ay naiiba, maaaring ikaw ay may moisture na. Kung dito naman nag-deviate sa region na to, maaring meron kang deformation sa transformer mo. At kung dito naman, nag-deviate yung resultant graph mo, ito model curve, sir, kinukumpare mo yung resultant curve mo. Kung dito ka nag-deviate sa bandang gitna, yung oil conductivity mo naman, yung may tama, baka hindi na siya nagre-resist, nagko-conduct na. So, ganun, sir, no? Halimbawa lang. So, oil conductivity yung middle range ng frequency na yon. Okay, so pagdating sa DFR, nagpa-plot tayo, nag-inject tayo ng voltahe, at kinukuha natin yung reaksyon at different frequency para magkaroon tayo ng resultant graph. And then, i-compare natin yan doon sa model curve na yon. Okay? So, ganun, sir, yung DFR method. Ito, case study, sir, para makita nyo paano nangyari. Case study number 1. Meron kaming tines na transformer, 230 kV siya, 100 MVA, ginawa siya 1979, mga 10 years bago ako pinanganak. Parang hindi sila makapaniwala. So, more than 20 years na out of service na. Ang kagandahan dito, bago nila pinatest sa amin yung transformer, pinurify nila. So, yung langis, nandyan sa loob, pinurify muna nila. Diba? And then, 6 months later, pinatest nila sa amin. Ang nakuha naming result, syempre yung connection namin, based din sa IEEE, naka-short lahat, no, 1,400 RMS yung in-inject namin. So, ang nakuha naming result, sir, good lahat. Yung value niya sa IPF at 60 Hz, 0.234. Sa moisture content, weight-to-weight ratio, 0.2%. So, as per assessment ng IEEE, as new. And then yung oil conductivity niya, 0.208, as good as new pa rin. Kalain mo, 1979 na transformer, ang ganda ng insulation. Di ba? Transformer number 2, halos magkasing edad, 1978. So mga 11 years bago ako pinanganak. Out of service na siya for more than 20 years. Ganon din, ang problema, hindi nila pinurify. Ano ang napansin namin dun sa result? Yung IPF mo, medyo tumas lang ng konting-konti. At yung moisture content mo, matindi, 1.8. Pero, yung value na yan, as per IEEE, dry pa rin. Ang oil conductivity, ang medyo obvious, 6.4, at ayon sa assessment, based doon sa standard, siya ay service age o matanda na yung langis mo. So sa makatuwid mga kaibigan, para akong announcer, maganda din gamitin yung DFR, no, para magbigay sa atin ng additional tool at ma-assess natin yung ating insulation o ng transformer insulation natin. Yun yung DFR, sir. Another case study, sir. Okay, sakto lang naman. Another case study, ito yung narrowband. Bakit kailangan kong i-present yung narrowband, sir? Kasi karamihan sa mga tester ngayon na mga multifunction, hindi lang naman Mega, sir, ano? Meron din silang frequency range. Diba? May mga frequency range din sila. Ngayon, hindi nga lang kasing layo nung DFR na unit dahil ang range ng DFR unit 1 MHz to 1 kHz. So normally, yung ibang equipment ng multifunction, nagre-range lang yan ng 1 Hz to 500 Hz. At yung 1 Hz to 500 Hz, yun yung tinatawag natin na narrowband DFR. So ito yung case study. By the way, ito yung picture ni Dr. Diego Robalino, yung member ng committee ng IEEE and SIGRE. No? Sila yung nag-test, sir. So i-report ko lang kung ano nangyari. Alam natin na yung limits ng IPF is 0.5 at saka 1%. Diba? Yan yung limit natin. So una nilang ginawa, nag-test sila ng bagong transformer. At ano ang naging frequency response ng transformer na yan? Kung mapapansin nyo, flat na 0.2 yung power factor niya hanggang 1 Hz. Ganyan ang signature ng bagong transformer. So nag-test sila ng transformer number 1, ibang transformer naman. Ang nakita nila sa transformer number 1, pagdating doon sa 1 Hz, 0.8. Kung ikukumpara mo doon sa new transformer, 0.2. So, anong nangyari? Kung ang tinitingnan natin ay yung 60 Hz lamang na ginagawa natin sa kasalukuyan na conventional method, eto, yung 60 Hz lang na to, masasabi nating pasado pa yan. Di ba? Kasi 60 Hz lang yung pinagbasihan natin. So si transformer number 1, anong ibig sabihin ng 0.8 na yon? No? Kung line frequency lang ang titingnan, yung 60 Hz, 0.27, pasado. Diba? Kasi yun lang naman ang available na equipment natin. So dyan, sa 0.7 na yan, ano yan? Bakit 0.7 yan? Sa 1 Hertz. So, tinira siya ngayon ng DFR method. So, they tested the transformer with full DFR method and ito yung naging assessment. Sa moisture mo, 2%, sa conductivity, 1.14. So conclusion dun sa service age transformer number 1, na-conclude siya na matanda na talaga yung transformer. Pero dahil ginamitan siya ng full DFR, indicates ng good insulation pa rin, yun nga lang, talagang medyo matanda na talaga. Kasi low oil conductivity na siya. Okay? Ngayon, nag-test naman sila ng pangalawang transformer. Ang nakita, wow, yung 1 Hertz zero, halos 4.5%. Bagsak na bagsak yung 1 Hertz niya. Pero, kung titingnan mo lamang yung line frequency na yung ginagawa natin na tradition, baka ipapasa pa natin to eh. Oy, 0.5, okay pa yan. Diba? 0.5 naman ang limit. Tapos 1% sa ano. Diba? Ipapasa ko pa to kung kung conventional method lang ang gamit ko. Pero doon sa 1 Hertz, obviously, ang layo niya kumpara doon sa bagong transformer, which is 4.0% ang lumabas. So anong ibig sabihin ng 4.0 niyan? So ginawa nila, nag-conduct sila ng full DFR method at nakita nila, wet na yung transformer, basa na. 3.4% weight-to-weight ratio. At ang coil conductivity mo, 8.87 na. So, yan ang nangyari, sir. No? So, dito, patunay lamang na yung line frequency could be misleading sometimes. Diba? So, additional tool ito. Hindi namin sinasabing wag niyong gawin yung line frequency. No? Gawin pa rin natin. Binibigyan lang namin kayo ng bagong idea, bagong method na pang-insulation testing ng AC method. No? So dito nakita siya na wet, solid insulation, and high oil conductivity. So ayan siya, sir. No? Yan yung kanyang difference. Ngayon kung tatanungin nyo ako, nasa standards na ba, sir? Makikita nyo, sir, yung narrowband DFR or yung 1 Hertz sa SIGRE Technical Brochure 962. Ito mismo, sir, kinat ko lang. Huwag nyo na lang sabihin. Kinat ko lang. Yan, sir, yung kanilang nakalagay mismo sa standard. Ito yung limits mismo ng 1 Hertz. Nasa standards na. Kahapon may tumawag sa akin na taga-NGCP, sir, nasa standards na ba yan? So pinakita ko sa kanya, yung bagong labas na standards, 2025. Sariwang-sariwa pa. Nandun yung limit ng 1 Hertz value. Okay? So yan, sir, sa transformer. So baka magtanong kayo, paano naman sa bushing? Ganun din, meron din kaming ginawang case study doon, isang mabilis na lang. No? Ito yung criteria sa bushing na ayon sa standard, 0.4 tsaka 0.5. Diba? So, subukan natin. Siyempre, kapag bushing na, sir, yung tinitest, normally, ang ginagawa natin dyan, kino-compare natin yung bushing ng phase A compared sa bushing ng phase B compared sa bushing ng phase C. O kung YN yan, pati yung N, i-compare natin. So ganyan, sir. Patatakbuhin lang natin yung frequency, narrowband DFR. So dito sa example na to, sa Carolina Dielectric Maintenance Testing Company, ang ginawa nila, ang limit lang nila ay 100 Hz to 1 Hz. So dito naman, nakita nila si phase A, si phase B, si phase C, walang problema dahil pare-pareho sila ng signature. Okay? Meron ditong isa. No? Meron dito sa India yata to, if I'm not mistaken, nakalagay ito mismo, sir. Itong diagram na to, nasa standard to, C57. So dito, tinira nila ng 60 Hz or yung line frequency. Nakakuha sila yung OIP, Oil Impregnated Paper 13, 0.32, 0.28, 0.31, 0.3. Walang naging problema. Pero, kung titingnan mo yung 1 Hz nitong isa, yung OIP2, di ba? Pagdating ng 1 Hz, ang layo niya. Oh. So, nung kinuha yung value ng 1 Hz, si OIP2, 1.58. Kung line frequency lang ang pagbabasihan ko, walang problema. Pero, ito na nga yung additional tool, nung tinira ng 1 Hz, naging obvious yung problema ng OIP number 2. Anong ginawa? Nilabas nila sa service yun, yung bushing na yon, binuksan, at ang nakita nila, X-wax. Yan, sir. Yan mismo yung nakita. Yan yung actual picture, at yan din yung nakalagay sa standard na picture. Okay? So, kaya ano nila yung 1 Hz. Yan, sir. Kaya nagawa nila yung 1 Hz. So, kung dati, meron tayong conventional method na 60 Hz, 10 kb, baka pwede nyo idagdag itong narrowband DFR, just add additional 4 minutes, magagawa nyo na yan. No? Makakaroon na kayo ng dagdag, tawag dito, tool para ma-assess yung insulation. So, yun lamang po. And yun na ang aking presentation. Kung gusto nyo ng copy ng aking presentation, sir, scan nyo lang tong QR code na to at para ma-share ng aming marketing sa inyo. May question, sir? Thank you so much, sir, sa pakikinig. No?
Any question po? And please state your name and your chapter.
Magandang hapon po, Sir Mike.
Yes, sir. Good afternoon po.
Victor Toledano from Asia Brewery, NLC. So, very interesting yung topic po. No? May tanong lang po ako kasi na-mention yung aging eh. Marami na akong nag-age dito, no? Anyway, number one question ko po is, paano nyo ba ika-classify ang aging transformer?
Yung aging ng transformer, sir.
Kasi na-mention nyo kanina eh. Ito po ba, naglagay ako ng 2017 na transformer kasi meron ho kami 1980s pa eh. Hanggang ngayon, ginagamit pa namin eh. 34.5 po yun.
Correct, sir.
Tapos naglagay kami ng mga, nagdagdag pa kami ng way back ng 2019. Transformer ulit.
Correct, sir.
So, tumatakbo pa rin yung 1980s namin. So, paano ko siya i-classify as aging?
Oh, parang aged na siya, no? Paano?
Yung bang 2019 ba, kukonsider ko na ba as aging na rin? Kasi, 6 years ago na eh.
Kung bibilangin mo yung taon, talagang, ano na sir, no? Lumampas-lampas na. So, ganito kasi yan, sir. Pag nagtitest tayo ng IPF, normally may mga correction factor doon sa temperature natin, di ba? Isa sa requirement para makapag-test ka ng IPF, ilagay mo yung year of manufacture ng transformer mo, yung temperature mo, at saka yung oil temp o yung insulation temp. Okay? Ngayon, di ba na ilagay mo na yung taon? So, paano nila ina-assess as age? Kung maganda yung naging resulta ng iyong, kung maganda yung naging resulta ng power factor mo, na nakita nila na 1979 pa yon, halimbawa.
Kung nakita mo, meron pa ng
parang sasabihin nila sa iyo, as good as new, kung maganda yung naging resulta. Kung medyo pumasok doon sa limit na, tama, kasi 1978 naman na yan, talagang dahil sa katandaan niya na, i-automatic niya yun, ilalagay na aged na yung transformer mo. So normally, sir, doon sa value at saka sa year of manufacture nila binabase yung assessment doon.
So,
kung halimbawa naman, sir, meron ka 2025 lang, tines mo. Pero yung value niya, sasabihin niya sa'yo, yung value na to, pang ano na to, pang matanda na to. Ganon sasabihin niya. Baka naman, bago yung transformer mo, pero yung inilagay mong langis, matanda na. So, ganon, sir. May range, sir, ng ano, may range ng value, yung inaano nila sa, base doon sa year of manufacture ng transformer.
Doon sa...
Yun lang, sir, hindi ko alam yung formula noon, paano nila kino-convert yun.
Doon po kasi parang na-mention nyo kanina, meron ho kayong tines na bago yung langis. Okay ang result. Tapos ata yung...
New transformer? Yung new transformer?
Di ko alam kung tama yung pagkaka-recall ko. No? Then, isa kanina naman, nag-test ka naman, yung naka-stack ba na langis, yung hindi nila pinurify.
Yun, sir. Hindi nila pinurify.
So, lumabas para may problema.
Correct, sir. Dahil nakita nila doon na yung conductivity nila is around 1.8. No? So, yun nila na-classify nila yon as service age, yung value na yon.
So, ano po nirecommend
Tama
nyo?
yun, sir. Sir, paki-ano nga, sir. Pa-view ulit ako noon. Tama, nako. Ito pala, sir. Ito yung range. Makikita pala dun sa presentation ko, sir. Sorry. Okay, sorry. Pabalik lang, sir, ng konti. Nandun, sir, sa aking slides pala yung value noon. Nung age. Yan. Yun. Yan, sir. Kung ang iyong conductivity ay 3.7 to 37 picosiemens per meter, categorize na siya or ano na siya, service age. Sa conductivity, sir.
So, regardless kung anong year sa manufacture.
Sir. Correct, sir. Kasi maaaring bago nga yung transformer, nilagay mong langis luma na. So, ganun. Pero kasi conductivity, sir, sa langis kasi.
So, I mean, kasi kung basically langis naman, hindi naman napapalitan yan eh. Alam ko, pinupurify natin from time to time.
Correct, sir.
So, dun sa nakita dun sa, sa result kanina, ano ni-recommend? Doon sa hindi pa
Purify, sir.
Purify. So, niretest ba uli after nung may...
Yes, sir, niretest yan.
So, umokay na po yun.
Okay yun, sir.
So, basically, yung transformer ko is good as new.
Good as new na ulit. Kahit 1978 siya.
I see. So, sa amin, 45 years old na.
Ganun, sir.
Pero i-retire na namin.
Hindi, ang ginawa nila doon, sir, hindi ko lang mabanggit yung pangalan. Ang ginawa nila doon, ginawa na lang nila na parang training ground, ganun. Okay. Tapos yun yung ginagamitan nila ng mga experiment nila, pagtetest ng mga bushing, doon nila ginagawa lahat sa transformer na yun.
I see.
Mga experiments nila.
Then, ito hindi ko lang na-pick up kanina kung bakit. Kasi meron tayo 60 Hz, di ba? Typically
sir.
na.
Yes, sir.
So, ano bang merong special sa 1 Hz nga pala? Hindi ko na
Okay. Naalala niyo, sir, nung pinresent ko yung DC method, di ba? Kapag nag-inject ka kasi ng DC, halimbawa positive side, pag nag-inject ako ng DC, positive, tapos maintain na siya sa positive kasi DC nga siya. Pagdating kasi ng DC, ang nakikita mo doon ay polarization current at saka capacitive charging current. Pagdating kasi ng 1 Hz, ano ba yung 60 Hz? Kapag 60 Hz, 60 Hz. Ibig sabihin 60 cycle per second. Pero ang 1 Hz, ano ba? 1 Hz. Nagbabad ka ng 0.5 seconds sa positive side or negative side. Yung babad na 0.5 second na yun, nakita niya yung polarization and yung capacitive charging current reaction. Okay? Ang 60 Hz kasi, ang isang cycle mo, 60 cycle. Isang seconds mo,
0.0167 per
Correct. Samantalang ang 1 Hz, 1 Hz. Meron kang 0.5 seconds na bumabad ka ng DC, halos DC na yon, no? 0.5 seconds sa positive side. And doon, nag-react yung polarization current mo and capacitive charging current mo na parang DC.
Okay. So, yung 1 Hz, for example, nagbabad ako ng 0.5. Basically, parang sabi na approximately 0.5 seconds.
Correct,
diba?
correct.
So, 0.5 seconds lang yon.
0.5 seconds. Oh, yung isang half cycle, yung half cycle.
Half cycle yan, 0.5 seconds. Then babalik ulit siya sa 0, ganyan.
Correct, sir.
Hindi ba parang mas ang DC mo, di ba, 60 seconds? Matagal yun.
Matagal,
Nakababad
sir.
yun.
Correct.
So, hindi ba mas parang okay naman, parang lumalabas na, di ba parang mas okay na itong DC na to kasi 60 seconds naman siya nakababad. Kumpara dun sa 1 Hz. Hindi ko alam kung anong meron sa 1 Hz.
Ang nangyari kasi, sir, yung DC mo, antayin mo pa ng 60 seconds yun, di ba? So yung 1 Hz mo, hindi naman aabuti ng 60 seconds yun. Tsaka AC method siya. AC method siya. Frequency method siya. Yung DC method siya. So isang side lang yung tinitingnan niya. So ganun, sir.
Doon ba sa may 1 second, hindi ko na kailangan maghintay pa ng 60 seconds na nakababad?
Hindi, sir. Hindi.
Okay.
Hindi, sir.
Sabay, nakakainip din maghintay ng
Kumbaga, ang gagawin nun, sir, mag-i-inject siya ng 140 volts. Diba? 140 volts. Uunahin niyang tirahin yung 500 Hz. Ilan yung power factor ko sa 500 Hz? So lalagyan niya ng tuldok yun. Ito, naging 0.5. Ilan yung power factor ko sa 400 Hz? Lalagyan niya ng gagraph niya yun, sir. No? Igagraph niya yun. Ngayon, ang sinasabi ko dun sa 1 Hz kanina, dun kasi nagre-react yung moisture banda or hindi naman sa 1 Hz lang. Mas visible yung reaction ng moisture doon sa 1 Hz. Ngayon, ganito kasi ang paliwanag dun, sir. Normally, ang moisture mo ay negative charge. So kapag sa positive cycle ka ng 1 Hz, mas nagre-react yung moisture mo papunta dun sa positive side na ng test probe mo.
Hindi ba pumuputok yung moisture ko kapag ano? Parang cavitation sa mga bomba.
Nagmo-move yung charge
Nagmo-move
papunta
lang
dun
siya.
Correct, sir.
Okay.
At yun yung tinitingnan na reaction doon. Mayroon mathematical formula, sir, pero hindi ko lang kabisado. No? Yung pag nun. Parang naka Fourier transform yung calculation nun, sir.
So,
hindi ko lang kabisado, sir. Ayoko nang ng math eh.
I cannot don't know na lang.
5 years na, sir.
Sige po. Anyway, maganda po yung presentation.
Yeah, thank you, sir. Thank you, sir.
Then yung sa meager part kasi basically 2 probes lang ako eh.
Yung guard, sir.
Yung guard hindi ko ginagamit. Anyway, tama nga naman, pag pasado naman, hindi ko gagamitin yung guard. Okay
Correct,
naman
sir,
pasado
correct,
na eh.
Oo, pasado na.
Salamat po.
Thank you, sir. Thank you.
Okay, so any more? Okay, so may question tayo sa online.
Ay. Nako, sir. Sino yan, sir?
Yes, basahin ko po. May question tayo sa online kasi very interesting po yung topic natin, Engineer Mike Inville,
Sir, wala
Evangelista. So from Joseph Bermoy, ano po yung standard service life ng transformer as per standard?
Standard service life ng transformer. Wala pa akong nakitang ganun, sir, na limit ng transformer standard life. No? Kaya ginagawa natin yung testing para makita natin kung okay pang gamitin yung transformer. No? Kasi ang nangyayari dyan, kaya walang naging standard life, kasi hindi talaga maiwasan na nagkakaroon tayo ng mga glitches, tawag doon. Yung mga, halimbawa, nagkaroon ng fault, nag-trip yung vocals mo, o kaya nagkaroon ng earthquake, nagkaroon ng, hindi talaga natin ma-determine, sir. Ang meron sa standard, sir, is yung recommendation ng maintenance tuwing kailan. Yun ang meron. So halimbawa, nagkaroon ng tripping yung differential mo, nakalagay din doon kung ano-anong mga test yung gagawin. Tapos kung halimbawa, light maintenance ka, dapat every 2 years mo gagawin tong test na to. Kapag ikaw naman ay intensive maintenance, dapat every year. Kapag ikaw ay talagang critical maintenance, every month tinetest mo na. So yun yung mga nakalagay sa standard. Pero wala pa akong nakita na ito yung standard life ng transformer.
Yeah.
Sorry.
Baka life expectancy yung tinutukoy.
Baka life expectancy. Wala pa, sir, ako.
Okay. Sige po. And then mayroon pa from online participants natin, from Engineer Dan Abelia. What is the failure mechanism at 60 Hz for a transformer that has failed at 1 Hz, considering that the transformer operates at 60 Hz?
So, kagaya nung sinabi ko kanina, sir, doon sa 1 Hz, mas doon nakikita yung mga contaminants in moisture, lalo na yung moisture. Kasi nga, yung moisture normally, negative charge yun. So, yun, sir, moisture or contaminants ang makikita mo lalo sa 1 Hz. Yun yung kanilang sa study.
Okay. So, last na to. Iwan ko kung mayroon pang humabol sa online. Mayroon pa ba?
Bakit sa akin na daming tanong, sir?
Very interesting kasi yung topic, no? Sige, from Ronald Godoy. Sir, pag ang IR results ay pass, but yung IPF mo ay bagsak, ano po ang assessment po ninyo? I-energize po ba? I'm talking about instrument transformers.
Pero parang imposible namang mangyari na pasado yung IR mo, tapos bagsak yung IPF mo. Pwede pa, bagsak yung IPF. Oo nga, no? Pag pasado yung IR mo, tapos bagsak yung IPF, Yun, sir. Kung ganun ang mangyayari, yung IPF mo, gawin mo yung 3 steps na binanggit ko kanina. 60 Hz, narrowband DFR, at saka yung full DFR. Kasi medyo, depende kasi sir sa IR na ginawa mo. Ano bang ginawa mo? Polarization index o the electric absorption ratio o regular lang na IR? So, minsan kasi, yun nang nangyari na confusion, kaya nag-recommend kami ng AC domain or yung frequency domain. Kasi yun sir yung mga confusion na nangyayari. Minsan doon sa IR mo, dahil 60 seconds mo lang tinira, hindi siya, kumbaga pumapasa siya kahit na hindi ano. Kaya medyo confusion sir doon sa IR eh. At nagkaroon ng recommendation sir doon sa SIGRE Technical Brochure 962, no? Nagkaroon doon na yung IR medyo confusing, kaya nire-recommend nila yung AC or frequency domain. Nasa 962 yun sir yung recommendation. Lalo na kung yung insulation mo ay bago at mataas yung polarization. Okay? Nasa SIGRE Technical Brochure 962. Nandun sir yung recommendation sa transformer na if IR could be confusing, we recommend to do IPF or dissipation factor method.
Additional lang dun sa question kasi parang siguro paano malalaman kung nag-fail siya
Si
sa
Sir Elmer
IR.
pala sir, yung aming mega sales.
So, paano siya nag-fail sa IR? Kasi ang talagang recommendation ng Mega is trending. So, kung magre-rely lang tayo sa isang value, hindi siya reliable. So, kailangan talaga multiple values over a period of time to determine talaga, to make an assessment dun sa IR value. So, mahirap mag-judge kung one
Correct,
value
sir.
lang rather than trending value.
Oh,
Mas magre-rely ako sa trending value than one value alone. So, yun lang.
Yung
additional.
nabanggit ko nga kanina sir, yun yung best na analysis ng result is yung trending. Pero meron pang isa sir na pwede. Halimbawa, wala akong previous test result anong gagawin ko? Ang gagawin mo sir, hanap ka ng twin unit. Ibig sabihin, same year of manufacture, same specification, same loading, i-compare mo ngayon silang dalawa. Okay? So yun sir, twin unit. Thank you sa mga nagtanong sir ha. Sana nasagot ko.
Okay, so I think ito na yung last no sa online natin. So from Engineer Guillermo Ambrosio, totoo po ba na yung ibang latest transformers ngayon ay alloy na yung windings instead of copper? So
Lahat sir? Ano sabi niya sir?
ang mga transformer po ngayon ay
May mga
alloy
ganun
na
sir, may
instead
mga
of copper.
ganun. May mga ganun sir siguro para gumaan. Depende sir, kaya kailangan nating i-test 'yon. Lalo na yung efficiency niyan, no? Kailangan na. May copper, aluminum. So meron talagang ganun sir. Either aluminum or copper.
Kasi
Winding
ngayon
yan, sir, tinutukoy
may
niya.
alloy na yun, no? Yung mga distribution transformer.
Hindi core ha.
Oo. Yeah. Baka distribution transformer yung nire-refer nito. Oo. So, okay, dito po sa crowd, mayroon pa bang question? Okay. Sige sir, state your name and your chapter po.
Sir, good afternoon.
Sir, good
lang sir,
afternoon.
Carlito Amba Jr. from Subic Power Generation Corporation. Sir, kasi yung transformer namin is hermetic type, magkaiba dun sa conservator. Ngayon, may kasi kami dati sa kumpanya namin na mababa yung IR namin, pero yung direct restraint ng oil, okay naman. Ngayon, ang ginawa direct restraint, mataas, mababa IR.
Yung oil sir, dahil
Oo, direct restraint ng oil, mataas. Ngayon, ang ginawa muna nung pinatanggal yung oil, tapos pre-process, nung na-process na siya, nung binalik, walang oil, mataas naman yung IR ng transformer. Walang oil, sir, ha? Tapos nung binalik yung oil, bumaba ulit. Ngayon,
pero yung oil dielectric strength mo, mataas.
Mataas pa rin, sir. May posibility kaya yun, sir, na ganun, tama kaya yung pagkakuha ng testing?
Yun, sir, yung isang may mga factors na nakaka-apekto dun, sir. Una, yung connection mo. Tingnan mo kung tama, o kung pareho lang, gumamit ba tayo ng guarding? Kasi baka may surface leakage ka nang nakuha dun sa kabilang side. Ano ba yung tinest mo, sir? Low voltage to high voltage to
Oo,
low?
sir. Oo,
High voltage to
low.
low. So,
Tapos
dapat
pati
wala.
yung kable, sir, papuntang labas.
Pero ito yung isipin mo, sir. Pag nag-inject ako sa primary at ang kinukuha ko yung leakage papuntang secondary, hindi lang naman langis yung tinitingnan ko dun eh. Kasi ang insulation in between, meron akong papel, meron akong langis. So ngayon, kung ang ginawa mo, kinumpare mo lang siya doon sa oil testing, paano yung sa papel? No? So yun, sir. So dapat i-confirm mo yun, sir, sa IPF o tangent delta testing.
Thank you, sir.
Yes, sir.
Okay, so meron pa ba? Going once? Twice? I think wala na.
Ay, salamat.
So, okay, that ends the Q&A portion of Engineer Evangelista's presentation, no? So, that I'll proceed ng awarding.
Okay, so let's award the plaque of appreciation to our speaker. Okay, so we call on our TCPD chairman and our co-chairman, Engineer Joseph Darren Claire Solicar and Engineer Bong Ibrada, to award the certificate of appreciation and the plaque. Okay, let me read the citation. 50th Annual National Convention and Expo 2025 awards this certificate of appreciation to Engineer Michael M. Evangelista for imparting valuable insights as technical resource speaker on the topic transformer insulation testing, time and frequency domain methods during the technology trends in electrical engineering, present and future innovations in conjunction with the 50th Annual National Convention and 3 Expo 2025 with the theme IIE. Okay, so excited na ba lahat na umuwi? Okay, so as we wrap up the third day of ANC, let us call our TCPD chairman, Engineer Joseph Dan Claire Solicar, for his closing remarks.
Ayos. Okay, good afternoon, everyone. Hello. Good afternoon. Okay, so, of course, to the Board of Governors for 2025, headed by our Golden National President, Engineer Alberto Herrera Jr., and of course, the member of the committee, TCPD team, I would like to request
the member to stay in front. First, the Vice Chairman of the committee, Engineer Ronaldo Ibrada. And of course, Engineer Moises Mali II. And of course, Engineer Jonathan Medalla. And of course, Engineer Ryan Anthony Umali. And of course, we'd like to request our TCPD staff, Miss Jen Sanchez. And we have also members sa TCPD. So, kami po ang nagplano, no, from the Mega Webinar up to sa activity po natin until Saturday. So, we have also the Vice Chairman, Engineer Manny Di Guzman. Then we have the member Maximo Adarlo. Then we have Sandro R. Villarosa, Mark Gerald Santiano, JC Leydon Lipata, Botany Casey and Sibilia Briones, and we have Amelia L. Compas, Melanie B. Rances, Juan Paulo M. Tolentino, Oscar F. Heronelia, Luel B. Ratilla. Then we have Eliseo Tanagan. Then we have Rolando A. Mariano Jr. and Rolly Clamor. And we have also from Meralco, Emmanuel Jan Aliada. And lastly, Rajima Yasmin Balingao. I would like to request to give pwede po natin palakpakan po natin sila lahat. For the job well done, no? So, yung TCPD team na kami po yung yung mga webinar natin, seminar start from January up to last October, and we have coming seminar in Legazpi, December 6. Okay? Thank you, guys. Thank you very much. Okay, today marks the second and final day of the highly anticipated virtual Mega Webinar, an event organized and hosted by TCPD Committee in celebration with 50th anniversary of IIEE. So this webinar is a special part of a series of activities designed to commemorate this significant milestone, and it has been extended beyond its original schedule to provide participants with an in-depth exploration in the latest technological trends and innovations, shaping the future various industries. So the primary aim of this is extension to equip you as participants, whether you are in the company, industry leaders, engineers, with up-to-date knowledge and practical insights. So throughout this two-day event, we have strived to create comprehensive platform where ideas, expertise, and innovative solutions are shared freely. I would like to take this opportunity to express my heartfelt appreciation to all of you, the dedicated members of IIEE. Lagpakan po natin yung sarili po natin. So the unwavering teamwork of the committee as well, meticulously planning and commitment to excellence have been instrumental in bringing this virtual conference. Okay? So coordinating sessions, inviting, so yung ginawa po namin, we invited speakers, no? From abroad and of course locally. So yung TCPD po, no? TCPD committee po ang gumagawa. And of course to the distinguished speaker, of course special mention to Engineer Michael Evangelista, no? So during the Southern Luzon Caravan, siya po nagkaroon po kami ng hands-on training sa transformer testing, sa motor at iba pa. So maraming salamat sir, Michael Evangelista. To our participants,
sa mga participants dito, no, attending physically, and of course, sa virtual attendees, tuning in from various locations around the world. Okay? Thank you for your active engagement, enthusiasm, and willingness to expand your horizons. Over these 2 days, your participation plays a vital role in making this event lively, meaningful, and impactful, and your curiosity and eagerness to learn what drives success of such initiatives. Of course, special mention to the gratitude extended to our resource speakers, these industry experts, leaders volunteered their valuable time and shared their deep knowledge, insights, and experiences to enlighten all of us. So their willingness to contribute to the advancement of the collective understanding is truly appreciated and greatly enhances the quality of this program. Lastly, I would like to acknowledge to the sponsors. Their continued support and generous contribution have been fundamental in making this event not only possible but also successful. Their commitment to fostering innovation and education within the industry demonstrates their dedication to growth and development. Together, through the efforts of everyone involved, organizers, speakers, participants, and sponsors, we have created an enriching event that inspires innovation and collaboration. So we look forward to continuing this journey of knowledge, sharing the technological advancement in future endeavors. Thank you once again for being part of the memorable celebration of progress and excellence. Mabuhay po tayong lahat. I would like to request everybody to stand up and give some just clap your hands, and because of our success of our 2-day Mega Webinar. Maraming salamat po, and this is Engineer Joseph Darrick Solicar, the Chairman of TCPD. Good afternoon.
Thank you, Sir Joseph Darrick Solicar, for that message. Before we officially end, we remind all participants on site and online to accomplish the evaluation form. Your feedback is vital in improving our convention sessions. Okay, so thank you and see you again tomorrow. So, ready na yung mga coat and tie natin, mga formal attire, no? Na-plansa na. Okay, so this has been your host, Engineer Moises Mare II. Thank you, and we hope to see you again tomorrow for the continuation of the 50th Annual National Convention. Mabuhay ang lahat. Mabuhay.